Hello and a very good morning, ladies and gentlemen. I warmly welcome you all to 4th International Conference on Energy Efficiency and Conservation. This is a flagship event of Center for Energy Research and Development, UET Lahore. CERAD organizes this conference in spirit of providing opportunities and platforms, ladies and gentlemen. This year, the conference is somehow different in its being and conduct, as it is happening virtually considering COVID impact. So powered by Punjab Energy Department and in collaboration with IEEE and PICA, we are organizing this conference on Cisco WebEx tool. So ladies and gentlemen, before introducing you to the power-packed guest and the power-packed list of the opening ceremony, let me begin in the name of Allah, the most beneficent and the most merciful. I would humbly request Mr. Nurul Wara to please recite few verses from the Holy Quran.
بسم الله الرحمن الرحيم والشمس وضحاها والقمر إذا تلاها والنهار إذا جلاها والليل إذا يغشاها والسماء وما بناها والأرض وما طحاها ونفس وما سواها فألهمها فجورها وتقواها قد أفلح من زكاها وقد خاب من دساها كذبت ثمود بطغواها إذ انبعث أشقاها فقال لهم رسول الله ناقة الله وسقياها فكذبوه فعقروها فدمدم عليهم ربهم بذنبهم فسواها ولا يخاف عقباها.
Thank you very much, Mr. Nurul Wara. Ladies and gentlemen, this was Mr. Nurul Wara reciting few verses from the Holy Book and enlightening our minds and our souls. So let's pay our homage to the country we belong to. Let's pay our tribute to the land of pure. Let's rise for national anthem, ladies and gentlemen. पाकिस्तान के सारे शहरों जिंदा रहो पाइंदा रहो रोशनी और रंगों की लहरों जिंदा रहो पाइंदा रहो. A huge round of applause, ladies and gentlemen, for the host country, amazing country like Pakistan and its amazing people. So ladies and gentlemen, now it's time to introduce you to the amazing guest list of the opening ceremony of 4th International Conference on Energy Conservation and Efficiency. Without any further delay, let me introduce you to Professor Dr. Waqar Mahmood. Professor Dr. Waqar Mahmood is Director Center for Energy Research and Development. He's leading the management as well as the technical committee of the conference. We are really honored to have you with us. A huge round of applause, ladies and gentlemen, for Dr. Waqar Mahmood. And next up is MD Pika, Mr. Adnan Mudassir, ladies and gentlemen. A round of applause for MD Pika. Pika is Punjab Energy Efficiency and Conservation Agency and one of the proud partners of 4th International Conference on Energy Conservation and Efficiency, ladies and gentlemen. And we have with us Professor Dr. Fazal Ahmed Khalid. He has got extensive experience of research and academia. He's Sitara Imtiaz bearer. He's ex-Vice Chancellor, University of Engineering and Technology, and he's currently serving as Chairman, Punjab Higher Education Commission. Professor Dr. Fazal Ahmed Khalid, ladies and gentlemen. Thank you very much, Dr. Saab, for being with us. And now quickly moving forward, we have Chairman, Prime Minister Task Force on Science and Technology, our distinguished guest, Professor Dr. Ataur Rahman, joining us all the way from Karachi. Thank you very much, Dr. Ataur Rahman, for being with us. It's an honor to have you with us, sir. And now let's quickly moving forward towards the chief guest of today's opening ceremony, ladies and gentlemen. We have with us Honorable Minister for Energy, Government of Punjab, Mr. Muhammad Akhtar Malik, ladies and gentlemen. Thank you very much, Minister Sahab, for being with us. A round of applause, ladies and gentlemen, for the distinguished and chief guest of today's opening ceremony. Now, let me just introduce you to the wonderful audiences with us. We have got engineers, academic experts, scientists. We have got people from public sector, building designers. They're all gathered here to meet, discuss, explore, and exchange ideas in the rapidly developing domain of energy efficiency and conservation strategies. Now, I would humbly request Professor Dr. Waqar Mahmood, Director, Center for Energy Research and Development, to please share his thoughts.
Bismillahirrahmanirrahim. Welcome to the 4th IEEE International Conference on Energy Conservation and Efficiency. I would like to welcome Chairman, Prime Minister Task Force on Science and Technology, Dr. Ataur Rahman, Minister for Energy Punjab, Dr. Akhtar Malik, Chairman, Punjab Higher Education Commission, Dr. Fazal Khalid, Vice Chancellor, UET Lahore, Dr. Mansoor Sarwar, Managing Director, Punjab Energy Efficiency and Conservation Agency, Mr. Adnan Mudassir, dear distinguished speakers, researchers, faculty members, Assalamu alaikum and very good morning. On behalf of Center for Energy Research and Development at the Kala Shagagu campus of UET Lahore, I would like to welcome you to this opening ceremony of the International Conference, 4th in the series, on International Conference on Energy Conservation and Efficiency. This conference we are organizing in technical collaboration with IEEE Lahore chapter, with the Industrial Automation subgroup of IEEE Lahore, also Energy and Power Society of IEEE. This conference is 4th, as I mentioned earlier, is in a series, and we are organizing it online, virtually, this year. We have received more than 115 papers in this conference, and with the help of a technical committee, which comprised of experts from different countries around the world, about 80 experts, they reviewed and evaluated the submitted papers. And they found about 31 such papers which got selected for publication. So this makes the conference about 27% selectivity of the submitted papers. In this conference, this time we have multiple technical sessions that are arranged in the conference, which are going to be happening today and tomorrow. We have distinguished speakers, lectures speakers from IEEE as well, who are participating from around the world. And then we also have technical sessions that comprises the paper presentations by the individual researchers who have successfully submitted their papers and got their evaluation completed and got selected. In this conference, we are bringing up the areas of energy conservation, which is particularly important for a country like Pakistan, where we have cost of energy rising almost on a very consistent basis. The cost of energy, since it is mainly produced through the fossil fuels, is not affordable to many homeowners in many households in the country. Similarly, it becomes unaffordable for industry at some point. So therefore, energy conservation are very important strategies that can be deployed, whether you own a household, or you have a commercial organization, a plaza or a factory, or you are managing agriculture farms. In all respect, we need to conserve energy, not only for saving cost, but also saving the important resource for the nation. The conference is organized by the Center for Energy Research and Development, which is a center that was established in 2013 in new campus, UET Lahore. And the Government of Punjab Energy Department provided the initial seed funding for establishment of various labs in the center. We have established a number of labs which are operational, and they were need of the hour and state of the art. For example, we have established a research lab which is primarily focusing on the validation and testing of the components which are important for the solar systems deployment in Pakistan. Very important feature of this year's conference is the exposition that is arranged on a digital forum. We have 20 plus industries who are collaborating with us, who are showcasing their products and their services in the energy conservation domain. And in addition to these 20 industries, that include industries from Pakistan, from Germany, from China, we also are exhibiting research projects and lab activities which are related to the energy conservation within Al-Khwarizmi Institute of Computer Science and Center for Energy Research and Development. Yes, I will take the opportunity to thank the hardworking teams of Al-Khwarizmi Institute of Computer Science and working very closely with Center for Energy Research and Development, who have worked tirelessly day and night during the last 2 months to make this event such a great success. Starting from the coordination committee, which worked under Mr. Kashi Bashir, we started working 6-7 months ago. Then we have the technical program committee, which is led by Dr. Ghalib, who worked very hard to get the reviews done on time and have the highest quality papers selected and get presented today. Then we have the program management committee, which is led by Dr. Amir Mahmood, who is organizing the program today and tomorrow in helping out with the team members. Then we have the exposition committee, which has put together a wonderful virtual exposition of the industry as well as the projects, which is headed by Mr. Rehan Tariq. Then we have a team which helped in putting together the industrial interest in our conference. In there, I should mention the name of Mr. Farhan and Mr. Imran Shah, who brought in the relevant industry and also the effective members of the panel who will have the discussion conducted tomorrow. And then we have also a team which has worked under Mr. Akil Babar in providing the services throughout here in the conference 2 days. Then we have a networking team which is headed by Mr. Mudassir Khan, who is helping out with Mr. Rashid in providing all the facilities. Team with Mr. Muhammad Ali, who's worked in bringing in the international experts for our invited talks and the keynote speakers. The experts are also made available to the panel. And I'm hoping that Mr. Muhammad Ali together with Mr. Imran will also moderate our panel. And then last but not least, a very special thanks to Mr. Hamza, who is providing support from WebEx. He's a fellow from IEEE and volunteering to help us out in technical aspect in using the WebEx tool for this conference. I thank you all.
Thank you very much, Dr. Waqar Mahmood, for being with us and giving an insight of what is going to happen in this conference. Ladies and gentlemen, this was Dr. Waqar Mahmood. A huge round of applause for Director, Center for Energy Research and Development. Now I would request the team to please play a few glimpses of what is going to happen in 4th International Conference on Energy Efficiency and Conservation, ICECE 2021. Let's have a look at the conference, ladies and gentlemen. I would would request the audience to please put your hands together for the management committee who have really worked hard and put up a great show. Quickly moving forward, we have our distinguished guest with us, MD PICA, Mr. Adnan Mudassir, who is waiting. Mr. Adnan Mudassir, I would request you to please say a few words regarding 4th International Conference on Energy Conservation and Efficiency, sir.
Assalamu alaikum and good morning. My name is Adnan Mudassir. I'm working as Managing Director, Punjab Energy Efficiency and Conservation Agency. I welcome all the guests and participants to the 4th ICEC conference. Assalamu alaikum and good morning. Just wanted to give you a brief of what PICA is doing in Punjab. PICA was established in the last quarter of 2015. And since then, we have been working on the energy efficiency and conservation in the province of Punjab. The main role, the objective with which PICA was established was the demand side management and to steer the energy efficiency and conservation program in the province. Since then, we have implemented various projects, and there are various projects which are in the pipeline as well. Some of the key initiatives that we have taken so far includes Energy Conservation Building Code. We have developed the Energy Conservation Building Code for the province of Punjab, and now we are proceeding for the implementation of the same in the province. And we believe that once this code is implemented, the buildings will be 30% more energy efficient, which means they'll be using 30% less energy as compared to a conventional building. Similarly, we are doing various solarization projects. One of the key initiatives that we have taken for solarization is ESCO model. This is the first time that we have introduced energy services companies model in the province, whereby all the capex, the capital cost, initial investment is being done by the private sector, and all the performance risk is being taken by the private sector as well. Our first project in this regard was solarization of UET Lahore, which was 1 megawatt, and that have already been completed, up and running. Now we are going for expanding this program to all the universities in Punjab. We are talking about around 60 megawatts of clean energy from the solar systems, and all being done through an ESCO model. Similarly, we are trying to introduce this ESCO model to the rest of the autonomous bodies in the province as well. In parallel to this ESCO model, we are solarizing public institutes from the development funds as well. One of our key projects is through the World Bank. We are doing a Punjab Green Development Program, which the objective of which is to promote green energy. Similarly, we have established the first AC testing lab in the province in UET Lahore, Center for Energy Research and Development. We are doing a retrofitting project as well. We have been working on the standardization and labeling in the country, which is again being done for the first time in Pakistan. We have already standardized and labeled the fans. We have developed the MEPs for lights as well, motors as well. ACs are in the pipeline, ovens are in the pipeline. So our target is to standardize and label all the electric appliances which uses the energy. So these are the key initiatives, the projects that we have taken so far. And we believe I believe that this conference provides a good platform for awareness, for bringing in new technologies, for bringing in stakeholders together to promote the energy efficiency and conservation. Thanks a lot. Thank you very much.
Thank you very much, Mr. Adnan Mudassir, for being with us. Ladies and gentlemen, this was Mr. Adnan Mudassir, MD PICA, and PICA always stresses and focuses the energy efficiency and conservation, and he was speaking his heart out. Thank you very much, sir, for being with us. Quickly moving forward, ladies and gentlemen, we have got Chairman Punjab Higher Education Commission as one of the distinguished guests of the opening ceremony. He has got extensive experience of research and academia. He's Tara Imtiaz Bearer. He's ex-Vice Chancellor, University of Engineering and Technology. Ladies and gentlemen, a huge round of applause for Professor Dr. Fazal Ahmed Khalid.
Thank you very much, Rehan, and Bismillah Rahman Rahim. First of all, let me congratulate the Director KICS and CERAD, Dr. Waqar Mahmood, and his team for organizing this energy conference, energy conservation. And this is a very important topic and a big challenge as far as Pakistan is concerned. And organizing a fourth conference in a row provide opportunity to all the stakeholders to come and join and share their experiences from the national organization as well as the international speakers who are going to come and deliver their different lectures and share their research experience. As we all know, ladies and gentlemen, that energy is a big challenge for Pakistan. Its generation, its conservation, its management, policy making, decision making. And in this context, role of universities have become very important and critical. And we have to see that these conferences not only provide opportunity for networking, but also come up with the recommendations which are very important for the different stakeholder organizations and government to follow up, to formulate better policies, to give relief to the masses, and also look at the modern developments in the field of energy, the new trends which are happening from renewable to many new developments to storage, where batteries have become very critical in terms of sustainable solutions as far as energy storage is concerned, which is an international, I would say, hot topic for research. At the same time, we have to see that how conservation can be made because megawatt saved is better than megawatt generated in terms of cost. So from that perspective, I'm sure that in terms of policy making, engaging the young faculty members, students, and all stakeholders on a multiple thematics which are being planned for this conference would allow all the participants a good opportunity, a good learning experience, and sharing views at this international forum so that we can recommend good policies and recommendations from technical point of view to the government and various stakeholders. Pakistan in recent time has done well. NICA is doing well at federal level, and PICA is also doing well. Who the stakeholders? IEEE is also engaged as important stakeholder of this conference. And certainly UET has made a big mark as far as technology and research and engineering programs are concerned. So I wish all the best to the organizers, the Vice Chancellor, the Director, KICS, CERAD, where a lot of new labs and facilities have set up for the certification of various appliances. And as a result of that, I'm sure we move a step further in terms of implementation and ensuring the quality of our appliances at the same time take measures for the conservation of energy. Thank you so very much, and may God bless.
Thank you very much, Dr. Saab, for your kind words. Ladies and gentlemen, this was Chairman Punjab Higher Education Commission, a very dynamic personality, Professor Dr. Fazal Ahmed Khalid. A huge round of applause must be there. Now, quickly moving forward, we have a very, very special guest who is joining us all the way from Karachi and who has arrived on a very special request of the Management Committee. I would request Chairman, Prime Minister Task Force on Science and Technology, and he's also ex-Chairman Higher Education Commission. I would humbly request Professor Dr. Ataur Rahman to say a few words.
I would like to congratulate the organizers of the IEEE conference on energy conservation and related areas. And this is being organized by UET Lahore in collaboration with a number of organizations in the Khwarazmi Institute and CERAD and other institutions. So this comes at a very timely manner because energy conservation has become extremely important. There has been an enormous amount of focus on alternative sources of energy, such as getting energy from wind or water or solar. But at the same time, we must also focus on trying to use the latest technologies so that we can benefit from proper energy conservation methods. I think there are several aspects of this that we need to focus upon. Firstly, it is the materials that are used for energy conservation. There have been enormous advances in various materials that are now available, which help to conserve energy and prevent wastage. These are smart materials, they are intelligent materials, there are a whole series of composite materials which have come forth, and the awareness of these materials and their proper use is therefore essential. A second aspect is the advances that have taken place in design buildings and houses. And we must benefit from these advances so that the proper designing of the structure of the houses as well as the internal layout is done to ensure that there is proper energy conservation. The third area is, I think, the use of artificial intelligence, which is now also coming in the vogue to ensure that energy wastages are minimized and houses and buildings are smart and are able to conserve energy to a maximum amount. So the integration of artificial intelligence into the design process has become of critical importance. Along with this, I think it is important that the government policies are properly enforced. We see that many recommendations come out from conferences. Some of them may be eventually absorbed and laws promulgated, but where we in the developing countries often lag behind is in the implementation of these laws in building construction and in house construction. So the approvals of the designs and approvals of the construction and final approval of the constructed building must not be given until it is ensured that the proper laws exist and that they are followed. So I think these are four major aspects in the field of energy conservation. And with the rising price of energy, and it has become even more important that we focus on the latest tools that we have available in terms of design, in terms of materials, in terms of the use of green energy wherever we can to prevent environmental pollution, and in terms of government policies and laws which should be acted upon effectively. I would like to congratulate the organizers of the conference again for holding a very timely and important conference, and I hope that the recommendations that come out from the conference will be taken seriously by the various countries participating in this event and will be then embodied in laws and in the implementation processes. Thank you.
Thank you very much, Professor Sahab. Professor Dr. Ataur Rahman, ladies and gentlemen, Chairman, Prime Minister, Task Force on Science and Technology, thank you very much for taking some time out from your busy schedule. Now, quickly moving forward, without any further delay, it's time for Chief Guest, ladies and gentlemen. I would humbly request Honorable Minister, Energy, Government of Punjab, Muhammad Akhtar Malik Sahab. Dr. Akhtar Malik, ladies and gentlemen.
बिस्मिल्लाहिर्रहमानिर्रहीम। मैं सबसे पहले तमाम पार्टिसिपेंट्स को जिन्होंने इस कॉन्फ्रेंस में शिरकत की उनको मुबारकबाद और वेलकम कहता हूं, और यूईटी जिन्होंने ये इवेंट ऑर्गेनाइज किया उनको भी मैं सराहता हूं कि दुनिया में जिस तरह एनर्जी की ज़रूरियात से सारी दुनिया वाकिफ़ है और एनर्जी एफिशिएंसी का जो एक नया बाब खुला है उस पे इस तरह की जो कॉन्फ्रेंस है वो मुल्क की इकॉनमी पर दूर रस नताइज मुरतब करेगी। मैं इनकी खिदमात को भी सराहता हूँ और हमेशा ये बढ़ चढ़ कर हिस्सा लेते हैं। और इसी के साथ साथ जो हमारी सेंटर ऑफ एक्सीलेंस जो काला शाह काकू में यूईटी ने शुरू किया था, यूईटी के तावन ने एनर्जी डिपार्टमेंट ने शुरू किया था, वो आज तकमील के आखिरी मराहल में है और उनको जब मुकम्मल हो जाएगा तो उसका फ़ायदा अभी भी हमारा सूबा पंजाब उठा रहा है, बल्कि पूरे पाकिस्तान से लोग उससे फ़ायदा उठा रहे हैं। जब मुकम्मल हो जाएगा तो एक इंटरनेशनल इदारा हमारा बनेगा जहां से तमाम लोगों को हम एनर्जी के बारे में मालूमात भी दे सकेंगे और जो एनर्जी एफिशिएंट अप्लाइंसेस हैं उनके बारे में उनको गाइड भी कर सकेंगे और उनकी हेल्प भी कर सकेंगे। जैसा कि पूरी दुनिया में अब दुनिया एनर्जी एफिशिएंसी और एनर्जी एफिशिएंट जो अप्लाइंसेस है उसकी तरफ जा रही है, तो ये बर्निंग इशू है पूरी दुनिया में, और मैं समझता हूँ कि इस पर इम्प्लीमेंट करके हम ना सिर्फ एनर्जी बचा सकते हैं बल्कि इकोनॉमी पर इसका बहुत बड़ा इम्पैक्ट आ सकता है। इसी के साथ जो पंजाब हुकूमत ने हमारा एक पंजाब एनर्जी एफिशिएंट एंड कंजर्वेशन एजेंसी के नाम जिसको मुखफ़फ़ में पीका कहते हैं, एक इदारा बनाया हुआ है, वो दिन रात इस पर कोशां है। और हमने कुछ 4 बड़े इदारे जो है रिट्रोफिटिंग उस पर कर चुके हुए हैं, और जिनके बिजली की मद में करोड़ों की अमाउंट में बिजली की सेविंग भी होती है और बिजली के बिल की बचत भी होती है। तो इसी को हमने आगे लेकर जाते हुए एक लेजिस्लेशन भी करने लगे हैं कि हमारी जो पुराने इंस्ट्रूमेंट लगे हुए हैं, जैसे एसी है, हमारे फैंस हैं, हमारे रेफ्रिजरेटर्स हैं, और जो इलेक्ट्रॉनिक जो हमारे आलात हैं, उनको हम रेट्रोफिट करके उनकी जगह पर एनर्जी एफिशिएंट आलात नस्ब करके हम एक तो बिजली की जो कंजम्पशन है वो कम हो जाएगी, और उसके जो बिजली के बिल में जो कमी आएगी वो भी उसको आगे लेकर चल रहे हैं। और पंजाब के जितने पुराने हमारे इदारे हैं, हम इंशाल्लाह उनमें ये रेट्रोफिटिंग भी करेंगे और लोगों को आगाही भी देंगे, और इस पर हम लेजिस्लेशन भी कर रहे हैं।
Thank you very much, Dr. Sahab, for joining us. Ladies and gentlemen, this was Dr. Muhammad Akhtar Malik, Honorable Minister for Energy, Government of
Dr. Antavish, please switch on your camera and as well as your microphone. Dr. Antavish, are you online? Please switch on your camera and your microphone as well. The rights have been given to you.
Can you hear me?
Welcome everyone. Can you hear me, everyone?
Yes, we can hear you.
Can everyone please hear me?
Yes, we can hear you, sir.
Okay, thank you very much. Assalamu alaikum and good morning. My name is Dr. Tabish, and I'm working as assistant professor in chemical engineering department UET Lahore. On behalf of the organizing committee, I welcome all of you to the 4th International Conference on Energy Conservation and Efficiency. Today, I will be chairing this session, and this session includes only the invited talks. This is the first session of this conference, and this session is focused on energy storage technologies and utilization. In this session, there will be 4 talks. Each speaker will have 40 to 45 minutes. And at the end of the talk, we will have some time for the questions. Attendees can write the questions in the question answer dialog box. Our first speaker is Professor Syed Mofizul Islam. He is currently the Dean of the School of Engineering, Information Technology and Physical Science at Federation University, Victoria, Australia. Prior to joining Federation, he was the John Curtin Distinguished Professor in Electrical Power Engineering and the Director of Center for Smart Grid and Sustainable Power Systems at Curtin University. He received the Dean's Medallion for Research at Curtin University in 1999. He has published over 300 peer-reviewed technical papers in this area of expertise. His research interests are in renewable energy, condition monitoring of transformers, wind energy, grid integration of renewable energy sources, and smart power systems. Professor Islam was a member of steering committee of Australian Power Institute and a founder member of WAEESA board. He was a board member of IEEE Power Academy in Australia. Today, we are inviting a professor on an invited talk for a research journey on frequency response analysis for power transformer fault detection, modeling, experimental, and field experience. Without any further delay, I would like to invite Professor Syed Mufizul Islam to present his talk. Professor Mufizul Islam, can you please hear me?
I can hear you. Can you hear me? Can you hear me? No?
Yes, sir, we can hear you.
Can you hear me now?
Mufizul Islam, you can
yes,
turn
sir.
on your mic.
You can hear me now?
Yes, sir, we can hear you.
Okay. I'm trying to now turn on my video.
I can hear you. Thank you. You can turn on your mic and present your presentation.
What about my video?
Yes, sir, please turn on your video as well and
Yeah, so
share the presentation too.
Okay, so I'm just going to open up the presentation and see if you can see that presentation. So here. Okay. Are you able to see my screen? Hello?
No, sir, we are not able to.
Okay, so I'm trying to find out the sharing. Where's the share button? This looks a bit different. So okay, so how do I share this screen with you?
Sir, at the bottom center, you can see the share button. Can you see it on your screen? At the bottom center.
So what does it look like? Because normally the share button is like a box with an arrow on the top. This is
exactly.
But I don't have that here.
Okay, let us fix it.
Yeah. I have a keyboard sign which has toggle subtitles. Then I have a screen button. Then I have a zoom button and see all slides, and then a pen. Why is that? What is my WebEx control?
Sir, kindly check now that if you can see the share button now. Can you see it?
No, I'm not able to see the share button now. So, okay, here, I think I can see, okay, I think I know what the problem is. Okay, so here it is now. Let's see. This should come to your screen now.
Yes, sir, we can see it now. It's perfect.
You can see it now. You can see it now, right?
Yes, we can see it, sir.
Okay, so I think I can start, but I...
And sir, please turn on your camera as well, so we can see you too.
My camera is on, but... okay, so,
but you are not visible from our side?
No, so... I'm just seeing that where the other controls are. Again, the controls disappear. Okay, no.
I guess, sir, you should start with your talk.
Yeah, I guess so. I think I should start with my talk because, yeah, okay. So thank you very much for inviting me to the ICEC Conference 2021. I've been listening to the opening ceremony all through, and I also congratulate the organizers for putting on this conference. And I think that the program that I have seen, it looks like there is an excellent lineup of talks and invited talks. So this is my opportunity, and it's my privilege to speak to you on my research experience on frequency response analysis, which is in short known as FRA techniques for fault detection in power transformers. I know the conference is on energy efficiency, but of course, without power transformer, power and energy cannot flow into the networks. And therefore, it is a very important portion of the network. These are very expensive transformers as well. These are very high voltage and high power transformers. And if they fail, they not only create havoc and causes blackout, but also causes a lot of collateral damages and cost involved. So it is important that we look into the health of these transformers and how to detect particularly any faults early so that major and catastrophic could be avoided. So transformers failure can be attributed to mainly 4 key factors. There are electrical reasons such as partial discharge, arcing, through faults, over voltage, short circuit current, lightning, etc. Thermal, which caused by overloading, short circuit current, insulation decomposition, evolution of gases, etc. Mechanical, which are very important, and that is the movement of the windings, the buckling, and the free buckling and forced buckling of the winding, loss of clamping pressures, etc. Now, this is an area that traditionally have not been picked up by traditional techniques of detection of faults in power transformers. And FRA came in the 1990s for an effective solution for this mechanical fault detection. I will be concentrating my talk in this topic. There are also chemical reasons for transformer failure, such as furanic compounds due to cellulose decomposition and deterioration, acid formation, sludge formation inside transformer. Transformers, particularly in the developed countries, because their network is quite well developed, some of the transformers are actually very aged. So if you look at Australia and New Zealand, many transformers are in the range of 36 to 40 years. And that means that many transformers are actually operating beyond their design life. However, they're so expensive and so difficult to replace. Therefore, it is beneficial that we maintain this transformer. On the right-hand side of the screen, you can see that in the Western Australia, which is one of the states in Australia, and its entire population of transformer, it almost looks like a normal distribution. But from where you can see is that majority of the transformer are approaching the end of their design life, and that is in the 26 to 30 years, 30 years being nominally the design life of power transformer. So IEEE conducted a transformer survey on oil immersed transformers, and it actually came up with a statistical graph, and it shows that the risk and the insulation degradation of transformers are directly correlated. So if your insulation is degrading, then you are actually at risk of failing that transformer. Transformer failures are not that many, but I think IEEE figured out that 0.00625 is a statistical rate. What does that mean is that in a fleet of 100 transformers, 10 will have problems within the next 16 years. So it is not very common, but these are very large transformers, 200, 300 MVAs, and if they go, they take down a city or a town with it. So therefore, this is supposed to be a very reliable device. Failure rate is 3 times higher in utilities with poor maintenance program. So in transformer, going back into what it looks like, okay, so those who haven't seen, I have on the screen for you, what it looks like is what it appears there is basically is a set of winding. So transformers basically has got a core, it's got an inner winding and an outer winding. So the inner winding is the LV and the outer winding is HV. And you have got these windings that you have, you are basically have to insulate them from the core and from the earth, and the failure of these disc type winding transformers can be caused by mainly radial faults or axial faults. So on the top of the screen, what you see is the force that is created inside a transformer that is radial. So where does this force come from? It comes from the currents which typically when short circuit currents happen, these forces are even larger, and they could be 120 times a second that this winding will be trying to vibrate, double the rate of power frequency, because power is twice the voltage frequency. So appropriate design radial support mechanisms are required. Radial faults are prevented by thicker low voltage conductors. On the bottom of the screen, what you see, and you see the direction of the force and etc., which is basically causing the axial force in the transformer. Again, they are created due to voltage and current stress. On the right-hand side bottom, you can see that when you have got a failure or a radial fault in a transformer, how the winding can be damaged, and that basically means that that expensive piece of device is out of service, and you can't operate that anymore. So we tried to model this transformer in finite element, and this is just to demonstrate to you that the failure occurs due to two kinds of forces. One is buckling, force buckling, and the other is free buckling. The force buckling mainly causes on low voltage winding, which is, you can see there, which is basically is supposed to be round, but it is not. You can see the helical shapes, and that's basically because that the winding has gone through buckling, force buckling. On the free buckling, it actually happens on the outer winding, which is the high voltage winding, and you can see that how outward forces will cause that free buckling. So the mechanical failures of transformers due to not just radial fault, but it can also be due to axial faults. And the axial faults are basically that when the fault are applied from the top to the bottom of the winding, and these faults can be prevented by proper design of clamping pressure, support structure, that resistance to compressive forces. So this is something that the manufacturer will have to take care of. Okay, so what it is that frequency response analysis was seen and established as a credible tool to detect mechanical faults in transformers. Historical developments of frequency response analysis is something that I'm going to show here. That in the 1978, a gentleman, a couple of gentlemen, they're named Dick and Irvin in the United States. They actually developed sort of a sweep sinusoidal frequency response to detect some sort of a winding movement. But that didn't progress too far. In the 1994, another couple of gentlemen, Jensen and Michelson, they published a paper reporting on a transfer function model using FRA to essentially relate transformer faults to FRA. The first study in Australia was done by a group at the University of Newcastle Advanced Technology Center, and I was actually leading that team, and other team members were there, Mark Stace, Barry Finlay, and Professor Gerard Ledwidge. And what we did is essentially in 1996, we created a device, basically a laboratory setup that comprised of a oscilloscope, a computer with a GPIB card, and a signal generator that would actually create a sweep frequency. And you can see on the screen on the left that how the high voltage and the low voltage winding, so the input and output voltage could be measured. Well, in 1996, that was the setup. But today, Dobel has established a commercial equipment, and that is well available. And in 2020, that device looks like what you see. The advantage is that you can actually run an automatic sweep using the Dobel device now, and you can do a frequency response analysis in maybe a couple of hours. In 1996, it took us a lot of time to actually generate a frequency response sweep. So what does the sweep looks like? So the sweep looks like this. Okay, so this is the result of our handmade device and what we did with a 3-winding transformer, 132, 66, 11 kV, and there are 4 of them in the service. One of those transformer that when we did test transformer A2, let's call it, and you see that all the frequency response, the frequency response being, okay, so let me explain that. So on the y-axis, what you see is the 20 logarithm of V out over V in. So we put a voltage in, and we get a voltage out. And we measure the two voltages, and we take the phase difference between the two. So we have a magnitude and a phase. So here is what you see is frequency from 0 to 2 megahertz in that range. In the 200,000 or 200 kilohertz, in that range you see the frequency response. Now that transformer looks like all the three windings are actually in agreement pretty much, and therefore we can say that this transformer is quite good. However, when you do the same thing to the A1 transformer, the first of the cab of the rank of those four, you actually see that there is a shift in resonant frequency for the A phase compared to the B and the C phase. And that started at that point of time, we just knew that something is wrong. And when this transformer was opened up, and we saw that the transformer A phase actually have moved. So therefore, we established that this technique is working. Now, we also did test on another transformer, T1. And when this transformer T1 was tested, we actually saw a severe disagreement between the phase responses. And what actually happened with this transformer that the A phase was much larger than the other two phases, the frequency shifts, and therefore we investigated this transformer, and we figured out that this transformer actually had a severe bending of a disc that almost was touching the core of the transformer, and that caused a significant a disaster was about to happen. If that winding hit that core, then that would have happened. But we prevented that, and it was sent to the manufacturers, and they then fixed that. So and then to establish that the effect of axial faults, what we did is that we created intentionally some clamping pressure differences, and we can see that when we did that before and after clamping, how the frequency response graph would look like. So this is interesting, and this was basically opening up the whole subject of power transformer fault detection when mechanical faults have happened inside the transformer. Mechanical fault in the sense that the winding have moved, the clamping pressure have moved, etc. Okay. So then we started continuing with our research on this. And while in the beginning, when we did that, we had a way of only saying, looking at the graphs, that, yeah, there are some differences in three phases, and therefore something is wrong in that transformer. But we're not happy with that. We tried to find out that exactly to quantify that fault. So we continued our research. We started modeling that transformer. So we developed a low frequency model. So what you can see is the low frequency model on the top. You develop the mid frequency model, and then on the right hand side bottom corner you see the high frequency model. The difference between that, in the low frequency model you have to take in the effect of all resistance, conductance, inductance, and capacitance. In the mid frequency model, we are mainly interested in conductance and inductance and capacitance, whereas in the high frequency, the transformer acts like a voltage divider. So therefore, only capacitors are need to be modeled. So that is when we did that modeling, and you remember that graph that I showed you earlier, which is also on the screen, we actually figured out, and applying some system identification technique, whereby we did some signal processing, and we came up with the parameter identification. And we saw that the phase inductance was 978 microhenry compared to 28.5 and 27.5 in the healthy phases. So you could see that by looking at that graph and now using that information and doing some analysis on it, without have to open up the transformer, we can have an indication of where the movements are. So the inductance showed that huge movement in the winding. So there is a saying that inductance can be measured by tape. So that means that when the winding elongates, the henries, microhenries starts to increase. Okay, so that was line fault detection using frequency response analysis, and people were then saying, well, you have to take out the transformer and then do the test, and this actually causes downtime, and it's not the best way of doing things. So there was some very early work started in Germany and at Siemens, and what they started to do is basically they were waiting for a surge on the electricity system to arrive at the transformer, or maybe switching on and off that transformer, and they created basically like a switching surge on the transformer, or an impulse on the transformer that arrived from light. But they have to wait for that, and they started recording the information, and then later on signal processing, they could get the transfer function. However, that's not really a very good way of doing it, because you actually have to wait for such a surge to arrive, and this is may not coincide with when you would like to do that test. So what are the big challenges in online that people couldn't do it so far, and what are the challenges? The challenges is that because you're looking at up to 10 megahertz worth of, or at least meaningfully up to 2 megahertz worth of information, so you need a high frequency CT that could actually act linearly over that range. You also need a signal to noise ratio improvement so that all your signal processing hardware and software actually can manage that noise. And the bushing or other type of coupling arrangement so that you could actually couple the high voltages and download information. And correlation of FRA and faults is another thing that we needed to do, and reduce magnetic and electrical field interferences. You're required to do this so that you could do online FRA. So to be able to do online FRA, we continued our work on this domain now. And the figure that you have on the screen essentially is showing the different components, and that how you have to couple your signal generator into the winding, basically a sine wave sweep from 0 to 2 megahertz. And then you download the output signal, and then you create the voltage transfer function, and you create the voltage transfer function, and you get your transfer function to do what you have to do. So one of the important thing is the bushing. So on the screen you see that that's the bushing of a transformer, and we needed to model that, and we needed to create an equivalent circuit of bushing. So we continued with the bushing test, and we created that bushing, and you see at the bottom there's an ABB bushing, and we tried to again do same thing as a frequency response of the bushing to actually create to have an idea about the parameters of this bushing. So and then we could get the parameters of the bushing through such a test. And then we started researching on developing a high frequency current transformer, and we use a ferrite core. And after lots of designs and testing, we came up with this ferrite core transformer, which basically remain flat in response from 20 to 2 megahertz range. So that basically means that now we have a device where we can actually use to download information at low to high frequency. Once we had these equipments in our hand, we then started to develop a transformer frequency response online. And we didn't have a transformer, but what we had is a damaged reactor, ABB reactor. The reactors basically are inductors, but they're high voltage ones, so they have got the winding insulation. So therefore, it resembles the transformer winding. So what we did is then we used that reactor, and using our equipment, we created a test setup in Western Power Lab in Perth, Australia, and we did that frequency response. And essentially, what you see is the various frequency response graph on the screen, and you can see that that the graphs actually have got different shades. Some are pink, some are magenta, some are purple and black, and they basically are indicative of when we are able to change the parameters. Because we had that damaged reactor, we could actually feel free to further damage that reactor. So we attached further additional parallel capacitance, series resistance, parallel inductance, series inductance, and etc. to various portions of that winding. And we started to see that because of those changes, we actually have changes in the frequency and in the graph of the of that reactor. So we then started to have a feel of how much change in those parameters causes how much change in the frequency shift, so that we could actually eventually move toward creating a standard on frequency response and analytical tools. So, and then we had to, because offline we didn't carry any load, so now we had to make sure that, okay, what is the impact of loading on the transformer? So what we did is that we took that reactor and we loaded that reactor. Basically, we short-circuited the secondary of the reactor and changed the voltage uh, high current flows in the winding. So you can see that that actually shows that how different load level actually causes the different load level causes the different frequency responses. Okay, so now having that in our mind, what we started to do now is develop analytical model and analytical model of transformer and model it in finite element. And our objective was to see that in finite element, could we establish this radial and axial faults further, and can establish the frequency shift versus the parameter change further. Because in software, you could do this much easier. So you can see that thing there. On the left hand side, you see the bushing of the transformer, and the right hand side where you see actually that that's the model of the transformer. And this is our signal generator where we send the frequency sweep. And then, of course, here is it where we measure the output. So this is the finite element model of a transformer and the bushing, and this is actually the finite element generated transfer function. So with that, what basically you see that that this is just one thing, is that if you change the permittivity of the medium within the transformer by 2%, so 2%, 4%, and 0%, which is healthy, you see how you start to see at the high frequency range, right, about anywhere between megahertz to 3 megahertz range, you start to see a lot of variation in the frequencies, and they give us a good indication of permittivity change. So you can practice this with inductance, capacitance, and I'll show you the results, some of the results later. But I think that was a very good introduction toward the establishment of parametric identification. Then we started doing this, move away from switch frequency to actually an impulse. So a low voltage impulse is where we moved next. So basically what we did is that we had a nanosecond pulse generator. We applied a pulse to the transformer winding, which is that winding there. And this is the pulse that we send, the negative pulse. And this is actually what you see is a healthy transformer and a faulty transformer. So you can see now that how so what we did is, you see, so we applied that nanosecond pulse on the winding, and we measured using a high frequency CT or a Rogowski coil, the current. And so therefore this is the current waveform, and that's the voltage waveform applied here. So now if we take the voltage by current, we actually get the impedance transfer function. So what it is, then we started to do this is the practical setup at the lab, and I'm going to show you now the results of that. So basically, this is the amplitude of the pulse applied. That is the current. This is the setup on the left, and so when we did the transfer function, you see that is how the transfer function looks like. So we see that there are lots of noises in this transfer function measurement. So one of the challenges was that we had to use a hyperbolic case transform to remove the pulse shape noise from this. And when we applied that filter, this is how the transfer function looks like. It's much cleaner. And therefore, it allows us to meaningfully interpret the online transfer function. Okay, so going back again to that finite element modeling, what we did is that we actually did a radial fault calculations by using the various faults are shown here, and this is the model that we use that you can see on the right hand side, and basically what you see here is that when we change the inductances, the capacitances from low voltage to high voltage, or from high voltage to the low voltage to core, we start to see that by changing the parameters, we see a significant change in parameters if the buckling amount is changes. So here, what we are trying to do is trying to establish a percentage of buckling or free buckling with the change in the capacitance or inductance or capacitance and inductances, which are the main variation that we see. So basically, then we came up with a table, and that basically says that in high voltage and the low voltage winding, this much frequency changes would occur, and this is where on the right hand side you can see on the table that the delta F, which is due to various radial deformation, how much changes in frequency could occur. Okay, so therefore what we are going is basically trying to establish a feel of looking at the frequency change. We can come and say that, okay, this much movement in the winding actually has occurred through the knowledge base that so far we are trying to develop and we have developed. By the way, all these have been published in IEEE, so people interested can look at it, and some of the references are given in the slides as well. Then we move on to doing the same thing with axial faults, and there's similar technique. And this is basically that when you have axial fault in transformer, this is how the flux distribution in the transformer will change, and or they will change a significant amount of with the flux, significant amount of leakage inductance, mutual inductance. Therefore, they affect seriously through the axial faults. Through the axial faults, we then started modeling using our frequency response data and the finite element result, that how we can now build a mathematical model so we can then manipulate this and basically finance our research. And you can see that using the equations lambda equal Li and the equation for mutual inductance and the resistance, you could actually then model the inductance and inductances and mutual inductances in the transformer by using the finite element software. You could do the same using the Q equals CV equation and the energy equation half CV square. You could actually then model in finite element and have a feeling of those capacitances formed between interwinding, series capacitance, shunt capacitance between the winding, etc. The various capacitances are shown in the figure. And then I think when you use that information and then you try to create changing the parameters and by changing the parameters, what I mean is that you can see at the bottom left that 1%, 3%, 5% change, this small change in mutual inductances or capacitances as shown on the right, you see that how the frequency response starts to change. Basically, what we are doing is using the frequency response technique to have a feel of transformer faults without have to open the transformer, without actually have to remove the transformer from service with an online technique. I just want to started doing some more research into this, not FRA, but it is another technique called a VI technique, and I'm going to only spend a slide on this. So essentially, this is a transformer model everybody knows, and the phasor diagram. And basically, if you take the V to the difference between the two voltages that you measure, and you and you download the current input current or primary current, you actually then come up with a graphical solution, and that is shown on the figure. The delta V is the voltage difference between the input and output, and the current actually is the primary current you measure. And if you then take every point on the voltage difference curve with every point on the current curve, you actually create an ellipse. And that's because that the VI curve gives us a quadratic equation. But the interesting thing is that ellipse could look like a circle, could look like minor and major axis of the ellipse changes as soon as the parameters starts to change within the transformer, similar to FRA. But this is much simpler, and we are now experimenting this in a utility in China, and they are going to give us the data on field trial, and we will be able to then use and fit our theoretical results with the practical results. So basically, it's another technique, also online, not like frequency response, but it is we call it VI curve, and this is also published if you are interested. But look, we are not the only group that is working on this field. There are quite a few other people who are publishing good papers and good work in this field, and I have listed some for you there. But I would like to acknowledge the contribution made by my research associates and students in over since 1996 to today. It's about 25 years of journey on this condition monitoring of power transformer, and in the process, I produced quite a maybe 10 or so PhDs and supervised about half a dozen research fellows. They came from different parts of the world, and I would like to recognize the contribution they made to this research and for me to be able to give to you this presentation. So with that, I'll stop and see that if I can answer some questions. Thank you very much. Hello.
Thank you very much, Professor Islam. We have a question session. So far, we got only one question from our audience. And the audience is interested to know which software you have used for the simulation purposes. Oh, so the different software. So MATLAB is the one that we wrote the code for signal processing, and for finite element work we use ANSYS, and for the pulse shape and the S transform noise cancellation, we use also MATLAB. So mainly MATLAB and ANSYS. These are the two softwares you need, and you could build your own FRA equipment, or these days they are available. It's about $50,000 from Dobel. That equipment, which actually will give you the graphs that you need. But if you want to do research, I suggest that yes, you do that. But I think that you also build your own codes and your own software, so you could carry out research on this. Yes, thank you.
Okay, I have one question, Dr. Tabish.
Can we have around 5 minutes for this talk more? Maybe one more question.
Yeah, sure.
I understand power transformer fault detection is no doubt a much needed area to work on. But at the same time, I was wondering if you can forecast, let's say, future developments on this subject, and maybe some potential problems that require immediate attention.
Oh, so the power transformer, there are lots of work still need to be done. The work is not completed on a power transformer. So, for example, you can partial discharge is an area where the focus is actually detection of voids in winding, imperfection in winding, and then to be able to detect where that fault is within the winding, so you could actually pay attention to. So location of faults, establishing the standards, and for example, the FRA, there is still not a serious standard on FRA, and there is still not a very clear guidelines on if the trace looks like this, what is exactly the fault inside the transformer. There is also lots of opportunities of applying artificial intelligence to the generated data and information. So there is still lots of research to be done in this field.
Yes, thank you very much. Thank you, Professor Sam. We are really obliged to have you on this session.
Thank you. Thank you, and have a good conference.
Yes, thank you very much. With this, I would like to invite our second speaker, and the second speaker is Dr. Fahim Akhtar. Dr. Fahim Akhtar is working as a postdoc research scientist at Water Desalination Center, King Abdullah University of Science and Technology. Previously, he was working in Advanced Membranes and Porous Materials Center at KAUST. His research is over past 7 years, and it revolves around membrane technology and engineering. Particularly, he has worked in the development of polymeric and mixed matrix membranes for gas and water vapor separation, as well in the dynamics of penetrant induced in polymer films. Over the past 7 years, he has authored and co-authored many papers in the top journals of the field. Some of his research has been highlighted in King Abdullah University of Science and Technology Discovery and magazines of North American Membrane Society. Today, we are inviting Dr. Fahim to talk about membranes for high energy efficient separation and sensing application. Without any delay, I would like to invite Dr. Fahim to present his talk. Dr. Fahim, you can unmute your mic and share your presentation. Thank you.
Thank you. Okay, now I got it. So now it's sharing. Okay, can you see my screen?
Yes, we can see it.
Okay, good. Thank you very much for inviting me. I'm very glad. Unfortunately, it should have been happened in person instead of online. But of course, we have to be with it with the current situation. Okay, so I will talk about membranes for energy efficient separations. And particularly, I will focus during this talk, I will focus only on 2 applications because of membranes are well known for many applications, but I will focus my presentation only just for 2 applications. Okay, before I start, maybe many of you know about KAUST. It's somewhere in the middle of desert, around 100 kilometers north from Jeddah, and we are just on the Red Sea shore. So, KAUST is composed of about 4 different research centers, 4 different divisions, and among it, one of it is physical science and engineering, where membrane center and water desalination center fall. Okay, good. So during this presentation, I was just reading yesterday the talks, but some of the major talks which are being delivered. So I think that there are people in this conference from various backgrounds. So for that, I put some membrane fundamentals just to understand what membranes are and what's their principle, and then I will talk about vapor permeation, one application, and another very interesting sensing application. Okay. Before I start my presentation, we want to know, we know that industrial separations, they are being done since more than hundreds of years, and especially not membranes, but other different techniques have been considered for these kind of separations. For example, in US, so this is a totally US energy consumption, which is about 98 quads, and 1 quad is 10 raised to power 15 British thermal unit, which is quite a lot. And if you consider, if you see that among this 98 quads, 45 to 55%, almost 50% energy is consumed only for separation technologies. And among these different separation processes, major separation is in distillation, and then comes, which is about 50%, then drying, evaporation, and some other non-thermal processes. So now one can understand that what's the importance of separation and how much energy is being considered over here. Now, some results, in fact, some very interesting studies, they show that if we use membrane-based separations, so we can reduce at least 90% energy only for distillation. So this clearly shows that a membrane has a big chunk in the separation industry, and especially it has a lot of potential for distillation industry. Okay, now why membranes? Of course, there are many other techniques as well, which have sometimes they look very fancy, and they have even better properties. But why membranes? Because of their modular design. Okay, here in this slide, in this picture on the right side, if you see that these are compact modules, it can treat millions of tons of water and for desalination. Whereas it's just in a very compact room. So this is one of the key feature of membrane technology, that it's compact, and most of the times it's also very light and scalable. Like in my first figure here, I showed you these are very big separation towers. Whereas I think maybe you can see like here. Like somewhere here, there is a membrane unit. So one can understand that how big is the difference between conventional separation processes, conventional separation units, and their footprints compared to membranes. So membranes have very small footprints, and most important thing is their continuous operation, and in many cases they are low in cost compared to other conventional technology. When we say that they are low in cost, of course one can say that sometimes the material which you are using, it's quite expensive, quite fancy. Yeah, that makes sense. But if you know that the material which is coated to have a membrane module, its thickness is very less. So at the end, that cost is nothing. So ultimate cost is the module cost, which is okay, one-time investment, but it's not very high compared to these big towers. Okay, now what is membrane? Membrane is a selective barrier, like this barrier is an example, excellent example of a membrane. So anything. In fact, we can see membranes in our daily life very efficiently. Like here, if you see. Okay, like here, if you see, especially during this time, this mask, this is also an example of a membrane. These capsules, because they are made in a way that moisture cannot trap inside, or some other kind of materials, some other kind of materials like this. So they are also a kind of membrane examples that they preferentially don't allow, let's say, water vapor or carbon dioxide or ultraviolet radiations. So this is a kind of membrane. Now these membranes, they can be made up out of many materials, but mostly they are from polymers, and also inorganic materials can also be used, and a combination of these two, which we call as a mixed matrix membrane, where we can efficiently use the properties of a polymer, which are more processable compared to inorganic materials, which have more diffusion which are more different compared to polymer. So I will talk about these things in next slide. Okay, now before I move ahead, I just want to show you, in fact, one figure of membrane milestones which have happened during the last almost 5 decades. In fact, membrane is known for many years. In fact, for more than 100 years, for different applications. It was being considered for many other things. But why we say 1960 as the key membrane, key milestone? In fact, this was the first time when Sidney Loeb and Soryarajan, they prepared a asymmetric membrane out of cellulose acetate, and here you can see that this is one of the SEM picture in an integrally skinned asymmetric membrane. There is very thin top layer, whereas there is a big finger-like structures which don't offer much resistance. So in fact, this was one of the key milestone in membrane fabrication, and from here we say that the real membrane industry started. And in fact, after that, in 1963, United States and in Germany, they started new startups. That, in fact, they started big grants for these startups like a Millipore. It came at that time, especially for membrane fabrication, and after that, Dow and DuPont, they started their first hollow fiber membrane. Okay, now the second, okay, there are many other things in it, but the second biggest milestone was in 1980, where John Cadot, he prepared interfacial polymerization by combining the two solvents in situ, MPD and TMC, in fact, used, and with that, he could get a very thin layer of membrane on top of a non-movement support. So this was the second biggest milestone in the membrane industry. And from here, real applications started. Okay, before that, ultrafiltration, microfiltration. Size of membranes were being considered after Sidney Loeb and Soryarajan membrane in 1963. But from here, membranes work especially for gas separation and for vapor separation. It started in industrial applications, and later industries like Air Liquide and also one of the biggest research center, MTR Membrane Technology Research. They started these products for especially membranes for CO2 separation and also for vapor separation. Okay, now I showed you some of the key milestones of in the membrane industry. Now, what is how membrane works? Okay, let's say we have a mixture of solute, solvent, or let's say water with some of organic matters. So from feed side, some driving force is applied. Let's say it's from left to right. So either pressure or concentration gradient or chemical potential. So as a result of that, one of the unwanted mixture is one of the content in the mixture which is unwanted. It is retented back, and whereas in the permeate we get a clean product, let's say clean water, or in terms of if it is gases, so we get our required gas, whatever we want in the permeate, whatever we want to clean. So that usually some applications are pressure dependent. For example, liquid separations or organic solvents nanofiltration, and in some cases they are dependent on their chemical potential or concentration gradient, especially in CO2 separation. Okay. Now, before I move ahead, I will just give you one example of gas separation, that how membranes. Okay, the last slide, but I showed that was for a journal. So here I will show you the typical mechanism for gas separation membrane. Like we know when someone talks about membrane, so we in our mind we think, okay, it's a kind of mesh like this, and something is passing, the other thing is not passing. But in the case of gases, let's say we have a mixture of natural gas CO2 and CH4. So we want to separate these two gases. Of course, methane is very range. In fact, one can understand, because the kinetic diameter size of let's say CO2, it's a few angstrom, and also CH4 is also in angstrom. So let's say we have a nanofiltration or ultrafiltration membrane where the pore is very big, so everything will pass. So we cannot separate anything. So here, this separation, especially gas and vapor separation, it's based on solution diffusion mechanism. So what's solution diffusion? In fact, solution as for solubility, so it depends on the gas's condensability and gas and material interaction, whereas diffusivity, it depends on the size of our gases, whatever we are separating, and also the free volume within the polymer chains. And finally, selectivity, which we say sometimes product purity, it's determined as by dividing the fast permeating gas or material divided by the low permeating. Okay. Now, what is this solubility and diffusivity? To understand it, I just want to spend one slide on transport mechanism. Let's say this is critical temperature. Okay, critical temperature, and here we are given two examples of two polymers, PDMS and PTMSP. They are very fast permeating polymers. But just what I want to show you that like here it's hydrogen, nitrogen, oxygen, CH4. So you can see that with the increase in size, usually this critical temperature is increasing, which means that okay, their solubility is increasing. Like this one is a water molecule. So water molecule has almost 647 Kelvin of critical temperature, and it's among the highest soluble gases, if we say it in terms of vapors, among all others, like higher hydrocarbons to CH4 to CO2, oxygen, nitrogen, and hydrogen. Okay, hydrogen is has the least absorption capacity. Okay, now how about diffusion? How about diffusion? So as I mentioned previously, that diffusion, it depends on the size of the molecules. Like here, if you see that nitrogen, among these gases, nitrogen is bigger, its size is bigger, and then argon, oxygen, CO2, hydrogen. So hydrogen size is bigger. Of course, so whenever there is a race between these molecules, of course, water molecules or water vapors, they will win because of their least size and higher diffusion coefficient. Okay. Now, up till here, I just gave you an introduction about membranes and, just one slide. So the membrane performance is measured, which I will use in my slides. It's permeance and permeability. So permeance is pressure normalized flow rate, which we usually measure it for gases in GPU, gas permeation units, and it's a membrane property. Whereas a more realistic towards material is a permeability, which is pressure and thickness normalized flux, and for this we use a unit as barrel. So here you see that so this barrel is in the name of Mr. Barrer. In fact, he was the one who did initial permeation experiments in 1940s at Imperial College. So under his name, we use especially in gas separation barrel. And this I will frequently use in my talk. Okay. Now, as I told you that my presentation will be about vapor separation and vapor sensing. So first I will show you some examples of significance of water vapor removal. It's very important in many applications like fuel cell in the cars and also in the food industry where humidity is key to control the grain quality, and also it's very important in gas industry. Like this is a natural gas purification plant. Usually, water vapor removal for natural gas industry it's conventionally done by big towers, as I showed you in my previous slides. But in cases especially where space is limited, so those kind of big towers they are not very well limited. Another very important application where water vapor removal is very important is in our space living where we live, and especially in the cooling industry. Okay. No, in fact, apart from this, there are some other applications, but I will just focus my talk on cooling industry. Okay. Now, when we say in cooling, why I say that this is the biggest application? Okay, according to very recent from Japan Refrigeration and AC Industry report, by 2050, 2/3 of the total world population it will have air conditioning units. So which means that right now in 2018 there were 1.6 billion units of AC's air conditioning units. So they will grow to 6 billion by 2050. So it's a big increase, especially in growing economies like Pakistan and India. They are among Pakistan, India, and also Indonesia. So they are among the biggest nations, developing nations, where the use of air conditioning units will grow in future. Okay. Now, one of the unintended disadvantage of this is energy use because of the increase in air conditioning units. It's expected right now it's about 37% in space cooling, and if we see it in terms of energy use. So right now it's in 2016 it was 2,000 terawatt hours. And if we keep on going as it is, business as usual, so we are expected to have 6,000 terawatt hours by 2050. Okay, now when I saw this report for first time, I didn't know how big difference is between 2,000 terawatt hours to 6,000 terawatt hours. But later when I saw it carefully, in fact, right now in 2020. The total energy consumption only for China and India, that is 6,000 terawatt hours. Total energy consumption, not cooling, but in all their sectors. So one can understand that how big jump will we have in especially energy increase just only for cooling if we keep on going as it is. But there are some energy efficient scenarios which we follow then. Which if we follow, we can reduce this 6,000 terawatt hours to almost 45% by 2050. Okay. Now, to understand this, what are the energy efficient scenarios? First, we need to know what is the conventional scenario. Like this is a conventional cooling system. In fact, in a conventional cooling, let's say we have a humid stream at about 20 gram per kilogram of humidity ratio and at a temperature of 30 degrees centigrade. So we reduce it, we cool down it to below the dew point at about 8 or 9 degrees centigrade temperature to heat on the coils, and then it's heated up to the required temperature, which is usually 18 to 20 degree according to HRE standards. So this is conventional cooling. Whereas in an efficient cooling, we propose that we bifurcate this process into two systems. First, dehumidification takes place at the same temperature. Let's say here I have shown 30 degrees centigrade temperature, and then it's cooled down to the required temperature, whatever we want. So in this case, we can see that there is no phase change, and because of that, it's a more it can reduce energy compared to conventional cooling process. Now, in fact, this is a big unit. It has many parts, but my focus will be only on dehumidification. Okay, in dehumidification, in fact, we can do it in many ways, but I will focus dehumidification or water vapor removal only for by using membranes. Like this is one of the chart which I prepared using different materials. You can see that water vapor permeability, which I showed you previously, that we will talk about in parallel. You can see that many materials have very good water vapor permeability, especially paybacks or even polyactives. They have good water vapor permeability, more than order of 10⁵, and also they are very much selective. Excellent performance, no doubt about it. But the problem is when we use these materials in real application, because we are dealing with the water vapor, so we will have a lot of swelling and especially bacteria and many others. In fact, operational problems, especially swelling. So for that, most of these materials, they don't perform, or they lose their water vapor permeability at the end. So the ultimate goal is to have high water vapor permeability. As more as we are in this right direction, right side. Okay, we will be in the right direction of our work. Because another thing, this also depends on the size of our module, that how big module we will get at the end. So if we have let's consider if we have a very small water vapor permeability, so we will need more and more meters of membranes and ultimately bigger modules to counter our real application. But if we have a very good water vapor permeability of a material and permeance of the membrane, so then of course our end size of our end unit, that will also be. So in summary, we need some of new membranes and new membrane materials where we can use those for dehumidification application, which is a water vapor removal. Okay. As I mentioned, that one of some of the key requirements for these kind of materials or these kind of membranes, to use them for such separation, they should be highly permeable. Of course, this makes sense because we need, as I mentioned, that we need smaller area. They should be robust in humid and resistant to bacteria. And finally, the material, whatever we are using, in fact, my major focus is on materials, so that's why I have highlighted it. So it should be scalable. In lab, sometimes we prepare membranes of a stem size, but at the end, when we scale up those materials, it's very hard to get it. So we need such kind of materials, membrane materials, which are scalable. Okay, so for that, in fact, in past 5-6 years, we prepared many different kind of membrane materials. But here I will show you just one example of a block copolymer membranes, which are very exciting and very interesting application. Okay, this is a 5-block pentablock copolymer. In fact, it has 5 blocks, so it's very interesting polymer. So you can see that these two end blocks, they have a tertiary butyl styrene, and then middle blocks they are ethylene copropylene block. So all these 4 blocks, they are hydrophobic. They have nothing to do with the separation. Whereas the middle block, it's a sulfonated block, sulfonated styrene, and we know that with the once it is sulfonated, so it means it will have a certain water uptake and a certain performance for water separation or even water vapor separation. Like here, these two end blocks, as I mentioned, tertiary butyl styrene, in fact, they are sturdy blocks, and they give strength to the polymer, and at the end of membrane, well as ethylene propylene, so they provide flexibility, and vapor transport happens through sulfonated blocks. Now these polymers, this kind of block copolymers, they form self-assembly, as I showed here, and this self-assembly can be controlled in different ways. And in fact, here I used two different kind of set of solvents to dissolve this material, and finally we achieved a very nice membranes of varying micelles formation. Okay, like here if you see, in fact in one case I use toluene and IPA isopropanol mixture, and you can see that we achieved a regular kind of micelles formation. These black dots, they show sulfonated block, because this is a TEM image and it was done by using lead acetate. So this black shows a sulfonated block. So here in this TEM image, you can see that the black dot is covered by this white part. So it means that our sulfonated or our hydrophilic block or our transport providing block, this is covered by unwanted blocks, I will say. Whereas when we changed our solvent from this mixture to tetrahydrofuran, we achieved a very nice morphology. In fact, when I did this TEM first time, so my professor said, "Oh, it's a kind of skin of a snake." So it's a very beautiful image. So you can see that, in fact, here all the hydrophobic blocks, they just make an aggregate, and they made lumps. Whereas the hydrophilic blocks, they get together and they form the channels for transport. So like here in these AFM images, if you see especially this tetrahydrofuran, you can see, okay, so this is for surface. You can see that we achieved a very nice highways kind of structure for transport. So we call it as highways for vapor transport. Okay. Now, when we, in fact, to further understand this, we also did MD simulation for these two cases, just to see that why this different mechanism is happening, why we are getting the two different kind of structures. Okay, let's see. In the case of toluene and IPA mixture, you can see that this red and yellow block, this is our sulfonated block. So this is covered by hydrophobic blocks, this white and gray. It's covered, since it's a 3D structure, so we are just looking from the front. So maybe it's not very much clear, but I think one can understand that that this hydrophobic block, it's covered by hydrophobic blocks. Like all these, just only this last one is not covered, whereas all other blocks are covered by hydrophobic blocks. Whereas in the case of tetrahydrofuran, you can see that all these hydrophilic blocks, they are on the outer edges, so they are not covered by hydrophobic blocks, which we exactly saw in our previous AFM image. To see it more clearly, I added water molecules in it. You can see that in this upper case, all the water molecules, they are trapped between hydrophobic blocks, like this water and gray. Whereas in this case, all the water molecules, they are just on one side of since we took this snapshot on one side, so they are just on the one side. So they are not on the somewhere in the middle of hydrophobic block. So this clearly shows what we observed in our previous TEM images. So we call them, as I said, that we call them as highways for water molecules. So this is just a schematic to show it more clearly. Like here, these water molecules, they have to follow this tortuous path to pass through. Whereas in this case, as we showed schematically, so these water molecules, they are very quick, and in fact they have no obstacle to pass through this. So ultimately, we got good performance for these membranes. Okay. Okay, just one or two slides before I go to its results. We tested its diffusion coefficients. In fact, in both the cases, if you see that we have almost similar, just two times the increase in diffusion coefficient. So here we have 6.47, and here it is 12.3. So this makes sense because here, as I mentioned, that there was no tortuosity, whereas here in this case was a tortuous path. So of course the sorption kinetics or diffusion coefficient was less in this case. No, when we observed its desorption kinetics, we saw a very interesting feature. Like here in our uppercase, where we have disordered kind of structure, so desorption happened only in 160 seconds, whereas in our ordered morphology, the desorption happened in about more than 200 seconds. So what does this mean? So this clearly contradicts to what I showed in our previous slides. But I think I will show you that what is the reason. Like here, if you see, in fact, I did its environmental SCM. Let's say in this uppercase, when we go from 10% to 95% relative humidity, you can see that there is about 24% increase in thickness. Whereas in this case, in our highways kind of structure, we have about a 53% increase in thickness, increase in membrane thickness. So this means that since the material has more moisture or more water vapors trapped, so that's why, of course, it will take more time. So this clearly shows what we saw in our sorption kinetics as well. Okay. So finally, as I showed you that water vapor permeability and selectivity data. Let's say this in case of toluene and IPR disordered, we have a very good water vapor permeability of about 10 raised to power 5. Whereas the other one, in fact, it increased a lot in our ordered membranes. And since it's a log-log graph, so maybe that's why it doesn't show very different. But in fact, it's more than an order of magnitude increase in water vapor permeability in both the cases. So, in fact, to summarize this, in fact, nanostructure is the key for this kind of a block of polymer membranes. Now, this was our fundamental work which we did for dehumidification application. So, as this was a whole work was done on a freestanding films without composite, without any support, but in the industry, such kind of membranes are not required because in industry they need something, especially composite membrane, their material is very much limited. Okay, so for this, in fact, COUS started a COUS cooling initiative based on this kind of works, and we did this work to develop some composite membranes. And here, if you see, in fact, we prepared a very thin layer of this material on top of hollow fiber support. And here, if you see, okay, this is just a simple hollow fiber, polyamide hollow fibers. And when we coated our material on top of it, we achieved a very thin, uniform thickness of the membrane, which is less than 1 micron. In fact, we can even go less than this. So this is this shows that it's a very uniform thickness what we achieve. So there is no problem in our coating to have this such kind of composite membranes. Now, when we see its surface morphology, okay, you can see that this morphology is very similar to what we saw in our highways kind of structure. So this clearly shows that whatever we achieved in our freestanding films in our fundamental work, so we got same kind of morphology in our real membranes, like composite membranes in this case. Okay, so finally, the membrane performance, we tested it for composite membrane. You can see we achieved very good, more than 6,000 GPU water vapor permeance, which is in fact more than what is required in industry, and with a reasonable water vapor over nitrogen selectivity. And so we also checked its EFM image after the test, and you can see that they retain their performance. There is no problem in the membrane morphology after our test. Okay, so scalable synthesis, membrane synthesis is possible using this kind of block-copolymer membranes, as I showed you, in composite membranes and in freestanding membranes. Okay, now all what I have showed, this is about membranes for a very typical applications for water vapor separation. They can also be extended to gas separation. In fact, we tested this for gas separation as well. But no, I will show you one very interesting, interesting application of such block-copolymers. Maybe some of you know, or I don't know whether you know. He's a Professor Klaus Feynman. In fact, he was my PhD advisor. He's very well known for his groundbreaking works in self-assembly of block copolymers. Like, this was his work in Nature Materials many years ago, where he introduced a simple method to prepare isoporous membranes with nanometer-sized pores by combining the industrially well-known phase inversion technique along with self-assembly of a block copolymer. So this is well known for many years. Now, we use this kind of material. We use this kind of block copolymer to test them. Why not to go for some other application? Let's say for sensing application. So no. When we started this work, in fact, we saw sensing is full of different kind of materials which are being used for sensing applications. Let's say for vapor separations, for water vapor, for organic vapors, and for various gases. They are already full of it. So we just tested our block copolymer, which was like in this case we used PS block P4BP polystyrene based block copolymer, and it showed some reasonable performance, but not a very exciting performance. So later we collaborated with the Solar Center. They are well known to develop miniature size sensors, and we are not good one in those. So we combined these materials and that sensing sensors, and we came up with some very interesting idea. In fact, in this work we used carbon nanotubes as a collecting material to develop sensors, because initial results showed that maybe if we go for just block copolymer sensor, we will not have a good performance. Okay. So this was our SEM image of our isoporous membrane. So you can see that it shows a clearly integrally asymmetric membrane of block copolymer with highly ordered thin layer on top of it, and this enlarged image, in fact, it shows that the pores are vertically aligned in the form of nanochannels of about 400 nanometer in length, and the diameter was about 20 nanometer. When we observed its AFM image, it also confirmed the long-range isoporous morphology of film consistent with our SCM images. And in fact, we did its TEM image as well, and you can see in TEM image, we can clearly see carbon nanotubes. They are very well aligned and uniformly embedded in the fragments of carbon nanotubes without any agglomeration. Okay, Okay, we prepared a sensor, isoporous sensor, and you can see that this is digital image of a freestanding film. We show that it's a good mechanically stable, and this is our device structure, which we prepared for a sensor. It consists of two gold electrodes deposited on a film. Okay, no, sensors have many other properties as well, but one of the most important is what is the sensor response. So the sensor response, which is calculated as a function of relative humidity, because in this case it was just only for water vapors. So as a function of current at a certain relative humidity divided by 0, but here in our case was 10% relative humidity. And in fact, here you can see that when we move from 10% to 95% relative humidity, we showed an exponential change of about 800 sensor response when we go to 95% relative humidity. And this is our absorption and desorption response for sensor as a function of a relative humidity. In fact, it shows no hysteresis. So this clearly indicates that the sensor is reliable, and this is a miniature size of sensors, sensor arrays which we use in our work. Okay, now the most important parameter in sensor industry is its detection speed. Like here, when we tested detection speed for our composite sensor of glaucopolymer along with the carbon nanotubes, we had the sensor response was just 0.3 seconds. And in fact, when we expose it from 10% to 95% the relative humidity, and its recovery time was about 4 seconds. Whereas in the case of just nascent sensor without carbon nanotubes, you can see that the response was very slow. It was about 3.8 seconds, and recovery time was about 12.1 seconds. So this clearly shows that the response of the sensor is very fast. And in fact, when we compared this data with literature, we found it's among the fastest response ever reported for, especially for water vapor detection. Okay, we also tested reproducibility, and the sensor shows very stable performance over extended period of time. Finally, to summarize this, the composite sensor we showed for isoporous glaucopolymer based membranes. It's a very fast response sensor, and it overcomes the challenges of fabrication of well-defined and long range devices for especially for humidity detection. In fact, we tested this for other organic vapors as well. But in those cases, the response was also good, but this was not very high compared to what we had in our humidity application. Okay. Before I end up, I must acknowledge COUS for funding all these works, whatever I did during the past many years. And I would also like to thank our group members led by Professor Feynman for all the support, and some of these guys who helped me in doing most of it. With that, thank you very much, and I would be happy to answer your questions.
Thank you very much, Dr. Fahim. Surely it was a very wonderful talk. Participants can write their questions in the Q&A box in the right side of their screen. Meanwhile, we get any question from the participants. Dr. Fahim, if you allow, I have a question.
Yes, sure.
Dr. Fahim, we are talking about carbon capture sequestration from the power plants, and you mentioned a couple of applications of membrane technology. in our exhaust gases from the power plant, typically it's water vapor, carbon dioxide, and oxides of sulfur and nitrogen, and some micron-sized particles. What we are currently doing to get rid of these pollutants, we are normally using scrubbing process. But
sorry, which process?
Scrubbing process. We just scrub out all these pollutants from the exhaust gases. We just wash them. Do you see any potential application of membranes in such kind of applications? Considering the exhaust is relatively high temperature and sometimes above 200 degrees Celsius, and even it contains some particles.
Yeah. Okay. Considering this scrubbing process, let's say if you are using scrubbing and you want to replace it with membrane, I don't think it's a very good idea, because at the end membrane we will not use only one module at the end. We will use a series arrays of modules and will make a big frame. So I think usually this mechanical separation like this you mentioned. So usually it is done as it is. But after this we have a so this we call as pre-treatment, and then for especially for expensive separations we can use membranes. For example, in Pakistan there is one natural gas plant, and in fact that is one of the world's biggest plant for CO2 separation, where membranes are being used. It is the biggest plant. They are using their cellulose acetate membranes, and it has been used since many years. There is no problem in that. But for its pre-treatment, usually it's not considered to use these kind of fancy materials. The second part of your question was about the temperature. In fact, mostly these membranes, let's say cellulose acetate membranes, which are for CO2 separation, they cannot withstand this kind of temperature. But there are polymeric materials which can withstand. But especially when we go for temperatures more than 150, usually we use thermally rearranged, and in fact thermally rearranged polymers, they can withstand more than 200 degrees, like some other polymers, like also polybenzimidazoles. They can withstand more than 400 degrees centigrade temperatures.
Yes, thank you very much. We do have a question from our participants. Dr. Zahib is there for the question. And the question is, although your highway membranes give high diffusivity coefficients, have you done any strength analysis? Can your developed membrane bear the same pressure drop as conventional membranes?
Okay. Okay, yes. So this question was from
Dr. Zahib.
Dr. Zahib.
He is a faculty member in chemistry.
Okay, Dr. Zahib. Yeah, he is right. Actually, this problem occurs. But here in this case, if you see that we have 5 blocks. All these 4 blocks are hydrophobic blocks. Let's say if we have a hydrophilic membrane composed of hydrophilic materials, let's say gel kind of material, super adsorbents polymers, like the material which is used in diapers. So of course there such kind of problems happen. But here in this case, our material, our blocopolymer, is composed of hydrophobic block, and in fact it's about the 75% part of the blocopolymer. Just middle block is a hydrophilic block. Now regarding its strength analysis, in fact I tested it at about how much, 22 bar, just freestanding film, and it was stable. On the other hand, in industry, like I showed the second example of our highways kind of structure, we prepared composite membrane. So at the end, we are using composite membrane. So in composite membrane, we just have about less than a micron thick membrane on top of a support, let's say any non-woven support. So over there, even if a material is not mechanically stable, even if it is not mechanical, so that mechanical strength is still stable enough. But here in our case, as I mentioned, that the material is already stable enough.
Thank you very much. And just a last question that was pointing to my mind. For desalination purposes, we have some current practices, and here is a membrane separation technology. I was wondering how do you compare current practices with membrane separation regarding their capital cost and the energy investment and maybe the maintenance as well?
Yeah, it's a very good question. In fact, in KAUST, we also have a membrane-based desalination, membrane-based unit. Okay, as I mentioned in your previous question, that for pre-treatment, no one will prefer membranes, or no one will prefer to go for very fancy things. Like here in Saudi Arabia or overall in Gulf, usually they are using thermal processes, thermal desalination processes, and they can afford it. They are very well on it since many years. But in Pakistan or in some other growing economies, since it costs a lot of money to set up this thermal desalination units. So membrane-based units, they don't offer very much. In fact, they are not very expensive. People think like that maybe they are very expensive. They are very difficult to operate. In a usual process, in fact, the biggest desalination plant, which is in Israel, Ashkelon desalination plant, they have millions of these units attached, and also we have here in Jubail and one in close to Rabil. So those are also membrane-based units. Now, okay, there are some operational problems, but those kind of operational problems are always in every kind of separation. But usually, let's say, finally, if we have RO membranes or NF range membranes, so usually they are polyamide-based membranes, and they are good enough to sustain more than sometimes even more than 10 years, and usually there is no problem. So sometimes I know some problems happen, let's say for spacer and spacer cleaning, but apparently they look very difficult. But I don't think they are very difficult problems, and they are being done very easily. So membranes have a lot of potential in desalination industry, and in fact, like here, as I showed you, as I mentioned that in KAUST, we have a huge plant, in fact, a very big plant to produce clean water right from Red Sea. So that is membrane-based.
Yes, thank you very much, Dr. Fahim, and thank you for this wonderful talk.
Thank you. Thank you.
Unfortunately, I forgot to announce the presentation of SHIELD to our earlier speaker as well. I request our team member to present the digital sheet to Professor Islam first, and then to Dr. Fahim.
Okay. Thank you very much. Thank you.
Thank you, team. And for Professor Islam. Thank you, everyone, for your time. Now we can move on to our third speaker, Professor Dr. Nauman Ahmad Zafar. Professor Nauman Ahmad Zafar is currently serving as Associate Professor and Director of Energy and Power System Research Cluster at the Department of Electrical Engineering, LUMS. He is also founder member and part of the steering committee of LUMS Energy Institute. His area of research includes work on smart and existing grid and new grid architectures, power electronics converter for integration of renewable energy resources, electrical drives, battery storage systems, and electrical vehicles. During his tenure at LUMS, he has been engaged in launching 4 power electronics startups and 3 patents. His primary research focuses on harnessing and efficient utilization of energy from available resources such as solar PV, solar thermal, wind, and hydrokinetics to enable grid-independent, integrated, smart grid communities. He has worked on the Chief Minister's Task Force on Energy Theft, part of enabling team for electricity marketing for the Pakistan power sector, and has been involved in formulation of National Electrical Vehicle Policy for Pakistan and its promulgation. Without further delay, I request Dr. Nauman to share his experience, his talk on stationary storage landscape in Pakistan and case for lithium-ion batteries. Professor Nauman, forum is yours. Please open your mic and share your presentation.
Thank you so much, and thank you to all the conference organizers. The share screen is still disabled for me, so as soon as it's enabled, I'll share the slides.
Session Chair, can you please help?
Ji.
Yes, sir, we can view your presentation now.
Yeah, thank you very much. Yes, Professor Nauman, screen share is open. Thank you.
Thank you so much. Once again, I'll be presenting the case for lithium-ion batteries in Pakistan, and in the process, I'll also be talking about the primary focus being on stationary storage landscape. The work that I'll be presenting evolved from a generous foundation from HEC through a technology development fund project. And one of the key requirements was to have an industrial partner who's willing to take the technology which is developed into production. And we have recently completed the project, and the commercial rollout of the product is already in place. So again, I would also like to thank HEC and also to Sozo Group of companies for the generous support that they provided to carry out this project. I'll start with a little bit of background. And when we talk about energy and energy storage, again, we are sort of dependent on stores of energy, but globally we are addicted to energy on tap, which basically means as and when required, we expect the energy to be available. And in that, we are primarily dependent on fossil fuels, for which the storage occurred millions of years ago. And we are at this point in time sort of, utilizing them without any regard to its depletion or its impact on the environment. And the key reason is that it's one of the highest energy density materials which is naturally available and fairly abundantly available. So if we look at the graphic which is shown, it shows the energy density of common fuels, excluding hydrogen, which are available. And on the x-axis is the energy density by mass, and on the y-axis is energy density by volume. And in that, if you look at the elements or the materials that are derived from fossil fuels, they occupy very good positions. They occupy high energy density positions by volume and by mass in general. And if you look closely in this, we also have the man-made storage, which is the lithium-ion battery, which is at this point in time sort of the commercial de facto technology which is available. And we see that it doesn't compare even now anywhere close to the energy density for the fossil fuel. But again, we hope that as time grows, we would be moving in the right direction for energy storage materials. And in that, electrical energy storage has seen unprecedented growth, primarily driven by new battery technologies. And in that, sort of lithium-ion has taken the lead as far as the commercial deployment is concerned. Another good thing is that there are many, many promising technologies that are right there on the horizon. We expect that in the next 5 to 7 years, maybe 10 years, we will see many competitors to lithium ion that are going to come in the market. So they're already in the lab. People are already working on them, especially in academics. Again, there is a cycle which is associated in taking these technologies to commercialization. And that sort of brings certain aspects of storage that need to be highlighted. I mean, before this recent surge in electrical storage technologies, we had few technologies which were there and we were using them without regard to their suitability for different applications. And now that we have a plethora of these technologies which are expected to come in vogue, how do we sort of make sure that the systems which are designed to use these batteries are independent of the underlying chemistry? And that's the core thrust of the work that we have done. First, to understand both ends of the storage equation, which is the underlying electrochemistry, and then to also understand the other end of the utilization of the energy. So the systems which will be utilizing the stored energy. And when we talk about electrical storage, there is a whole range of the kinds of loads which use batteries as electrical storage. There could be small systems, medium systems, or large systems in terms of their energy requirement. But then there could also be devices that use energy at the two extremes of the rates at which the energy is consumed. So we not only have to look at the energy density, we also have to cater for the power density requirements of the loads which are connected, and maybe the charging times which are dictated by a particular application. As an example, if you look at small systems, there could be handheld devices. There could be lighting loads which have low energy requirement and low power requirement, but there could also be power tools that require energy to be drawn at very, very high rates. Same batteries are not suitable for these two varying types of loads, although both could be classified as small systems as far as their size is concerned. When we talk about medium systems, there could be automobile batteries versus, say, solar or UPS batteries. Once again, huge difference in terms of maybe not the capacity which is required, but the rates at which the energy exchange takes place. So we need to again be mindful of these and design the storage based on the requirements. And then we could be talking about large systems, and these could be either with batteries or without batteries, like pumped hydro versus flywheel versus grid level batteries. And each of these again have their own set of requirements and their own sort of particular application that they target and then are designed to fulfill the requirements. So in a nutshell, we have cell chemistry to deal at one end and load behavior to deal at the other end. In terms of this particular area, again, when we look at the most disruptive technologies which are expected to come out, storage and related to storage is the application of the storage in renewable energies. It has both a very high impact on the society and various aspects of the society that it can impact. And it also has a huge financial impact, which means the financial case for the storage and its application is already established. We need to sort of become part of this run and develop technologies which not only address the requirements, the local requirements, but if we are able to create disruption and create technologies that others need, we can also make this part of the export value chain. Which pain points and challenges should we be looking at to address? As I mentioned already, it would be matching of load with the right chemistry. And in addition to that, we have to create appropriate terminal characteristics. And when we talk about terminal characteristics, when we look at our battery storage solutions, the terminals are the interface that they provide to the outside world. Inside the batteries have a whole world of their own which is going on, and the overall battery system that gets developed is comprised of many smaller units. And in general, these are cells, and these cells can also be designed for various capacities. But in general, a battery system would consist of multiple of these cells that are connected in series and in parallel. And the series connection allow us to provision the battery terminal voltage characteristics that should match with the requirements of the load. And the parallel connections of the cells should, in theory, allow us to service the current requirements for the loads which are connected. So depending on how much energy is required to be drawn, or at what rate it's required to be drawn, we need to connect different cells in parallel. The parallel combination also allows us to manage the storage requirement. So the energy as well as power requirement would be the cells in parallel. The battery terminal voltage characteristics would be determined by the cells connected in series. Another challenge which has been a pain point of battery storage systems has been both the high upfront cost and the recurring cost. And again, these are parameters that need to be taken into account for applications. And if we are able to address these challenges, there is a whole range of new applications that open up and that make the case for the battery storage much more stronger. The next point would be the reliability of available batteries, and I'm sure that each and every one of us has suffered at the batteries failing at the wrong time. And we need to make sure that the storage systems are reliable. They're reliable in terms of provisioning of power and energy. They're also reliable in terms of giving us a prediction of when and how we can expect the performance to degrade. So it's not, again, a mandatory requirement for the batteries to last forever. But if we are able to predict the behavior of the batteries, that in a way it is good enough for people to both plan and then use the batteries in appropriate manners. We need it to be safe. Batteries, depending on how they're manufactured and for what type of applications they're manufactured, can pose both chemical and electrical hazards. And again, if we are lucky to have not experienced it firsthand, we as electrical engineers are generally aware of news about the batteries and the hazards that they pose. So not just the functioning, but to also the protection of the batteries and the protection of the people and the systems that are using the batteries becomes an integral component of the batteries when we talk about battery systems that have to be designed. Batteries in general are big, bulky, and they require maintenance. So once again, if we can do, or whatever we can do to manage the size, and again, what the size is would also depend on the application and the type of application. And again, to set the expectations right for various applications is a key requirement. And again, it's not just the battery system, but the pain points spill over to other associated industries. The potential uptake of renewables currently is primarily limited by quality and size of storage. So again, if you're able to address those, we can see a surge in uptake of renewables, either in connected modes or standalone systems and their deployment. When we talk about the storage landscape in Pakistan, they are in general at this point in time dominated by lead acid batteries. And then in lead acid batteries, which are primarily not designed for the kind of applications for which they're used, they happen to be there. They were designed as starting batteries for internal combustion engine vehicles. But again, because that was the only kind of storage which was readily available and had a relatively low price point, that is what people ended up using, and using, I would say, in absolutely the wrong way, not looking at how the battery should optimally be utilized. And then because of the demand, there was a lot of production that happened, and there's a huge variability in quality of batteries. In general, even the manufacturers are aware of this, and what they provide is a declining warranty, and generally the warranty is less than 6 months, although some of the newer manufacturers with the increased competition from lithium-ion have now started giving slightly longer warranties, but none that I know of provides a warranty of more than a year. The lead acid batteries at best provide inefficient utilization. In the systems that they are used, the overall system efficiency is generally less than 40%. And people are happy because at the critical time of their need, these systems do provision energy, but they don't truly understand the cost associated. And the systems are in general less than 40% efficient, and they are ill-designed solutions. To top it off, all of the marketing for these existing batteries is based on the total storage capacity or the nominal storage capacity, which far exceeds the usable energy capacity. And that again is related to how the battery should be utilized, which basically means that there is, and we'll talk about all these parameters so that we get, again, a deeper understanding and then design our storage solutions around that. The challenge is to introduce new storage solutions, the best of both worlds would be that the new storage solution does not create an environment where it is limited in use to only the new systems. And that's how a lithium-ion battery is perceived globally. So one of the key pain points that we addressed was to design the lithium-ion batteries so that the new systems are able to utilize these batteries, and these would be systems which are designed to use lithium-ion batteries. But what if we could design these lithium-ion batteries so at the terminal, they provided the terminal characteristics of lead-acid batteries, so that people who already have systems that run on lead-acid batteries, for them it becomes an off-the-shelf drop-in replacement of lead-acid batteries. So they gain all the benefits of lithium-ion batteries without requiring an upgrade of their electrical system. And that would reduce a lot of waste to existing systems. For customers that have deeper pockets, like telcos, for them, the case is already established where they are thinking of replacing the entire system. So they not only replace the batteries, but they replace the associated electrical system that exchanges energy and power from these batteries, both during charging and discharging along with it, to install the new lithium-ion systems. If the existing electrical part of the system is working fine and the efficiencies are good, which is generally the case for telco, which is a well-regulated market segment, then in fact, there should be no need of dumping good existing system to buy new systems. And we should only be required to change the element which is causing the problem, which is sort of replacing the lithium-ion batteries. Another challenge is to not only look at the existing market segments, but to also capture the emerging needs of these battery systems, and local indigenous development provides that handle. So it allows the batteries to be developed, understanding all these requirements, and then as and when the need arises, the evolution to new types of storage requirements, say for EVs, or for grid level storage can also be then extended and be not required to be designed from scratch all over again. And the market size, we have about 2.8 million plus UPS systems in Pakistan. The EV policy has already been approved by the cabinet. New models for intelligent batteries become an essential requirement for fast track rollout of EVs locally. Then there are new solar solutions which are funded by government for rural communities that are coming up very fast. It's expected to be more than 1 million in the next 3 years. And we need to have financially competitive and longer life battery banks for off-grid and hybrid solution, and goes without saying higher reliability and better quality. We need to understand the various underlying science for electrochemical storage solutions, and I'll go over some of them so that we are sort of on the same page as far as each of these terms and terminologies are concerned, and we develop a keener insight into why they're important. So when we talk about electrochemical storage, they are inherently a voltage source. So as opposed to being a current source, and the cell voltage, not the battery terminal voltage, but the cell voltage is a function of cell chemistry. Whereas for lead acid, each cell is nominally rated at 2 volts. For lithium ion, when we talk about lithium ion, we sort of bundle a bunch of chemicals into a single kit. So there are different cell chemistries for lithium ion. Each of those have different cell level voltages, cell level voltages, and be aware of. And we need to be aware of other characteristics as well for each of those cell chemistries. But here about the overall voltage for the tree, any of these need to be connected. What kind of voltage protections need to be put in place? We need to understand the cell voltage for each cell in the particular cell chemistry. The terminal voltage is determined by a series combination of cells. Then we talk about storage capacity, and generally there are 2 measures that are associated. Either be the energy stored measure or a charge stored measured for a given nominal cell voltage. The are watt kilowatt hour for energy storage and ampere hours for charge storage, which to terminal voltage actually into the watt hour kilowatt hour energy storage units. The storage capacity is determined by parallel combination of cells for a given terminal voltage. The next is depth of discharge. So that determines the recommended level of energy extraction for normal operation without excessive degradation. And that again is a very, very important parameter. So although we can have a battery which stores a certain amount of energy, and it may be willing to provide that energy, it is highly recommended that the amount of energy extracted from the battery is limited, either by designing an intelligent system that puts those checks and balances in place, or it needs to be governed or monitored and regulated as far as the customer is concerned in terms of managing the amount of energy exchanged from the battery. To give an example, the depth of discharge for flooded lead acid batteries is limited to anywhere from 20% to 30% only, which means that about 70 to 80% of energy which is stored should not actually be utilized from a flooded lead acid battery. The sealed or deep cycle lead acid batteries, the depth of discharge is around 50%. For lithium-ion batteries, it can be 100% without any issue. Recommended is 80% depth of discharge, and people actually build intelligent algorithms around it. For example, one of the mechanisms utilized by manufacturers extending the life of their batteries is to to actually reduce the depth of discharge initially and keep it a dynamic parameter of the state of health. So what happens is the cell is new or the battery is new, they would say limited to 80%. And people, the customers get used to certain storage or certain backup time for the cell phone. As the cells degrade, they increase the depth of discharge. 80% depth of discharge, the life of the battery increases. And even with that increased life, as and when it degrades with the increased depth of discharge, the user experience remains the same. So with this kind of intelligence built into the battery management system, we can understand depth of discharge and use it to our advantage. The next is the discharge rate, and that determines the maximum power delivery capability of the battery. And it is given by CERAD. So you might have heard 1C discharge, 0.5C discharge, maybe 2C, 5C discharge, depending on the type of battery which is available. And 1/C gives the time in hours to discharge the nominal capacity completely. So for a 100 ampere hour battery, 100 ampere of discharge current would be rated at 1C. 50 ampere of discharge current would be rated at 0.5C and so on. So with 0.5C, you would get 2 hours of backup time for the battery from a nominal storage capacity. The charge rate is also given as a C rate, but generally the charging rate for lithium-ion batteries is smaller than the discharge rate by a factor of 2 to about 10. And again, depending on the particular application and the type of cell, this can vary. Within keeping the charge rate within these limits helps improve the performance and the overall life of the battery. Then there is self-discharge rate, and that determines the shelf life of the battery, and that determines the energy leakage over time. So if we are to charge a battery and we are to leave it on the shelf, how long would it take for that amount of charge to actually drain away from the battery? And there is self-discharge for all types of batteries, and it sort of determines the energy leakage from the battery over time. Then there is a cycle life, which determines the number of useful life in terms of charge-discharge cycles, and it determines the longevity of the battery. The cycle life is given under strict conditions, and it varies with environmental factors like temperature and humidity. It also is degraded or enhanced by the charge rate, the discharge rate, and depth of discharge. We then have internal resistance, a parameter.
Assalamu alaikum. My name is Dr. Tabish. I'm working as assistant professor in chemical engineering department, UET Lahore. Every year, millions of lives are.
As the battery ages, the internal resistance goes up, which basically means that at higher rates of discharge, the voltage is going to go down very quickly. Another important parameter is round-trip energy efficiency. So the batteries are not 100% efficient. There can be multiple factors that affect it, and it determines the energy extracted from the battery and how much energy you store in it, and when you take it out, many of it is recoverable. And this also is impacted by how much of this energy is actually wasted in the process. The energy density in watt hour per kilogram or watt hour per liter determine the energy per unit mass volume. The power density determines the rate at which energy can be delivered. And again, depending on the various types of storage technologies which are out there, another competitor to battery systems is capacitors. They do not have a high energy density, but they have a very high power density. They also have other advantages and disadvantages. But again, for anybody who's working in the electrical storage area, need to understand these parameters in depth. Then there is operating temperature range, and that dictates the boundaries beyond which storage deteriorates. Then we have state of charge, and this is for every cycle of use that would tell you on how much is the remaining energy capacity at a particular point in time. Then there is state of health, which is a measurement over the life of the battery, and that determines the percentage nominal capacity remaining, percentage of the nominal capacity which is remaining. And again, with every charge of storage which are out there. We then have levelized cost of electricity in cents per kilowatt hour, which is again a derived parameter, very important, and that says that over the lifetime of this storage, over the useful exchange of energy from the battery, just taking into account not the cost of the energy per se, but the cost of the battery as it depreciates, what is the levelized cost per kilowatt hour that we have been able to achieve from a particular battery storage system. When we day and age talking about energy storage systems, and they are not the same as the traditional electrochemical energy storage in batteries. They are complicated electronics and power electronics based systems that are there, which actually monitor different aspects of the battery throughout its life, and use those parameters to determine the way the batteries are going to behave and the way they are used. The control of terminal characteristics would be load dependent, and the control of terminal characteristics for charging would be cell chemistry dependent. And then the cells, when they are connected, if they are not equal in capacity, it can give rise to suboptimal utilization of the battery storage capacity. And it's illustrated by this figure. And it basically says that you can run into a problem where if one cell, say cell 2, is weaker than cell 1, then during charging, cell 2 may actually reach its full capacity before cell 1, which basically means that even if you want to charge cell 1 because they're connected in series, you are unable to do that. So, and during discharge, because if cell 2 is actually weaker, it is going to discharge faster than cell 1. So over time, this particular phenomenon gets compounded, and battery, the charging is limited by cell 1, the discharging is limited by cell 2, and although both cells individually may actually be have their useful life left over, but because of the way they're connected and the way their capacity was being managed, they're no longer usable. We do not hear about cell balancing in lead-acid based systems because it's managed passively, and it's part of the cell chemistry of lead-acid systems, where during overcharging, the cells that get charged to their full capacity earlier, they dissipate energy faster, so it allows the other cells to catch up. So it's a dissipative process. It wastes energy, but it allows the balancing of the cells in a natural manner, although the situation degrades till one of the cells actually completely breaks down, and then the whole battery becomes useless. The one of the systems that we developed here, and it's sort of put in there to highlight the complexity of the electronics and the complexity of the control that goes in to manage these systems. One of the key elements in newer battery technologies is the smarts, the intelligence that goes in both for monitoring and control. And these are now the new battery systems are IoT enabled systems. So they're not only there to monitor the charging and discharging profiles of the batteries, but to also put various controls in place to safeguard the battery. And it also allows newer level of services to be offered to the customers. And then we can also think of hybrid systems, again, not part of the current project, but again, very important to understand that there can be applications like, especially in electric vehicles, where hybrid storage systems of supercapacitors and electrochemical storage can be combined to create batteries which perform well based on their own sort of requirements or their own areas. The international trend in lithium-ion, the price is going down. So this pictorial here sort of shows the declining trend. Very encouraging in terms of, new storage solution development. For Tesla Powerwall, the current prices is around $400 per kilowatt hour. Expensive, but still provides 10x advantage over others. In terms of the overall breakdown of the cost, very encouraging, because the raw material cost for cell and cell related areas is maybe around 40% of the total battery price. So that leaves a good play in terms of areas that we can develop locally and then work with. When we compare lead acid with lithium ion in existing storage solutions, again, it's a depth of discharge that I've already explained. And then the storage capacity also is primarily dependent on the initial charging cycle for lead acid. And that's one of the parameters that is completely missed in the local market. So when we go to buy lead acid batteries, we purchase the battery and the seller charges the battery, but does a very poor job, maybe because the buyer himself is in a rush. And that sort of decreases the life of the battery right there and then at the time of the purchase. How much energy is extracted at higher rates, the capacity actually goes down, and that's given by Puchert's law. So if there is, when we require the energy at bigger rates, it not only depletes the battery faster because you're draining the energy faster, but it also drains it faster because the capacity also degrades. So you are hit by two things all at once. And then the capacity changes with temperature. The lead acid battery capacity degrades above 25 degrees, which is very normal for our geography. Lithium ion works well till about 50 degrees Celsius. So sort of the temperature that we expect in our geography. In terms of cycle life, different types of lead acid batteries, the cycles are either 500 up to 500. For lithium ion, they can go from 1500 to 2000 with 80% depth of discharge. If for smaller depth of discharge, it can actually be 3000, 4000 cycles as well. There is lower round-trip energy efficiency, and a lot of energy is lost in lead-acid batteries, anywhere from 15% to 50%, depending on the charge rate, compared to lithium-ion, which is more than 90% efficient in terms of round-trip energy efficiency. Then the other parameters include the energy density, which means the lithium-ion batteries are going to be both small in volume and in weight, and maybe not a very big concern for stationary storage, but a very, very important factor as far as the mobility storage is concerned. And it also means for bigger load applications, it would be something which is needs to be taken into account. For lead acid battery, the terminal voltage drop is much higher than lithium-ion batteries. And also chemically, we need to be careful with lead acid because of the noxious acidic fumes that are released. In terms of the company which is formed, it's Workbox, it's indigenous development, so it provides better quality, control over quality. It's a bigger value in terms of both expected life and ROI. It's almost 10 times better than existing battery solutions. The existing UPS systems have a market size of about 1.2 billion a year. And then we expect a growing installed base of new solar systems. The design is made scalable and modular. And it needs to be flexible for renewable installed capacity. They're both compact and so this is primarily an overview of the system that we designed. It's a retrofit solution. It works with existing UPS systems. We have already tested it for over 20 different models. And it works with existing customers in UPS, solar, and telco systems, all set for electricals and rural electrification, and also for grid level storage and its associated benefits. Three of the benefits: Workbox batteries compared to acid, average life of 20 months compared to less than 14 months for lead acid, efficiency 90% compared to less than 60%, more than 2,000 cycles compared to 500, self-discharge is insignificant, and weight third of lead acid batteries. These are the project partners, and with this, I would like to end the presentation with a proverb, an American Indian proverb, that we do not inherit the earth from our parents, we borrow it from our children. So one of the core focus should be on sort of preserving it and utilizing it in a socially conscious manner. Thank you.
Thank you very much, Professor Norman, for a very interesting talk. Unfortunately, we are running out of time, but we can have a very short question and very short answer to the question. We got a question from a PhD student from France. And the question is, could you please tell us about the environmental impacts for the production of lithium-ion batteries? Is it friendly environment in terms of raw materials and recycling or not?
Sure. So again, this is and it's something which is asked on various forums. I'll keep the answer brief, but I'm available for discussion. The cell level environmental impact is something that the countries are fighting over. So the raw material procurement for manufacturing of cells is something that we take cells as a raw material. The actual utilization of lithium-ion cells in different types of applications. So the first life is generally for high rates of discharge and charge, which is reserved for electric vehicles, and for a good cell chemistry, that can be anywhere from 3 to 5 years, maybe more. The second life is in stationary storage, which is beyond 80% state of health to about 60% state of health. The first life is between 100% state of health to about 80% state of health. So that gives us another 7 to 10 years in life. Talking about around 15 years before it goes into what we call the recycling of lithium-ion. And that's again an already established area, not done in Pakistan at this point in time, but we have that 15-year window. If we are able to develop the cell manufacturing facility within Pakistan, then the recycling would automatically happen. Otherwise, there is an already established export market for lithium-ion based batteries where China and Korea buy them at very attractive rates, and then they recycle it. So majority of the material is actually recycled during the entire life of the lithium-ion cells.
Yes, thank you very much, Professor Nauman. Surely it was a very interesting talk, and we are thankful for your time. I request our team to present the shield. It will be a virtual shield.
Thank you, Jeev. Thank you very much.
Thank you, team. So let's to our of this session, and this is Professor Dr. Jawad Idar. Professor Dr. Jawad Idar is a professor in materials chemistry at University College London. He is also the Vice Dean for Enterprise and Innovation for the Maths and Physical Science faculty. His research group, Clean Materials Technology Group, focuses on developing new materials for energy and related applications. He has published over 160 papers and 2 patents. He is principal investigator of the JUICET Energy Materials Consortium that is trying to accelerate the discovery and scale up of energy materials. Involved a number of battery research groups. Grants include high throughput nanomaterials discovery, lithium, sodium, and lithium-ion materials, scale up of nanoceramics and materials process control. He is the co-founder and of USIG, a charity that seeks to work with stakeholders to develop better coordination, cooperation, and communication skills, efforts, infrastructures, and educationalists. Without delay, I request Professor to please his talk on materials challenges for decarbonized energy storage. Professor Doc, it is yours. Please share your presentation and on mic.
Assalamu alaikum. Can you see that? Can you see the presentation?
Yes, we can see the presentation and we can hear you clearly.
And could I just confirm how long you want me to talk for? Is it 30 minutes plus questions?
It's 45 minutes including questions. So we request to wind it up in 40 minutes.
Okay, and if you could give me a 1 minute warning and interrupt if I get anywhere near the 40 minutes, I would appreciate it.
Sure.
Okay, assalamu alaikum, bismillahirrahmanirrahim. It's past 7 o'clock in the morning. First of all, I apologize I missed the previous talk. I was really looking forward to Norman Zuffer's talk because it follows on very nicely from what I'm doing. Unfortunately, I was in the wrong session. Maybe it's just too early for me to get up and give a talk, but I'll do my best. I hope everybody's well. I wanted to, given the range of topics on this webinar, I wanted to give you something that very complementary to the previous talk. So I want us to think about, especially those young students here that will be doing research when I'm long gone. We need to think about sustainability. A lot of excitement in batteries and battery research, but we really do need to think about the cost of batteries from an environmental point of view and the sustainability challenges. And actually, these are probably just as important as many other topics, such as developing these amazing devices. So I run the Clean Materials Technology Group. I'm a material scientist, not an electrical engineer. That's my main area. I'm at the interface of chemical engineering, electrochemistry, and for the last 8 years, I learned a lot about batteries, and I run a battery research group, but I'm not an electrochemist by background. So let's see if I can make this thing move forward. Okay, so obviously I'm at University College London, which is one of the oldest universities in the UK. I just point out there's many stats about UCL, one of the main ones for me is that this in the West, this was one of the first universities to offer study for students, or no matter the class of religion or gender. So this is in terms of 1826. This was an empowering university. It still has a lot of that ethos today. For example, somebody like me, a Pakistani British professor in a university like this, it just doesn't happen that often in a top university. So I'm going to talk to you about various topics. For the sake of time, I'm not going to list these topics. You can read them there. And I'm going to particularly cover green materials challenges. As I said, just over about 8 or 9 years ago, we started to develop our facilities with others in the university, and right now we have several labs across the university, a few hundred channels now across the university, probably upwards of about 300 individual test channels. We work in coin cells, pouch cells, up to that scale. We also have collaborations with people, so we are able to make new materials for batteries and evaluate them quite well up to a certain point. And then with industry collaborators, we're able to obviously scale them up to test them in more at sort of almost pack level. The process that my main expertise is around the manufacture using environmentally scaled up processes. So we go away from fundamental recovery of materials to the of those materials. I am involved in projects where we are making kilograms of these active electrode materials or electrolytes. So one project making solid state batteries, another project making high power lithium ion cells. So that, it's a very broad range of projects. In particular, and Norman alluded to it, we're obviously very interested in some of the chemistry and how that could be relevant to the global battery agenda. Particular, if you think about these ideals for society, the UN Sustainable Development Goals, number 7 is clean and affordable energy. And obviously that relates to the fact that there's many people in the world that just don't have even access to electricity. And we'll talk about some numbers in a minute. So why do we need decarbonized energy? And obviously I'm going to talk a little bit about batteries, obviously battery materials. Of course, we all are familiar with global warming. In the UK and many other countries, they have signed up to reducing their carbon emissions, and UK by 2050 has signed up to 0 carbon emissions. So we have to start to decarbonize our energy. Obviously, for those of you who live in Lahore and other very highly polluted cities, I'm sure you'll understand the importance of getting rid of fossil fuels simply due to public health and similar problems in many cities around the world. I would say even in London before they started to reduce emissions. And obviously, what we want to do is to make a benefit of the fact that many of the energy harvesting costs, so if you look at the price of solar cells, is coming down year upon year. So what we'd like to do is by using some sort of battery, as Norman alluded to, and others, we want to be able to take advantage of the fact that these cells are coming down in price. And some of the chemistry around them is actually, for example, in solar cells, they don't require such fancy facilities for manufacture. They can be made in pretty much anywhere in the world without a huge investment, if you take something like the perovskite solar cells. And of course, the nice thing about decarbonized energy storage or batteries is that you can deploy them, as Norman again alluded to, off-grid, on-grid. You can have them in very remote places. And so this can be very good for disaster relief, and also the fact just being modular for being deployed very rapidly. Why is the UK interested in batteries? Well, we have an existing manufacturing of normal petrol vehicles. But as the world is moving to electric vehicles, the UK has realized that it doesn't have the capabilities to build electric vehicles. And we have a number of car manufacturers, and it's, the market is massive, not just in the UK for our home market, but also for Europe potentially. The problem really is that, as I said, we don't really have any gigafactories. And I mean, Norman just now alluded to the fact that, the price of batteries is coming down. The price of batteries is coming down because people are building gigafactories. And in order to actually make a price of a battery low, you actually have to do something on a massive scale. You have to buy raw materials on a large scale. You have to produce batteries on a large scale. And the UK has given millions and in fact billions of funding available to make that happen. They have already announced 1, possibly 2 gigafactories, and they've already invested hundreds of millions of pounds in medium-range manufacturing facilities, such as the UK BIC, and also slightly smaller facilities, and heavily invested in universities and research centres to manufacture batteries and discover new materials. So this has required an absolutely tremendous investment from the government, and of course this is required to woo the manufacturer to come to the UK to do this. without that, the electric vehicles will just not be possible in the UK to manufacture. And the other reason is due to security of supply. There's a question about lithium. There are many issues about lithium, but one of the issues is, can you get hold of lithium in the future? 20 years from now, will you be able to get the lithium? Because if you can't get the lithium and you rely on lithium batteries, then you're not going to have a car industry relying on it. So one of the things I'm going to talk about in a minute is about what are the alternatives to lithium that could be much better, but it needs quite a bit of R&D investment. Okay, so I'm going to skip through a few slides because I was trying to get across information about the fact that many Pakistanis have limited access. About 40 million also have no access to electricity. But I'm going to skip that because I'm assuming other people have spoken about it. So I'm going to move on. Let's think about energy storage technologies. So obviously there are many different possible ways you can store energy. I'm very interested in supercapacitors because nanomeasures, which is what we manufacture, seem to be quite suitable for this type of technology. So this is very rapid energy transfer. And of course, lithium-ion or other batteries. Now, it was nice to see the bark box from Norman Saab just now. And of course, there is an existing player, the B box, which is this, I think it was founded at Imperial College. It's a small company that spun out and is certainly very active across Africa and other places. And I think, as a British Pakistani, I'm very, many people live outside or outside like me. We all visit with our families and we're very aware of the issues in the past about, obviously, blackouts and brownouts. And so even as a child, I was very interested in how these types of devices could be utilized for the benefit of people. And it's nice to see that through LUMS and others and industry partnerships, they are very progressive and that they are trying to develop alternatives. But again, those alternatives, as Norman pointed out, are based on lithium-ion technology, which is currently the best technology out for the point, and also the fact that you can use from China. That's absolutely right. But let's try and think a bit ahead to the future. Okay, so when we look at the performance of batteries, I see Norman alluded to lead-acid batteries. So if you think about the specific energy, so how much energy can this thing hold per kilo or per liter, depending on your volumetric or gravimetric. So in this case, this is gravimetric energy density and specific power in watt per kilo. We can see that things like capacitors are good for high power applications, but they can't store much energy. Whereas a lithium-ion battery in this red band here, you have the possibility to either have high energy or have high power or a combination of both moderately. So these lithium-ion batteries are very popular. And of course, the different electric vehicles that are currently on the market, they require higher energy, specific energy, at reasonably similar or higher specific power. This is because essentially you can't hold enough. I mean, cars are often focused on volumetric energy density. So how much energy can you store in a certain amount of volume, because a car has a fixed kind of volume space that you can use for the battery. And of course, we need to store more and more energy in the same amount of space. Whereas, as Norman Saab pointed out, on grid storage, the volume that you take up doesn't really matter. You have plenty of space to store your battery and your module in a house or somewhere like that, or a dwelling. It's not a problem. But for cars, it is very much a problem. So we can think about different batteries, different characteristics. For something to be useful in small to medium transport, it's going to have similar properties clearly to the lithium-ion, or better, or even slightly worse if it's a lot cheaper or more sustainable. We're not really trying to go back to the days of lead acid, as Norman Saab pointed out, for a number of reasons, including round-trip efficiency. So here's a simple battery. This has got a graphite anode and a lithium cobalt oxide cathode. And typically, of course, as you're charging and discharging, you're transferring lithium ions between the electrodes, and you have the separator in the middle. And of course, this whole thing is filled with lithium ion electrolyte, which allows the transfer of lithium ions on charge and discharge. So this is a very simple device. At UCL, we actually run undergraduate programs where students will actually make their own materials and their own coin cells. In fact, that's running right now in UCL today and the next few weeks. And this is something, with reasonably, reasonable simple setup, you can really establish a very sort of small scale battery materials testing facilities. We're also very interested in rapid charge and discharge. In China, for example, there are a number of technologies in transport where they are using these fast charging stations. So these sort of high power applications could be useful. So what they do with these buses is they basically have a battery in there that's it can charge up in about 15 seconds, and it has just enough energy to get to the next bus stop where when it stops to let somebody off or on, the battery just charges up. So there's sort of alternative ways of looking at transport, particularly when you have sort of centralized transport, such as these fast charge buses. You can also have something in between a battery and a capacitor, which we call a hybrid supercapacitor. And that usually involves an inorganic electrode with a sort of carbon-based sort of capacitor-like electrode. And those have been shown to have a slightly higher energy density with similar power, specific power capabilities. So those are devices that we've been working on for about the last 7 or 8 years. The advantage of the nanomaterials that we make is they have this reasonably high surface area. So on your, because a lot of the charge that's stored here is a specific type of charge, which is sort of fast Faraday pseudo-capacitive charge, or it's just double layer charge. This is a type of charge that's stored very quickly between the electrodes. So this is very suitable in terms of your device architecture. And of course, the other applications of these are sort of power tools where you want to just, if you have something like a drill, you can put it down, charge it up in about 10 seconds, use it for a couple of minutes, put it back down, it'll charge up again in 10 seconds. And, there are various devices where this type of charge and discharge is very useful. And I think on the trucks, this is sort of cold cranking. So the difference between a normal material, a micron-sized material, and a nanomaterial is, as I said, this kind of pseudo-capacitive charge storage. So generally, you'll get classical intercalation in your cyclic voltammeter. You'll see well-defined peaks for lithiation and then delithiation. And when you move towards a sort of double layer charge storage where you're just using this sort of charge shuttling for a super capacitor, you normally see this box-like behavior, and this is essentially instantaneous transfer of charge. In the middle, for nanomaterials of inorganic nanomaterials, not carbons, you generally see this kind of weird hybrid between the two. The advantage of this is that often in nanomaterials, you have the ability, as I said, to both store quite a lot of energy, but also transfer energy quite quickly. So you've got the best of both worlds, essentially, with these materials. And the two charge storage mechanisms, as I point out, one is essentially double layer charge transfer. The other one is the surface reaction on the nanomaterial, which is this fast Faraday chemical reaction. It's not classical intercalation necessarily, depending on the charge and discharge rates of these materials. So there's a number of interesting materials that are of interest for cathodes, and here's one is lithium iron phosphate. It doesn't have the high energy density, perhaps, such as certain materials like nickel manganese cobalt-based cathodes. It also has issues with low ionic electronic conductivity, but you can overcome many of these problems through adding carbons and coatings. And also, the nice thing about this is that it just contains, if we look, iron, phosphorus, and lithium. So phosphorus and iron are relatively abundant, cheap materials, and that's a big advantage. When you move over to things like NMC, nickel manganese cobalt, which is the current generation of electric vehicles or hybrid electric vehicle batteries are using some kind of, or coming generations, I should say, because some of these NMCs are still in commercialization phase. In particular, the one that has a ratio of nickel manganese cobalt, which is 8:1:1 in ratio of the metals, that's nickel manganese cobalt. That one has amongst the highest energy density because it has nickel, so you can go to higher voltages, so you can store more energy. Now, that particular one, and many of the NMC family, one of the problems there is that you have a lot of cobalt, or a certain amount of cobalt. And of course, cobalt is a problem that I'm going to come to in a minute. It's a political problem. So it's not that you can't get cobalt, it's just the fact that it's mined in the Congo from child slavery or a political regime that is not favored by the West. So people don't want to get cobalt from the Congo. There are very few places to get it. So these are all the kinds of considerations. Okay, what I'm going to do is skip a couple of slides just to maybe speed up a bit. So what are the challenges for materials? Well, we need to look at the abundance, the cost and price stability, very important. Certain metals, the price is very unstable. And this is a problem when you're trying to commercialize something. Lithium is one of those, actually, funnily enough. The price of lithium has started to go up and up and up. If you look at latest reports. And again, if you base your battery technology on lithium in the future, if the price keeps going up and the availability of lithium keeps going down, it's a really bad business idea. So we want, in the West and other countries, if we are going to manufacture batteries ourselves, we want security of supply, whether it's lithium or sodium or whatever we use in the bubble batteries. We want to be able to get it without having to worry about where we're going to get it from or the political ramifications. And of course, we need to think about the impact on the environment, about recyclability. And what we often do is something called a life cycle assessment, where we actually look at every single stage of the use of the materials from the battery, from the actual mining all the way to the recycling and all the stages in between. How much energy is used, how much waste is being produced, how much raw material goes in. And you basically do a full calculation of this, and then you consider what is the best material or best things to, how to use it better to be more efficient in terms of energy use, in terms of sustainability as well. So these are things that you get taught at undergraduate level chemistry or chemical engineering. So when we think about materials and devices, we need to think about many different things, how we are going to make it, how energy efficient that is and chemical efficient. What are the properties of the materials in the battery, the crystal structure, and how easy are they to recycle, and what are the safety and toxicity considerations? And also, are there any socioeconomic factors or political factors as well? And all these considerations should be taken into account. So when we look at choosing a choice for battery materials, we need to really look at, this is a plot of abundance, and this is compared to per 10 to the 6 atoms of silicon, and silicon is one of the most abundant elements. So if we compare this to 10 to the 6 atoms of silicon, which is here, these are our most abundant elements here. And we can see that some interesting elements I'll point out. Here's lithium, which is not necessarily as abundant as other metals such as sodium, aluminium, potassium, magnesium. So it's no wonder that many of these metals are of interest in next generation batteries. You've got iron and titanium. Again, you have transition metals, again, which are many of these. Here's cobalt, not necessarily that abundant in the earth. And of course, as I said, there is an issue politically. So when we look at many of these metals, we want to have battery technologies that can exploit some of these elements, perhaps in our favor. Here's sulfur. I'm going to mention sulfur as well. Not just in batteries, by the way, we also do the same consideration in solar cells or any other energy materials related technology. And here's a nice little figure from David Cole Hamilton, where he actually looked at the different elements of the periodic table to try and identify elements that would be under serious threat in the next 100 years or have a rising threat, as shown in orange. So here's cobalt. I mean, it doesn't have political threat, but cobalt would definitely be there as one of them. And of course, so there's limited availability of some of these elements due to, and of course, many of these elements are becoming more and more of interest. If you take something like niobium, this is now becoming one of the most important anode elements for high power batteries. Yet it is in limited availability. Of course, that might improve in the future, but there'll always be, some pressure, whether it's just availability or other factors of toxicity that are always going to be the issue. Okay. One of the ways that, so at UCL, one of the ways that we are trying to look at how to have more sustainable materials is to think about using high throughput techniques. Over the last 3 years, we've been working in what we call materials discovery. One of the areas has been in the area of magnesium ion batteries, for example. And what we're trying, and so this slide here is showing you a future plan that we've got to develop our technologies. At the moment, we can do what's called high throughput synthesis. We make lots of materials and we basically screen them. So we do this analytical side. We look at them as batteries. We look at their properties of the materials. What we'd like to do in the future, so when we make these materials and test them, we essentially just make them and test them, and then we try and understand through modeling and other things
about why these materials might work better as a magnesium cathode or another cathode, lithium or sodium. But what we'd like to do is make use of some of the technologies that are out there in terms of artificial intelligence in particular. So where we're moving to in materials discovery, with a view to discover more sustainable elements for batteries, for cathode materials, for anode materials, is to really make use of AI, try to use databases and data in a smarter way with machine learning and trying to use that in a sort of continuous loop of improvement. Many of these ideas for high throughput material synthesis come from the similar ideas around drug discovery, how we discover drugs. We make a lot of drugs, we test them and screen them, and we find the good ones, and then we try and design the next iteration of drugs. So this is a kind of similar thing, but just done with materials. And there are projects all over the world that are doing a lot of this, but not necessarily an experiment. They're actually, a lot of them are doing it through modeling and computer modeling. It's not the same thing. The difference with our UCL collaborators and UCL is that we can actually do a lot of these syntheses in high throughput. We can actually make hundreds and thousands of materials very quickly and screen them. So this is one of the things we are doing. In fact, I had a PhD student starting from Punjab HEC called Zebi, and she started last week, and her project is going to be looking at high throughput synthesis and discovery of sodium ion cathodes, because we're very interested in sodium for reasons I'll explain. Okay, our time is getting on, but I hope I've given you an idea. Oh, the other thing is that when we discover these materials, we make them in very small amounts. So the other thing we need to be able to do is to scale them up. So in UCL, we've established maybe 10 years ago now the scale-up synthesis of our materials using this sort of pilot plant process. And because you're not chemists, majority, I'm not going to go into the chemistry about it today. What other things is the UK doing? Well, the UK has many projects. These are funded. This particular one, which we were involved in, was funded. It was about £13 million. So if you convert that to rupees, you see it's a big project. And the sole purpose of this project was to look at degradation in anodes and cathodes. One of the reasons for that is to improve the lifetime of batteries. And in the UK, we're very blessed with national and high quality facilities. And so what this is doing is throwing lots of different analytical techniques at the battery, both in operando, so whilst the battery is running, and also after the battery is running, you take it apart and have a look at it. But we're using all range of analytical techniques here that's just shown in the slide, so I won't repeat which techniques we're using. I think Norman mentioned Second Life, so I'm not going to talk about it, but I think recycling is very important. And I think that, there are, even in Asia now, people are starting to look at the fact that if batteries are coming in, yes, I won't repeat what Norman said about this excellent answer to the fact that you can, once they get to 80% electric vehicle batteries are no good for the vehicle. But of course, once batteries come in, you have that supply of lithium or sodium or whatever, well, lithium, let's say, which is the important one. You could recycle that, but you would need to remanufacture that. And I think getting Pakistan, I know from talking to the science minister in Pakistan and others, it's going to be very difficult to get anyone to build a gigafactory in Pakistan, if we're honest. And this is because why would they, when they have China is right now, is a good friend of Pakistan and right on their doorstep? Would they want to do that? I'm not sure. But there are opportunities for recycling, and I think that it's this is an area that the UK has also funded quite a lot of money in to academic projects. Now, I want to talk about sodium and magnesium ion batteries. We're one of the few UK groups that is actually working on magnesium ion, and some very few groups. One big project on sodium, which we're not involved in, but we have our own sodium ion projects as well. And there's a big advantage here. Sodium and magnesium are much more abundant in the earth. You can extract commercially things like magnesium from seawater and sodium, of course, right? So you never have a security of supply problem. Many of the best sodium ion batteries are actually not quite as good as the current lithium ion. But if you consider the fact that you're not relying on lithium, it's a big plus. In fact, in India, the Faradian is a company that's been out in the UK. They are developing sodium-ion batteries for commercial vehicles, and India has signed up to this company. I'm not related to this company at all, but they have realized by replacing lead acid, getting into the sodium-ion battery production, this could be a real win for them in terms of small vehicle transport or even just grid storage. I mean, 90% of grid storage could be addressed through these alternative technologies because lithium ion is just very expensive. We know that compared to, these sort of scales. But when you scale up and you go to sodium, you could actually use the existing similar plants for sodium if you switched over, and also for magnesium. Many advantages of magnesium, you can get much higher energy densities, but it's more challenging because you've got magnesium is a 2+. So you get double the charge per atom, which is a massive plus, but it has issues of trying to intercalate and deintercalate. It's a lot more harder because you've got to overcome that 2+ charge going into a structure and back out again. And there's the challenge. And very little work has been done on magnesium. In comparison to sodium, a lot more work's been done. And I think that's much closer to market, as we can see from this slide effectively. The number of patents is going up year upon year. So it's showing more and more interest. In the West, in particular in the UK, not much work in magnesium. Americans have tried magnesium and really found it difficult. Europe is now starting projects in magnesium as well. And companies like Honda are already getting involved in grid storage magnesium technology using organic-based cathodes. So I think the future for magnesium could be very bright. And as I said, there's no shortage of magnesium. I mean, sodium and magnesium are the 6th and 8th most abundant elements in the Earth's crust, at about 2.5 and 2.4% abundance. So that is pretty high. I mean, this is orders of magnitude higher than lithium, I believe. Other types of anode materials. Here's an alloying material. So this is zinc ferrite. This can, as an anode, it's very good. It can store lots of energy. One of the problems is it has what's known as a conversion mechanism, which is essentially means the material changes its shape and the chemical elements revert to the metallic state often. So the problem there is that the material is not so stable under cycling. And one of the ways to get around that is to coat it in a carbon coating, and it retains much, much better stability. So these are interesting because you're using elements such as iron and zinc. They don't pose a problem necessarily from a toxicity point of view and an abundance point of view. Very good. So again, moving away from niobium cathodes, or anodes, would be a good thing. And of course, there is still graphite out there, which is the gold standard. Lithium sulfur technology, there's been a big project announced in the UK in the last year or two. You're trying to develop lithium sulfur. Similar problem, that you're using something where it's changing its shape upon cycling. And so again, you're using a carbon coating to try and keep the lithium sulfide stable so it doesn't pulverize and fall to bits as you start cycling it. But if you can mitigate this volume expansion that occurs as well, and there are ways of doing that, which I won't go into, but what's nice about this chemistry is just lithium and sulfur. It's very simple chemistry. I know it's got lithium in it, but the point is that it's a relatively straightforward technology in terms of there's no cobalt involved, there's no toxic nickel. So there are many advantages of that. So look, I just wanted to sort of round up really. I think I'm getting out of time. I really wish I'd seen Norman's talk, so I hope I can get hold of a recording of that to see if we actually said the similar things. But I think the main thing is that there are many opportunities for Pakistan in energy storage. Look, there are many technologies I didn't talk about. There's aqueous batteries. If Pakistan was able to develop aqueous batteries, there's companies like Aquion that have been around for a long time. There are some slightly different challenges, but aqueous batteries could be manufactured without specialist facilities, like you need a gigafactory with special handling facilities, because of course when you make lithium-ion batteries, you need to handle the lithium in dry rooms, which is a particular problem. If you got into other types of technologies such as aqueous, you don't need any of that technology. You could do this on a large scale or a small scale. It really would be very much doable. So, I think it would be great for Pakistan to really look at different technologies, somebody to actually have a proper look at what could be doable within Pakistan, because so that you have the control within your own hands and you don't rely on neighbors or others. You should have the control in your hands and the technology in your own hands. So there are opportunities, of course, in the grid to improve your resilience, to use indigenous resources, to change the decarbonization of transport, and to develop your own recycling in-house, just like you do with lead acid at the moment. You recycle, obviously a lot of the lead, I believe, gets recycled. You need to bring multidisciplinary teams together to deliver this, all the way from materials people, software people, electrical engineers, you name it. So thank you for that. I mean, just one thing to say is obviously somebody mentioned the charity upsign that we run. We started in 2017. This is basically trying to collaborate and bring together UK-Pakistan research for the benefit of both countries. We also do some work in the UK to support British Pakistanis, but I think our passion lies in collaborating with Pakistani researchers and helping in any way we can. A year ago today, I was meeting the Prime Minister Imran Khan, about a year ago today, when we delivered some big workshops to try and get grant collaborations, grant workshops with about 150 academics. I know Norman and others were there, Naveed, Saab. I mean, we are now moving into other things. In particular, we are interested to develop supervisor training for PhD supervisors. And so we are working with Pakistani and UK partners to develop courses with the Punjab HEC and others. And inshallah, those training courses will, once they are developed and we'll be ready to deliver them, we'll be very interested to talking to people about this in the future. This is called the GAP project, the Good Academic Practice. And we want to try and get the best of both worlds. Thank you for your time, and happy to have some questions.
Thank you very much, Professor Dahl. We have a question from our participant. And the question is, sodium-ion batteries give very low capacities with graphite anode. Other materials such as tin, antimony, or phosphorus have low cycle life. Sodium is also heavier than lithium. So do you think it will be a good for electrical vehicles?
Okay, so at the moment, so I just unshare in a minute. Okay, so at the moment, Ferradian, who is probably one of the world leaders, I would say, based in the UK, it's a small company. They have signed deals in different countries, Australia and India, I just mentioned. They already have products which are much superior to lead acid, just like the slide that Norman showed with the lithium versus the lead acid, what the different performance characteristics are. So so round trip efficiency, sodium 90% odd versus lead acid, which is, I don't know, 60, 70%. So all the other characteristics of lithium, sodium is not that much worse. Let's be clear. It is good for small vehicles. So e-bikes, they already developed products for e-bikes. And so small transport, I don't know whether they would be scalable to a tuk-tuk level, yeah? But clearly for grid, the big advantage is for grid, because in the grid level, the volumetric energy density doesn't matter so much. So if you take all the different factors in consideration, price being one of them, again, when you do this on a large scale, the price comes down. So, you have to look at the key metrics, right? Price, performance. Performance is going to be up there. And the more we do more research, I mean, the lithium-ion battery was discovered, 1980s. So 40 years later, we've had 40 years of lithium-ion. Sodium-ion, we haven't really put that much effort into, but we are now doing that, particularly in the UK with these big projects. And I'm sure that it will only get better. So, you've got to assume lithium is just not going to be available in the quantities. Okay, recycling we'll have some lithium because of recycling, obviously, that will come. But I don't think it's going to meet the expansion. So, lithium is a really strong contender on performance and price.
Yes, thank you. Another very interesting question that we also got from the participants is related to the application of lithium and batteries in electrical vehicles in Pakistan circumstances, for example, especially in summer season when we experience temperature something like 40 or 45 degrees Celsius. So what are your thoughts on this kind of situations?
Well, I mean, obviously, if a battery gets too hot, it could degrade, right? But that's why you've got these battery management systems, or you potentially, if it was grid storage, you could include some sort of cooling, of course, right? If it ever became a problem, if it was really hot and you needed to do that. So I think Norman kind of answered that question about temperature problems, or I mean, the funny thing is some technologies work better at higher temperatures. So I know, for example, that when you run NMC cathodes in lithium ion, they work better at 50 or 60, but maybe the lifetime will just go down a bit. That's probably what suffers. Magnesium ion, which is at a very early stage, works better at 50 degrees. It works even better at 110 degrees. So, but then again, you worry about, you're never going to get to 110 degrees, obviously, because you boil. But I think the point is that it's important to look after the health of the battery, and the chemicals which are organic will degrade, and temperature is one of those factors that could accelerate that. But there are so many other factors, water and other things, that can also mess it up.
Yes, thank you very much. So we are at the end of our session. Thank you for a very thoughtful presentation on this subject. At the end, I request our team to present the shield.
Oh, so. Thank you very much.
Unfortunately, at this situation, we cannot share a physical shield, so this is the only option. So we are at the end of our session. Thank you all our participants and distinguished speakers. Now we will have a lunch break for almost 1 hour. We will resume at 1:45. So stay tuned and join us at 1:45. Thank you, everyone.
Assalamu alaikum. My name is Imran Ali Shah. I am managing Energy Lab, Al-Khwarizmi Institute of Computer Science, also providing services in Center for Research and Development, which is a state-of-the-art research and testing facility located in the new campus of University of Indian Technology, Lahore, Kalasha Kaku. We are providing different kind of services like consultancy services, third-party validation services, energy auditing services, and we have some kind of research from technology development program from HEC and also NRPU program, and we are also providing training services in related to energy sector. We are providing consultancy services, the energy department. In this consultancy, we are providing energy auditing services for 40 DHQs located in 36 districts of Punjab. Funded project we have done recently in HEC installed 55 kilowatt solar system and search the behavior variety of the events and the angle that can impact on the energy generation. Secondly, we have some projects. We have developed a cleaning robot that will be very effective to save the water and provide high efficiency of the system. And we're also working on TDF project funded by HEC. This project is you can say that it's a municipal waste to energy. We can convert the plastic waste, medical waste that is very harmful for the people, and we can convert this plastic waste to energy by using some nanoparticles that we are developing in our lab. And this project we are developing with the help of JV partner from NC Islamabad. And we are providing training services with NAVTEC, that is the federal government department, and same is we are also doing with the Punjab Skill Development Fund program. Testing services, we have developed one of the state-of-the-art lab in PV testing lab in Kalasha Kagu campus, and we have developed LED testing facility over there. We have state-of-the-art facility available, which is one of the largest and one of the best facility available. Recently, we have done a project in University CBS and called 1 megawatt solar system. The same is the case. We have provided technical services to the University of Indian Technology Lahore, the PD department, for installing 1 megawatt, which is the first ever PPA project in the public sector institution.
Assalamu alaikum. Battery has been a critical component in energy storage especially with PV systems, and has been often misquoted by suppliers by dodging the actual values of battery systems. Battery Tester is a co-optimized solution which can help estimate the battery capacity with higher precision and validate the claim of rated values, which leads to the better system design and ultimately helps to reduce the risk associated with battery backup systems.
Assalamu alaikum. I am Quratul Ain, working in Energy Lab in Al-Fazl Institute of Computer Science, UET Lahore. With the increment of PV integration in the energy mix of Pakistan, an underlying problem faced is the cleaning of solar PV modules. Currently, our market is not addressing this problem properly, and the soiling problem reduces the energy generation hugely. Therefore, a localized and efficient solution is required to fill this gap in the market. A self-cleaning report for PV modules has been developed and designed by our team under EGC-TDF fund. Our robotized solution not only reduces the time, but also labor needed for cleaning tasks, and it increases the energy generation by an approximate 5%. The activity of this device can also be controlled remotely through GSM or Zigbee. The payback of our robotized solution spans over 12 to 18 months with an expected life of minimum 5 years.
The light testing services that we have in CERAD are the electrical and photometric test, chromaticity test, harmonic current emission test, impulse test, LED driver test, salt spray test, IP and IK test. The electrical and photometric test used to determine the luminous intensity, luminous efficacy, light distribution diagram, and the other electrical parameters. For that purpose, we are using the gonio spectroradiometer, that is a D-type gonio for near field detection, and we also have a C-type gonio that's used for the near field and far field detection. IES files also produced using this setup, which is further used for the simulation of lightning models. The integrated sphere is used for the chromaticity test, in which the color index and the correlated color temperature were measured. Harmonic current emission test is also done using the power meter that is integrated with this integrated sphere, and it can determine the harmonics of the current and voltages. We have a temperature and humidity chamber which is used for the damp heat and environmental test. In IK test, an impact of 5 joule is applied on the linear body at different points to assess its withstand capacity. We are offering following tests in CERAD. Few of them are the determination of real power at STC condition using the sun simulator that can emit a light of 1000 watt per meter square at a temperature of 25 degrees C, and air mass is set at 1.5. IV and PV curve also determined using the sun simulator. Another test that we have is the EL test, that is named electroluminance test. EL test setup capture the image of the PV module whose quality is assessed to detect the cracks and defects on the PV module. Bypass diode test is also used for the PV module. Bypass diode thermal test is used to assess the adequacy of the thermal design and long-term reliability of bypass diode. Another test that we have is the ultraviolet preconditioning test. Ultraviolet preconditioning test is used to identify the degradation of the PV module material through ultraviolet radiations. Module breakage test is also applied to the PV module to determine the strength of the PV module. And mechanical load test can determine the ability of the PV module to manage the mechanical load and stress of the PV module.
Assalamu alaikum. My name is Mohammad Amza Latif, and I'm working as a research assistant in Internet Energy Research and Innovation Lab, UET Lahore. In addition to that, I'm also working as an instructor for PSDF and NAFTA courses. Ultimate aim of these courses is to target the renewable energy sector. In renewable energy sector, they target solar, they target wind, they target geothermal, and they target hydel. The main focus of these courses is to create employability in the market and to make the students self-sufficient so that they can create their own startups and create jobs in the market. Last but not the least, one of the ultimate aims of these courses is to enhance the R&D sector and to make them self-sufficient so that they can pursue their careers and they can start their masters and PhD, and they have the prerequisite knowledge to pursue their higher education.
Assalamu alaikum. My name is Muhammad Ali, and I am working as Senior Research Manager at Al-Khwarizmi Institute of Computer Science and also providing support to CERAD labs. We are working on various energy efficiency related projects, especially related to the industrial sector. We started off with the energy efficiency course funded by GIZ Germany, where we have senior level people from industries coming over on weekends to get hands-on training. We also developed a motor testing system based on IEC standard. The motor tests the running efficiency of induction motors, which is very important in decision making for motor replacements or making improvements. We won a project from UNIDO for sustainable energy initiatives for Pakistani industries, focusing on paper and pulp and ceramics sector. We won a TDF project from HEC on solar inverter development. It's very essential for us to get these products in Pakistan for customized needs, preserve foreign exchange, skill development, and job creation for local engineers. We won funding again from HEC for pump testing system development. The system tests the efficiency of centrifugal pumps, giving a lot of benefits to its users. We are working very closely with PICA for establishing AC testing lab at CERAD, Kalachao campus. The lab will test energy efficiency ratio and coefficient of performance of air conditioners, in addition to various other parameters mentioned on the nameplate. We are also offering short training courses on energy efficiency, programmable logic controllers, industrial instrumentation, in cooperation with NAVTTC and other funding agencies.
This project tends to determine the efficiency as well as the pump curve of pumping system. In any industrial or commercial facility, we can determine the pump curve from ratio of flow rate and the head of the pump. This solution gives us the real-time efficiency data of pump of industrial or commercial systems. The test bench duly equipped with PLC, programmable logic control, the VFD, variable frequency drive, from which we can change the speed as well as the technical parameters of pump as per demand. All parameters and real-time data are displayed on a HMI screen. This demo test bench contains 1 HP motor of 3-phase power. This project has been awarded from HEC through TDF Technology Development Fund. Thank you very much.
The project is to develop an economizer to control and automate the pigmentation of leather skin with minimal pigment waste at less cost. This system to automate the leather spraying process is locally developed and presented for the first time in Pakistan leather sector with high precision and calibration. It immediately becomes pure and has installed on very finishing across the country. And it is working. The leather skin are placed on the conveyor of the leather machine and pigment coating is done by solenoid spraying guns placed on carousel. Economizer detects the speed of the conveyor and carousel and convert the area of the leather skin into the digital format using IR scanner. After computation of calculation, it directs the guns to perform the efficient spraying. It also provides the user-friendly interface and flexibility in adjusting the parameters required for the process. And what is more, the system at the end of the working day gives you more than the 25% saving, thus entirely repaying itself within a few months.
Pakistan is faced with energy crisis due to shortage of 7 gigawatts of electrical energy. 65% of the electrical energy is produced by thermal resources, among which coal is the cheapest. This makes it inevitable for us to move towards coal power generation. However, the problem is, in Pakistan, the coal quality is very low, so we need to process it to make it suitable. Here, our facility, Mineral Processing Research Center at Mining Engineering Department, University of Engineering and Technology, Lahore comes in. We collected samples of 32 million tons of Punjab coal and 130 million tons of Khyber Pakhtunkhwa coal. We processed it through crushing, grinding, flotation, and gravity separation, and we have made it suitable for power generation. In addition to this, we are also committed towards renewable energy storage. For this, we are recycling printed circuit boards and mobile batteries to extract the raw material for lithium-ion batteries manufacturing. For printed circuit board recycling, we are using cables, electrostatic separators, magnetic separators, leaching. While for mobile batteries, we are sticking to crushing, screening, and smelting.
Assalamu alaikum. My name is Dr. Tabish. I'm working as assistant professor in Chemical Engineering Department, UET Lahore. Every year, millions of lives are lost because of drinking contaminated water. Availability of clean drinking water is a basic human right, and water contains several pollutants including chemical and biological.
Biological contaminants are the most concerned one because they contain microorganisms, and those microorganisms lead to several diseases and at the end casualties. There are several techniques to disinfect the microorganisms, and those techniques include ultraviolet radiations, reverse osmosis, chlorination, and ozonation. Reverse osmosis is a versatile technique, but it's expensive to buy and difficult to operate. And ultraviolet radiations, they have technological limitations because of the transmission limits of the ultraviolet radiations within the turbid water. Ozonation and chlorination, they produce disinfection byproducts, and disinfection byproducts, they are harmful in the treated water. We are working on another technique, that is electrochemical disinfection. Electrochemical disinfection works on the principles of electrochemistry. On the electrodes, electrons are generated, and these electrons directly disinfect the microorganisms. Alternately, several chemical radicals are produced, and these radicals include hydroxyl radicals, ozone and oxygen radicals. And when microorganisms come in contact with these radicals, they become hibernate and disinfect. The overall electrochemical disinfection system, it contains pre-filtration process, electrochemical disinfection process, and the post-filtration process. Pre-filtration is to ensure the removal of particles that are more than the micron size. Electrochemical disinfection removes the microorganisms, and post-filtration is to remove the dead bodies and also to polish the treated water. This electrochemical technique against the competitors, it offers several advantages. For example, the low environment compatibility, easy to operate, and their preservative effect in the treated water. Major target of this project is the underdeveloped and developing countries, especially the low-income communities of Pakistan. In the flooded areas, the flood water contains all these microorganisms, and in the flood time, it becomes very difficult to supply the drinking water. We are working on the development of a flood water treatment system for the drinking purposes, and the electrochemical technique will be applied in the process. System will be mobile, so it can be carried out to any location, any flooded area.
I'm Hafiz Waqas, working as an assistant in Motion Control Research Lab in CERAD, UET Lahore. Motion Control Research Lab conducts its research in the multidisciplinary and electromechanical projects, keeping in view the energy needs of the Pakistan. MCRL providing its services in the advanced green energy, using efficient tools to design and develop the best products to fulfill the energy needs of the Pakistan. In this regard, we are working on the concentrated solar thermal power plants, in which we have designed and developed dual-axis solar tracking heliostats, dual-axis solar tracking parabolic dishes, and single-axis parabolic troughs, in which we will focus the sunlight onto the central focal point and then to rise the temperature of the water. After that, we will run the steam turbine to generate the electricity to eradicate the energy shortage of Pakistan. On the other hand, MCRL is working on the energy efficient electrical vehicles, in which we are working on the BLDC motor and its drive with the regenerative braking system. In the end, I would like you to visit our stall, and I would like to thank all of you to visit ICECE. Thank you. Parabolic trough is a type of solar thermal collector that is straight in one dimension and curved as a parabolic in the other two dimensions. The upper surface of a parabolic sheet is then lined with the polished metal mirror. The sunlight which enters the mirror parallel to its plane of symmetry is focused along the focal line, where the pipe containing the fluid with the high coefficient of thermal resistivity are positioned that are intended to be heated, which leads to produce steam from the water by providing the stored heat. Modeling and simulation were carried out on the SolidWorks and simulation software, and analysis of its structural integrity, weight, wind load, resistance was successfully done on the SolidWorks and ANSYS simulation software. Single-axis solar tracking system has been implemented on the PLC, and data has been integrated for the whole year. This single-axis solar tracking parabolic trough can rotate in 120 degree in elevation for the sun tracking the accuracy of 0.02 degree. Thank you. Programmable logic control (PLC) or a programmable controller is an industrial digital computer which has been ruggedized and adopted for the control of manufacturing process, such as assembly lines or robotic devices or any activity that requires high reliability, ease of programming and processes. PLCs can range from small modular devices with tens of outputs and inputs in a housing integral with the processor, to the large rack-mounted modular devices with the count of thousands of IOs and which are often networked to other PLC and SCADA systems. So we have developed the prototype of PLC trainer for the new graduates to have a good experience before getting into the practical industrial application. PLC trainer prototype has been designed and developed. Application manual of PLC trainer is ready for the trainer classes and educational institute. Radar is a detection system that uses radio waves to determine the range, angle, or velocity of the object. It can be used to detect aircrafts, ships, spacecraft, guided missiles, motor vehicles, weather information, and trains. A radar system consists of a transmitter producing electromagnetic waves in the radio or microwave domain. A transmitting antenna or a receiver antenna is used for transmitting and receiving, and a receiver and processor to determine the properties of the objects. Radio waves from the transmitter reflects the object and return to the receiver, giving information about the object's location and speed. Modeling and simulation of this structure was carried out on the SolidWorks and ANSYS simulation software. Analysis of its structural integrity, weight, and wind load resistance was successfully done on the SolidWorks and ANSYS simulation software. Fabrication and integration of a main structure and slew drive is completed and deployed at the electrical department of UET Lahore. Dual axis tracking system of this radar is capable of 360-degree rotation on azimuth and 180-degree elevation for the active tracking system with the accuracy of 0.02 degree. Thank you. Dual axis solar tracking heliostats is one of the types of the concentrated solar thermal power plant which has the solar radiation energy, produces the electricity by heating up the working fluid, drive the engine and the turbine. Because the solar radiation is too low to heat up the working fluid, helium comes in, concentrate the radiation to rise the temperature even up to the 500 degrees Celsius. The purpose of the dual axis slew drives is to enable the mirrors to accurately track the sun throughout the day with the aid of the computer control system, and it accurately tracks with the accuracy of 0.1 degree, and it can rotate in 360 degree in both azimuth and elevation angle. MATLAB and SolidWorks were used to calculate the position and angles of the sun specific time each day. That is why this type of tracking system can accurately track the sun in both east-west and north-south axis. Modeling and simulation of this project is done in the SolidWorks, and analysis of its structural integrity, weight, and wind load resistance was successfully done in the ANSYS simulation software. Dual axis solar tracking has been implemented in PLC, and data logging for different days of year is taken and verified.
My name is Jamshed Iqbal Janjua, and I'm working as a Senior Manager Research at Al-Khwarizmi Institute of Computer Science. I work at the Power Systems Lab, and we focus on the research areas in the energy sector and the power sector related environments. And we work with the NTDC, CUPA, and different DISCOs in Pakistan to solve the problems related to the power sector and energy sector with some indigenous capacity building and software development and IT-based solutions. So we have developed a project named Unmanned Grid Control and Monitoring System. This project was a joint initiative with between NTDC and MAPCO, and it was funded by MAPCO as well. So the focus of this project is to control the monitoring and the grid control monitoring system mechanisms of the concerning DISCO. The system comprises of the two main parts. The first part is the hardware devices, which are responsible for the data acquisition and the control system, whereas the other part is the web portal, And this project is totally developed from the hardware to the PCB design, hardware, the firmware level, and the data acquisition systems, and then the portal in Al-Khwarizmi. The overall mechanism of this project is first of its kind and it is deployed on the 11 kV feeder panels on the grid stations, 220 kV, 500 kV, and 66 kV grid stations of MAPCO. And the hardware devices detect the faults and sends the information via GS and GPRS medium to the concerning control room. And then there is an interactive dashboard for the web portal. From here, the concerning grid control operators can actually manage the grid, and different kind of alarms and faults based upon the feeder and the transformers deployed in the grid stations are available in real time for the efficient management of the grid station. We have developed a project for the data communicator development for the grid control and monitoring systems. In this project, we have focused on reducing the communication cost that occurs when we collect data from the grid systems and relay it to the backend servers. So in this overall activity, the hardware was focused, and we have developed a data communicator that actually communicates with the local devices on the grid station and acquires the data through the Wi-Fi, and then after a certain interval of a time, the data is being relayed in a mechanism to the backend servers. And from there, those backend servers, we have dashboard available and a portal available, upon which there is a dashboard that can actually help to see the faults occurring on the transformers, on the feeders, incoming and outgoing feeders of the 132 kVA, 220 and 500 kV grid stations. And the grid control operators can actually control the different functions of a grid station. They can turn off the grid, they can turn on the certain line, and they can manage the load shedding management on this grid, on the concerning grid station. So this project was funded by USAID through the USPK centers, energy centers in Pakistan. The project is being now routed to be deployed at the grid stations of PESCO and the TESCO area, so that we can drive most of the benefit for the remote side configuration and the remote side controlling of the grid station.
Assalamu alaikum. My name is Imran Ali Shah. I am managing Energy Lab, Al-Khwarizmi Institute of Computer Science, and also providing services in Center for Energy Research and Development, which is a state-of-the-art research and testing facility located in the new campus of University of Engineering Technology, Lahore, Kala Shakaku. We are providing different kind of services like consultancy services, third-party validation services, energy auditing services, and we have some kind of research projects from technology development program from HEC and also NRPU program, and we are also providing training services in related to energy sector. We are providing consultancy services to the energy department. In this consultancy, we are providing energy auditing services for 40 DHQs located in 36 districts of all over the Punjab. Funded project we have done recently in HEC installed 55 kilowatt solar system and search the behavior of the variety of the irradiance and the angle that can impact on the energy generation. Secondly, we have some TDF projects. We have developed a cleaning robot that would be very effective to save the water and provide the high efficiency of the system. And we are also working on TDF project funded by the HEC. This project is, you can say that it's a municipal waste to energy. We can convert the plastic waste, the medical waste that is very harmful for the people, and we can convert these plastic waste energy by using nanoparticles that we are developing in our lab. And this project we are developing with the help of JV partner from NCP Islamabad. And we are providing training services with tech, that is the federal government department, and same is we are also doing with the Punjab Skill Development Fund program. Testing services, we have developed one of the state-of-the-art lab in PV testing lab in Kalasha Kagu campus, and we have developed a LED testing facility over there. We have state-of-the-art facility available, which is one of the largest and one of the best facility available. Recently, we have done a project in Karachi University, ICCBS, and installed 1 megawatt solar system. The same is the case. We have provided technical services to the University of Indian Technology Lahore, the PD department, for installing 1 megawatt, which is the first ever PA.
Good afternoon, ladies and gentlemen. Now you're watching Industrial Exhibition along with the exposition we are presenting you, especially from the platform of CERAD, Center for Energy Research and Development. We have so many labs comprising aerial lab. We have a lot more work that has already been done in the domain of solar. We have some wind turbines specially designed, indigenously designed by Center for Energy Research and Development team, and we have so many projects that are underway. So we are just sharing some valuable feedback that has already been taken from our own team, and that has already been developed at the center. So let me present you some projects that are being done at CERAD by our own team. So ladies and gentlemen, let's present you the industrial exhibition along with the CERAD's exhibition.
Assalamu alaikum. My name is Imran Ali Shah. I am managing Energy Lab, Al-Khwarizmi Institute of Computer Science, and also providing services in Center for Energy Research and Development, which is a state-of-the-art research and testing facility located in the new campus of University of Indian Technology Lahore, Kalasha Kaku. We are providing different kind of services like consultancy services, third-party validation services, energy auditing services, and we have some kind of research projects from technology development program from HEC and also NRPU program, and we are also providing training services in related to energy sector. We are providing consultancy services to the energy department. In this consultancy, we are providing energy auditing services for 40 DHQs located in 36 districts of all over the Punjab. Funded project we have done recently in HEC installed 55 kilowatt solar system and search the behavior of the variety of the irradiance and the angle that can impact on the energy generation. Secondly, we have some TDF projects. We have developed a cleaning robot that will be very effective to save water and provide the high efficiency of the system. And we are also working on TDF project funded by the HG. This project is, you can say that it's a municipal waste to energy. We can convert the plastic waste, the mineral waste that is very harmful for the people, and we can convert these plastic waste to energy by using nanoparticles that we are developing in our lab. And this project we are developing with the help of JV partner from NCP Islamabad. And we are providing training services with NAVTEC, that is the federal government department, and same is we are also doing with the Punjab Skill Development Fund program. Testing services, we have developed one of the state-of-the-art lab in PV testing lab in Kalasha Kagu campus, and we have developed LED testing facility over there. We have state-of-the-art facility available, which is one of the largest and one of the best facility available. Recently, we have done a project in Karachi University, ICCBS, and installed 1 megawatt system. The same is the case. We have provided technical services to the University of Indian Technology Lahore, the PD department, for installing 1 megawatt, which is the first ever PPA project in the public sector institution.
Assalamu alaikum. Battery has been a critical component in energy storage, especially with PV systems, and has been often misquoted by the suppliers by forging the actual values of battery systems. Battery tester is a cost-optimized solution which can help estimate the battery capacity with higher precisions and validate the claim of rated values, which leads to the better system design and ultimately helps to reduce the risk associated with battery backup systems.
Assalamu alaikum. I am Karatul Lan, working in Energy Lab in Al-Hazmi Institute of Computer Science, UET Lahore. With the increment of PV integration in the energy mix of Pakistan, an underlying problem is the claim of solar PV modules. Currently, our market is not addressing this problem properly, and the soiling problem reduces the energy generation hugely. Therefore, a localized and efficient solution is required to fill this gap in the market. A self-cleaning report for PV modules has been developed and designed by our team under EGC TDF fund. Our robotized solution not only reduces the time but also water and labor needed for cleaning tasks, and it increases the energy generation by an approximate 5%. The activity of this device can also be controlled remotely through GSM or Zigbee. The payback of our robotized solution spans over 12 to 18 months with an expected life of minimum 5 years.
The light testing services that we have in CERAD are the electrical and photometric test, chromaticity test, harmonic current emission test, pulse test, driver test, salt test, IP and IK test. The electrical and photometric test used to determine the luminous intensity, luminous efficacy, light distribution diagram, and the other electrical parameters. For that purpose, we are using the gonio spectroradiometer, that is a D-type gonio for near field detection, and we also have a C-type gonio that's used for the field and far field detection. IES files also produced using this setup, which is further used for the simulation of lightning models. The integrated sphere is used for the chromaticity test, in which the color rendering index and the correlated color temperature were measured. Harmonic current emission test is also done using the power meter that is integrated with this integrated sphere, and it can determine the harmonics of the current and voltages. We have a temperature and humidity chamber which will use for the damp heat and environmental test. In IK test, an impact of 5 joule is applied on the luminaire body at different points to assess its withstand capacity. We are offering following tests in CERAD. Few of them are the determination of real power at STC condition using the sun simulator that can emit a light of 1000 watt per meter square at a temperature of 25 degrees C and air at 1.5. IV and PV curve also determined using the sun simulator. Another test that we have is the EL test, that is named electroluminance test. EL test setup capture the image of the PV module whose quality is assessed to detect the cracks and defects on the PV module. Bypass diode test is also used for the PV module. Bypass diode thermal test is used to assess the adequacy of the thermal design and long-term reliability of bypass diode. Another test that we have is the ultraviolet preconditioning test. Ultraviolet preconditioning test is used to identify the degradation of the PV module material to ultraviolet radiations. Module breakage test is also applied to the PV module to determine the strength of the PV module, and mechanical load test can determine the ability of the PV module to withstand the mechanical load and stress of the PV module.
Assalamu alaikum. My name is Mohammad Amza Lateef and I'm working as a research assistant in Alternate Energy Research and Innovation Lab, UET Lahore. In addition to that, I'm also working as an instructor for PSDF and NAFTA courses. The ultimate aim of these courses is to target the renewable energy sector. In renewable energy sector, they target solar, they target wind, they target geothermal, and they target hydel. The main focus of these courses is to create employability in the market and to make the students self-sufficient so that they can create their own startups and get jobs in the market. Last but not the least, one of the ultimate aims of these courses is to enhance the R&D sector and to make them self-sufficient so that they can pursue their careers and they can start their masters and PhD and they have the prerequisite knowledge to pursue their higher education.
Assalamu alaikum. My name is Muhammad Ali and I am working as Senior Research Manager at Al-Khwarizmi Institute of Computer Science and also providing support to CERAD labs. We are working on various energy efficiency related projects, especially related to the industrial sector. We started off with the energy efficiency course funded by GIZ Germany, where we have senior level people from industries coming over on weekends to get hands-on training. We also developed a motor testing system based on IEEE standard. The motor tests the running efficiency of induction motors, which is very important in decision making for motor replacements or making improvements. We won a project from UET for sustainable energy initiatives for Pakistani industries, focusing on paper and pulp and ceramics sector. We won a TDF project from HEC on solar inverter development. It's very essential for us to get these products developed in Pakistan for customized needs, preserve foreign exchange, skill development, and job creation for local engineers. We won funding again from HEC for pump testing system development. The system tests the efficiency of centrifugal pumps, giving a lot of benefits to its users. We are working very closely with PICA for establishing AC testing lab at CERAD, Kalashakaku campus. The lab will test energy efficiency ratio and coefficient of performance of air conditioners, in addition to various other parameters mentioned on the nameplate. We are also offering short training courses on energy efficiency, programmable logic controllers, industrial instrumentation, in cooperation with NAVTTC and other funding agencies.
This project tends to determine the efficiency as well as the pump curve of pumping system. In any industrial or commercial facility, we can determine the pump curve from ratio of flow rate and the of the pump. This solution gives us the real-time efficiency data of pump of industrial or commercial systems. The test bench duly equipped with PLC, programmable logic control, and a VFD, variable frequency drive, from which we can change the speed as well as the technical parameters of pump as per demand. All parameters and real-time data are displayed on a HMI screen. This demo test bench contains 1 HP motor of 3-phase power. This project has been awarded from HEC through TDF Technology Development Fund. Thank you very much.
The project is to develop an economizer to control and automate the pigmentation of leather skin with minimal pigment waste at less cost. This system to automate the leather spraying process is locally developed and presented for the first time in Pakistan leather sector with high precision and calibration. It immediately becomes mature and has been installed on various finishing plants across the country. And how it is working, the leather skin are placed on the conveyor of the leather machine and pigment coating is done by solenoid spraying guns placed on carousel. Economizer detects the speed of the conveyor and carousel and convert the area of the leather skin into the digital format using IR scanner. After computation of calculation, it directs the guns to perform the efficient spraying. It also provides the user-friendly interface and flexibility in adjusting the parameters required for the process. And what is more, the system at the end of the working day gives you more than the 25% saving, thus entirely repaying itself within a few months.
Pakistan is faced with energy crisis due to shortage of 7 gigawatts of electrical energy. 65% of the electrical energy is produced by thermal resources, among which coal is the cheapest. This makes it inevitable for us to move towards coal power generation. However, the problem is, in Pakistan, the coal quality is very low, so we need to process it to make it suitable. Here, our facility, Mineral Processing Research Center at Mining Engineering Department, University of Engineering and Technology, Lahore comes in. We collected samples of 32 million of Punjab coal and 130 million ton of Khyber Pakhtunkhwa coal. We processed it through crushing, grinding, flotation and gravity separation, and we have made it suitable for power generation. In addition to this, we are also committed towards renewable energy storage. For this, we are recycling printed circuit boards and mobile batteries to extract the raw material for lithium-ion batteries manufacturing. For printed circuit board recycling, we are using shaking tables, electrostatic separators, magnetic separators, and leaching. While for mobile batteries, we are sticking to crushing, screening, and smelting.
Assalamu alaikum. My name is Dr. Tabish. I'm working as assistant professor in chemical engineering department, UET Lahore. Every year, millions of lives are lost because of drinking contaminated water. Availability of clean drinking water is a basic human right, and the water contains several pollutants including physical, chemical, and biological. Biological contaminants are the most concerned one because they contain microorganisms, and those microorganisms will lead to several diseases and at the end casualties. There are several techniques to disinfect the microorganisms, and those techniques include ultraviolet radiations, reverse osmosis, chlorination, and ozonation. Reverse osmosis is a versatile technique, but it's expensive to buy and difficult to operate. And ultraviolet radiations, they have technological limitations because of the transmission limits of the ultraviolet radiations within the turbid water. Ozonation and chlorination, they produce disinfection byproducts, and disinfection byproducts, they are harmful in the treated water. We are working on another technique, that is electrochemical disinfection. Electrochemical disinfection works on the principles of electrochemistry. On the electrodes, electrons are generated, and these electrons directly disinfect the microorganisms. Alternately, several chemical radicals are produced, and these radicals include hydroxyl radicals, ozone and oxygen radicals. And when microorganisms come in contact with these radicals, they become hibernate and disinfect. The overall electrochemical disinfection system, it contains pre-filtration process, electrochemical disinfection process, and the post-filtration process. Pre-filtration is to ensure the removal of particles that are more than the micron size. Electrochemical disinfection removes the microorganisms, and post-filtration is to remove the dead bodies and also to polish the treated water. This electrochemical technique against the competitors, it offers several advantages. For example, the low cost, environment compatibility, easy to operate, and their preservative effect in the treated water. Major target of this project is the underdeveloped and developing countries, especially the low income communities of Pakistan. In the flooded areas, the flood water contains all microorganisms, and in the flood time, it becomes very difficult to supply the drinking water. We are working on the development of a flood water treatment system for the drinking purposes, and the electrochemical technique will be applied in the process. System will be mobile, so it can be delivered to any mission, any flooded area.
I'm Hafiz Bakas, working as Assistant Manager in Motion Control Research Lab in CERAD, UET Lahore. Motion Control Research Lab conducts its research in the multidisciplinary and electromechanical projects, keeping in view the energy needs of the Pakistan. MCRL providing its services in the advanced green energy using efficient tools to design and develop the best products to fulfill the energy needs of the Pakistan. In this regard, we are working on the concentrated solar thermal power plants, in which we have designed and developed dual axis solar tracking heliostats, dual axis solar tracking parabolic dishes, and single axis parabolic troughs, in which we will focus the sunlight onto the central focal point and then to rise the temperature of the water. After that, we will run the steam turbine to generate the electricity to eradicate the energy shortage of Pakistan. On the other hand, MCRL is working on the energy efficient electrical vehicles, in which we are working on the BLDC motor and its drive with the regenerative braking system. In the end, I would like you to visit our stall, and I would like to thank all of you to visit ICECE. Thank you. Parabolic trough is a type of solar thermal collector that is straight in one dimension and curved as a parabolic in the other two dimensions. The upper surface of a parabolic sheet is then lined with the polished metal mirror. The sunlight which enters the mirror parallel its plane of symmetry is focused along the focal line, where the pipe containing the fluid with the high coefficient of thermal resistivity are positioned that are intended to be heated, which leads to produce steam from the water by providing the stored heat. Modeling and simulation were carried out on the SolidWorks and simulation software, and analysis of its structural integrity, weight, wind load,
resistance was successfully done on the SolidWorks and ANSYS simulation software. Single-axis solar tracking system has been implemented on the PLC and data has been integrated for the whole year. This single-axis solar tracking parabolic trough can rotate in 120 degree in elevation for the sun tracking with the accuracy of 0.02 degree. Thank you. Programmable logic control PLC or a programmable controller is an industrial digital computer which has been ruggedized and adopted for the control of manufacturing process such as assembly lines or robotic devices or any activity requires high reliability, ease of programming and processes. PLCs can range from small modular devices with tens of outputs and inputs in a housing integral with the processor to the large rack-mounted modular devices with a count of thousands of IOs and which are often networked to other PLC and SCADA systems. So we have developed the prototype of PLC trainer for the new graduates to have a good experience before getting into the practical industrial application.
Hello everyone. Welcome to the second session of ICECE 2021, being organized jointly by the Center for Energy Research and Development and the Al-Khwarizmi Institute of Computer Sciences at University of Engineering and Technology, Lahore. I'm Dr. Tanveer Iqbal, session chair for this session. So we'll start with a message from the Vice Chancellor for the session and for the conference. So first of all, a message from Vice Chancellor is going to be played by Hamza Imtiaz. Please play that message from the Vice Chancellor for the conference.
Good afternoon.
Good afternoon.
I warmly welcome all the speakers, paper presenters, and participants from across the globe to deliver their technical talks and present papers at the International Conference on Energy Conservation and Efficiency, ICECE 2021. After 3 successful conferences conducted by the Center for Energy Research and Development, CERAD, at UET Lahore. This is the 4th edition of the conference. University of Engineering and Technology Lahore is actively working in this sector by collaborating with the government on various important projects. This conference is another step of the UET to spread awareness about the much needed requirement of energy efficiency and conservation through sessions, talks, paper presentations, and roundtable. ICEE will provide the opportunity to researchers to sharpen their skills, and above all, the research work will get feedback through discussions by highlighting their strengths and weaknesses. This conference would be a great networking opportunity for students, scholars, researchers, and faculty members. The participants will have a great opportunity to connect with like-minded researchers and experts to learn from each other. I admire the efforts made by CERAD and PICA in organizing this conference and wish them well. Thank you.
So thank you very much, sir. Thank you for the nice words regarding the organizing committee and the conference, and we'll continue to do the best we can. So our first speaker for today's session is Professor Alberto Peteño. He's a professor at Sustainable Energy Research Center, Sotacarbo, and the talk is on chemical energy storage by means of carbon dioxide capture and utilization. Professor Alberto, please continue with your session, please.
Yes, thank you very much. Can you hear me?
Yes, sir, we can hear you.
Okay, that's perfect.
Yes, we can hear you.
Great. Let me share the presentation. So I assume you can see it. So first of all,
yes, sir, we can see it.
That's great. Thank you very much. First of all, I would like to thank you thank you, Mr. Chairman, for the introduction. Let me thank all the organizers for inviting me today. It's a pleasure for me, of course, to present our results and our research activity in the field of chemical energy storage. So today, during the first session, we have seen several presentations on different technologies for chemical energy storage. My presentation is focused on the chemical storage. So I mean the conversion of electrical energy into fuels, into clean fuels, by means of carbon dioxide capture and utilization. So let me spend just a few words to introduce Sotacarbo, my company, which is basically an Italian research institute. It's a private company, but with public shareholders. So ENEA, which is the Italian National Agency for New Technology and Energy Research, and the regional government of Sardinia Island, in the center of Mediterranean Sea, where we are based. So basically, Sotacarbo is a company which works in the field of low carbon technologies. So mainly on biomass and waste gasification, CO2 capture, utilization and storage technology, and energy efficiency. So this is a very simplified scheme on our research activities. So basically, the idea is to convert renewable energy from solar, wind, etc., into the so-called e-fuels. So basically, green fuels from renewable sources in order to feed, in order to store the energy in chemical form, and to feed, for example, transport sector, industrial sector, and also domestic uses. So basically, Sodacarbo is has several role in the international community. In particular, we represent Italy in the clinical center of the International Energy Agency. We participate in the greenhouse gas program of the agency. We are member of EXCEL, which is the European Carbon Dioxide Carbon Storage, Capture and Storage Laboratory Infrastructure. We are also the Italian representative in the implementation working group on carbon capture, utilization and storage of the European set plan, which is basically a sort of a working group which supports the European Commission for the funding of research projects on, in this specific case, on CCUS technologies. And finally, we are a member, we are a founding member of the CO2 Value Europe organization, which is a non-profit association with the aim to promote the development of CO2 valorization technologies. So our work is based on bench scale, pilot and demonstration scale experimental tests with several kinds of facilities. For example, this picture shows the our experimental facility for power generation and renewable hydrogen production from waste material, biomass, plastic, algae, etc. We work in collaboration with several international partners. For example, the National Energy Technology Laboratory of the United States, etc. We work also on CO2 capture technology with advanced solvents and novel approaches, membranes, etc. And we have a very fruitful collaboration with the University of Engineering and Technology Lahore. We are working on CO2 utilization, CO2 conversion into liquid fuels. So, and this is the topic, so I can skip this slide because this is the key topic of this presentation. And finally, sorry, we are working on the geological storage of CO2 with a bench scale facility. Basically, it's a pilot scale facility, is a site laboratory for CO2 injection into a specific fault in order to study the leakage process. So this was just a short introduction of our research activity. So what does chemical energy storage mean in this specific case? So one of the key goals of the European Union is the climate neutrality by 2050. So the European Union is investing a lot of money to reach this goal. So the aim is to become the first continent in the world carbon neutral in just 30 years, which is a very, very short time window. And basically, the European Union is investing more or less 1 trillion euros of both public and private funding in order to promote the development of low carbon technology and to this goal. Basically, so this slide is well known. It comes from a study from the International Energy Agency published last year. Basically, it underlines the need of different approaches to reduce CO2 emissions in the atmosphere. So, energy efficiency, renewables, fuel switching, nuclear, and carbon capture, utilization, and storage. In addition, other minor technologies are required. And if CCUS is quite important to reach the goal of carbon neutrality in the power generation sector, it is very important in the industrial sector. In particular, in several areas, the so-called hard to abate areas, where the conventional approaches for CO2 reductions are quite difficult. So, in this case, it is very, very important the possibility to convert CO2 into green fuels, CO2 and renewable energy into green fuels in order to achieve these goals. So basically, this is a sort of a general overview of the problem. So the diffusion of non-programmable renewable energy sources involves an instability of the electric grid and a limit. This is basically a limit to a further diffusion of non-programmable renewable sources. So that's the reason why there is still the need of fossil fuel power generation plants in hot reserve to assure the safety of the electric grid. So basically, I have to burn fossil fuels. I have to emit CO2 in the atmosphere because I need to assure the availability of electrical energy if the production from non-programmable renewable sources decreases. So that's the reason why renewables currently are not enough to achieve the goal to reduce CO2 emissions in the atmosphere. So that's the reason why basically the energy storage approach is essential in this transition phase. And so the possibility, there are several possibilities. The first one, the most common one probably is batteries, but they are characterized by high cost, limited capacity, and a significant environmental impact. So this is a very good solution, for example, for vehicles, but this possibility, this approach has several problems for large-scale applications. Another option is hydroelectric power, but it is characterized by, at least in Europe, by a low potential development, considering that all the basins are currently in use for this kind of application, and there are just few basins potentially available for new plant. So the application capacity is currently limited. On the other hand, the chemical storage of energy, it is still characterized by relatively high cost, but it has a very high potential development, in particular for a potential application in the transport sector. Basically, heavy transport is one of the sector mostly related to fossil fuels. Basically, all the fuels currently used for transport, for heavy transport, are derived from oil. And that's the reason why the possibility to produce green fuels for transport is one of the key solution for the abatement of CO2 emissions in this specific sector. So, power to green fuel. This is the title I give to this chapter of my presentation. What does it mean? Let me start from the definition of e-fuels. So they are generally defined as liquid or gaseous fuels produced not from fossil sources such as diesel, gasoline, etc., but from renewable electrical energy. So basically, with the current technologies, there is the possibility to produce, for example, hydrogen, methanol, dimethyl ether, methane, or also synthetic oil, diesel and gasoline, and many more, not from fossil sources, as currently happens, but from renewable energy and CO2. So this is a very key approach, a very important approaches. As mentioned, in particular for the decarbonization of the so-called hard-to-abate sectors. And so the question is, are e-fuels renewable except for hydrogen, which is directly produced from electrical energy by water electrolysis? But the other fuels need CO2, need carbon dioxide, that can be obtained from, for example, fossil fuel power plants or other applications, but also from bioenergy and air, directly from air. So basically, CO2 can be considered renewable if hydrogen, so I'm sorry, basically the e-fuels can be considered renewable if hydrogen is produced from renewable electricity. So this is the only conditions. And let me show you why. Basically, this picture represents the two main commercial scale plants, both coal-fired power plants, where CO2 is captured. In both these cases, CO2 is used, is stored underground, is we can see reused for to enhance oil and gas production. So the so-called enhanced oil recovery technology. So both these plants are very important example of CO2 capture projects. But this is just the tip of the iceberg, considering that there are a lot of CO2 sources, and probably the most important one is the atmosphere. So in the atmosphere, there are more or less there is a lot of CO2, so 3 power 10 squared 12 of tons of CO2 in the atmosphere at a concentration of more or less, unfortunately, a little bit more of 400 parts per million. So there is a lot of CO2 that can be used. And if the technology for capturing CO2 directly from air, it was quite expensive a few years ago. In the last few years, there is a significant cost reduction of this technology. Basically, the concept is the following. Currently, for example, fossil fuels such as coal are used for power generation with CO2 emission, and in parallel, oil-derived fuels are used for in the transport sector with an extra CO2 emission. So the idea is to capture CO2 from fossil fuel and use it for the production of, for example, jet fuels to feed the air transport or, for example, naval transport, etc. So I can say, basically, of course, it is just a simplistic view of the whole situation, but so we learn at the primary school that 1 and 1 makes 2, but with this approach, we can say somehow that 1 and 1 still makes 1. So considering that we have a sort of double use of carbon dioxide before its emission in the atmosphere. So, but this is just an approach, considering that if CO2 is captured, for example, from renewable energy, for example, from biomass gasification processes or from directly from the air, we can achieve a sort of definitely a neutrality of CO2 cycle. So this is one of the key fuels that can be produced from carbon dioxide. In this period, in particular in Europe, there is a very strong attention focused into hydrogen. But we know that hydrogen has a lot of problems. So hydrogen is quite easy to be produced, so the technology are mature, but hydrogen is very difficult to be stored, to be transported, and to be used. So there are several technologies such as fuel cell for power generation directly from hydrogen, but these technology are quite expensive, and the safety of storage and transport technologies are still still an issue. So basically, one of the most important alternatives to hydrogen is methanol, which is very simple to be produced from hydrogen and CO2. So one of the first sponsor of the methanol economy was Professor George Olah, Nobel laureate in 1994. So he proposed the methanol economy as a potential alternative to hydrogen for the decarbonization of the fuel sector. And this is probably the most important example of methanol production plant from renewable sources. So this is the George Olah renewable methanol plant located in Iceland near Reykjavik, so some more or less 30-40 kilometers from Reykjavik. It uses geothermal energy and a natural emission of CO2 to produce methanol. So it is commercialized in Northern Europe with a commercial name of Vulcanol, considering the origin of CO2 and the electrical energy. And this plant operates since 2011 with a production of more or less 5 million liters of methanol per year. So this is the most important example of methanol production from hydrogen, from electrical energy basically, and CO2. And this is probably one of the key applications. In Europe, only in Europe, the transport sector involves the emission of more or less 300 million tons of CO2 per year. And as I mentioned a few minutes ago, e-fuels can be easily used they can be efficiently used for the decarbonization of this specific sector. So this picture represents probably the first and the most important example of methanol application this is the Stena Line, the Stena Germanica ferry owned by Stena Line shipping company. So it's a Sweden company, and it is based in Gothenburg. This ferry has been reconverted with methanol engines, and it works every day with this renewable fuel. So this is the first, probably the most important example, but I'm sorry, there are several other examples of ferries fed with methanol as a fuel. But methanol is also used as a raw material in a lot of industrial production processes, with a daily demand of 200,000 tons just in the industry. And it is a market characterized by a very, very quick development in the last few years. And this is another example. In this case, the product is not methanol, but methane. And this is a plant. It is basically a demonstration plant operating in Germany, in Wertel, since 2013. And it uses basically electrolyzers, commercial electrolyzer, for the production of hydrogen, renewable hydrogen, and CO2 captured from a coal-fired plant. So they basically produce more or less 1,000 tons per year of methane that is commercialized basically for car feeding. This is one of the key problems of this approach, the energy balance. Basically, consider all these technologies, for example, for methane, but also diesel production, involve a significant loss of energy. So, considering the power, the electrical power, the inlet of the process, more or less 50% of this power is losses. But there is also the possibility to recover a part of this energy as a sensible heat. For example, the methanol synthesis from hydrogen and CO2 is strongly exothermic. So it means that this process makes a lot of thermal energy available for other uses. So this is just the energy balance of the process, but a significant amount of these losses can be recovered to improve the whole efficiency of the process. And the other aspect is the production cost of e-fuels. So here there is an example, for example, for methane, methanol, and liquid fuels in general, which means basically gasoline and diesel. Currently, of course, the production cost of CO2 derived fuels, I can say the production cost of these e-fuels, renewable fuels, is significantly higher than the cost of the corresponding, I can say, fossil derived fuels. But in a medium long-term period, a very important cost reduction is expected as a consequence of the optimization of the processes and of the diffusion of the applications. If we consider potential increasing of, so for example, most of the policies in Europe are focused on the introduction of new taxes for CO2 emissions. So that's the reason why these renewable fuels can become competitive in just few years with respect to the corresponding fossil derived fuels. So this is a very, very important message. This information has been published a couple of years ago by the International Energy Agency, considering in general the worldwide situation of liquid fuels. So let me spend a few minutes before concluding my presentation to show you some key results we achieved in our experimental facilities. So basically, I've shown you this picture at the beginning of this presentation. So basically, our research, our experimental research here in Sotacarbo is mostly based on this, I can say, X to liquid bench scale plants. X means CO2, but also syngas from biomass gasification, for example. So this is basically a bench scale unit, a very flexible bench scale unit that can operate up to more or less 10 megapascal, so 100 bar of pressure, with different kinds of configurations. So basically we simulate the CO2 and hydrogen mixture by means of flow gas regulation systems. And in order to simulate the process and characterize different kinds of catalysts, we worked with, so this is basically the concept. We work with so we are working in the development of novel catalysts, I'm sorry, mainly for methanol production, but also for dimethyl ether and methane production from CO2 and renewable hydrogen. So we are working on material synthesis to produce novel catalysts that are experimentally characterized into this bench scale units and generally compared with the commercial catalysts just to verify the performance of this material in comparison with this with the commercial products. Basically, this is one of our best results. So it's a novel catalyst produced combining the impregnation salt gel process and the autocombustion process. So I can say two conventional process combined in a non-conventional way. And in particular, this is the first application of this technology for this kind of catalyst, so for renewable methanol synthesis. So basically, this material, so the metal, copper and zinc, are supported in a SPA 15, which is I can say an inert support to promote the diffusion to promote to improve the active surface of the catalyst. So we are able to produce this specific material, which is characterized by very, very high performance. So basically, compared with the other catalysts available in the literature or commercial products, our material presents a very, very high conversion efficiency. It presents also a very good stability during the time. It is tolerant to oxygen. It means that, for example, it can be used for application in, for example, in oxycombustion plants where CO2 is so the captured CO2 has a significant concentration of oxygen. Conventional catalysts are not tolerant to oxygen, and with conventional catalysts, CO2 flow needs to be purified in order to avoid the poisoning of the material. Our catalyst is tolerant to oxygen, and it can work in this kind of processes. And probably it is the most important result, differently from the conventional catalyst that have to be activated, typically fluxing hydrogen for several hours before the production phase. Our material is already active, so we just need to load the material into the reactor. The reactor has just to be heated up, and the process is ready for operation. It means, of course, several advantages in terms of cost, shutdown time, safety of the application, etc. So basically, this catalyst is already active. The key cons is that the production still to be scaled up. Basically, we developed the catalyst at laboratory scale. We still need to scale up the production to test the material at demonstration scale. This result is the key subject of a patent titled Efficient Catalyst for the Conversion of CO2 to Methanol. So this patent has been published in a World Intellectual Property Organization website last in 2000. If I remember, the PCT application was issued in February 2019, and the patent has been published in October of the same year. Now we have obtained the Italian patent, and we are extending the patent in whole Europe and the United States. So starting from this material, this specific material, we are now working on the development of a bifunctional catalyst for the synthesis of dimethyl ether. So basically, the same catalyst promotes the conversion of CO2 and hydrogen into methanol. We are working on a derived catalyst, so the same approach, but with other active phases to promote also the hydration of methanol for a direct production of dimethyl ether. Currently, dimethyl ether is produced from methanol in a second stage, so a second reactor. In this case, we are working on the production of dimethyl ether in just a single step. So this work is carried out in collaboration with different partners, in particular the University of Cagliari for the development and characterization of a catalyst, Politecnico di Milano and LEAP, which is a consortium, an Italian consortium for system simulation. We are working with the Indian Institute of Technology Madras for the study of process kinetics, and with the Hydrogen National Center, the Spanish Hydrogen National Center, for a development of advanced hydrogen production system. So let me conclude this presentation. Basically, we said that e-fuels are currently one of the most promising approaches for energy storage, in particular to support the hard-to-abate sectors. For example, it is an option to make transport sustainable. Most of the technologies are already mature, so it means that, for example, electrolyzers are mature. The distillation of the purification of the products are mature technologies, and several other technologies are quite close to maturity. For example, the catalytic synthesis of methanol from CO2 it can be optimized, but I'll show you the demonstration unit in Iceland, which operates since 2011. So it's more or less a mature technology with a significant margin for optimization and cost reduction. And as I mentioned, the competitiveness from the economic point of view is expected to be achieved in just a few years. As for our specific activity, we are working on novel catalysts for methanol and dimethyl ether with high performance, stability, tolerance to oxygen, and activity without any pretreatment processes. And the next step of our research is the construction of, I can say, a pilot scale. It's a big pilot with a design production of more or less 50 kilograms per day of methanol. It is still under, we are completing the design phase, and the unit will be available for operation. So it will be completed at the end of this year, so it will be available for operation from the beginning of 2022. So it is a very, very flexible unit with 2 different reactors and capable to operate up to 60 bar at 350 degrees or 30 bar at 450 degrees. So basically the first configuration is for the production of methanol and dimethyl ether, and the second configuration with a lower pressure and higher temperature is basically designed for methane production. This is just a very, very simplified scheme of the unit with a 2 reactor in parallel. So this is the end of my presentation. Let me thank all the team in Soda Carbo who work in this specific topic, and the research activities I have presented are funded by the regional government of Sardinia and the Italian Ministry of Economic Development. So thank you very much for your attention, and I'm available for any question.
Dr. Tanveer, are you online? Dr. Tanveer, are you online? Thank you so much, Dr. Alberto, for your talk. It was really a very insightful discussion. Now we would like to present a virtual shield to you, because the actual shield, it was not possible for us to present you. So thank you so very much for being the part of this panel.
Thank you very much indeed. Thanks again for the invitation.
Thank you so much, sir.
Okay.
Sham. Can you hear me?
Hello. I think so. Dr. Imran has joined the session. Dr. Imran is working as assistant professor at Eastern University and is an active member of Energy and Bioproducts Research Institute. He has worked on mainly low temperature and waste heat to power conversion technologies. Major work is on organic Rankine cycle, supercritical carbon dioxide cycle application, and hybrid energy application. He's going to be presenting his work in this conference. Thank you very much, Dr. Imran, for considering to be part of this conference. So please present your work. Dr. Imran.
Thank you so much.
Over to you, sir.
I'm good. How are you guys doing? Can you hear me?
Yes, sir, we can hear you. Please share your presentation as well on the screen.
Yes, your presentation is now visible.
Just give me a second, please. Okay. Good afternoon, everyone. My name is Mohammed Imran. I am working as assistant professor at Aston University. I am a key member of European Bioenergy Research Institute, also known as Energy Bioproduct Research Institute at Aston University. We're working mainly in the area of biofuels and biomass, and part of our activities also revolves around energy efficiency and hybrid energy systems and decarbonization activities. I am leading the group which is working in industrial decarbonization and low waste heat to power conversion technologies, mainly organic Rankine cycle, supercritical CO2 cycle, and cleaner cycle. I have been working in organic Rankine cycle technology from last 12 years. This is my main area of research. Besides this, I'm also actively working on hybrid energy systems and partially on biomass and biofuels. The topic of today's talk is about volumetric expanders. But before we proceed to details about volumetric expanders and how they have been selected and designed, how they perform, what are the performance criteria, assessment criteria, let us talk about what is meant by waste heat or low temperature heat. Most of you are already aware of final use of energy. When it comes to power production, there are two main sources of electricity production, mainly through heat to power technologies. And the technology I'm working on is powered by either low temperature waste heat or low temperature renewable energy resources. In terms of low temperature waste heat, there are plenty of resources, including waste heat from industries that include energy intense industries like cement and steel. There are medium energy intense industries, including petrochemicals, textile, paper and pulp industries, ceramic, glass, and many more, which have these industries, they discard about 30 to 40% of input fuel as a waste. So they have around significant waste heat recovery potential. Some of industries have adopted technologies to recover part of that waste heat, but most of this waste heat is in the band of 80 degree to 160 degree. And they are termed as low temperature heat, which could not be further used for any process within the industry. And they are discarded as waste heat. The current potential of waste heat around the globe is 3 to 5 terawatt hour per year. within Pakistan. I'm specifically got these numbers. We are working on waste heat potential within Pakistan, mainly in energy intense industries. Also, if we talk about at global level, it is 159 terawatts air potential. And if only 50% of this waste heat is recovered using ORC, we can produce around 0.5 terawatt hour per year in Pakistan, and in global 9.57 terawatt hour. So that's a significant number. Recovering the waste heat from industry brings two significant contribution. One, it reduces the carbon emissions because most of these industries are powered by fossil fuels. Secondly, it can reduce the energy cost and improve the energy efficiency, the business within these industries. The second source of waste heat is from transportation sector. And in the transportation sectors, we have heavy-duty vehicles, including a long-haul truck. It could be construction machinery. It could be rail transport and maritime sector. All of these transportation sectors heavily depending upon fossil fuel or biofuels. And again, when it comes to conversion efficiency, about 40 to 60% of input fuel energy is discarded as a waste heat through the exhaust, through the engine cooling water. That could be recovered using organic and gun cycle again. And there have been a lot of work which was dedicated to develop a dedicated system to recover the waste heat from these sectors. If you look at current decarbonization pattern, even in developed countries, they are struggling to decarbonize the industry and the transportation sector. When it comes to transportation sectors, I'm not talking about electric cars. I'm talking about freight long vehicles, high-duty vehicles, including long-haul truck, rail time, or maybe maritime sector. Maritime sector is being now hardly hit by recent regulations of emissions across EU and UK as well. So they have set a target to get it free by 2050, but still it's a long way to go. And ORC could be potentially one of the technologies that could be adopted to recover waste heat from these systems. When it comes to renewable energy resources, where we can use organic and cycle and other technologies, they include geothermal, solar, ocean thermal, and biomass energy. Geothermal energy potential in Pakistan is relatively low, about 0.1 gigawatts, and at the global output potential, geothermal power production is around 80 gigawatts. And considering binary geothermal applications in geothermal energy is where we don't have high temperature reservoir. The temperature where we have binary, they range between 80 to 160 degrees, and conventional steam and fan cycle cannot be applied for those systems. So here comes the cleaner cycle and ORC that could be adopted with those low temperature geothermal resources, and we can effectively recover them and convert them into electrical power. Second is solar energy. Although PV is becoming cheaper and most widely adopted, but in terms of distributed power generation, where there's a restriction on area, talking about power density and in large quantity, then ORC could be one option. It normally operates within a temperature range of 100 to 200 degrees centigrade. So that could be easily achieved using conventional solar collector. There have been a lot of installations of solar ORC. Then ocean thermal energy could be one option. The thermal gradient between the upper surface of the water and below the sea level up to a specific height, the temperature gradient can be between 10 to 20 degrees that could be used to drive the ORC system. Biomass energy is another option which is being considered in many countries, and also some of countries have adopted biofuels for power generations. And even if you have biodiesel generator, that still have some engine cooling water and exhaust heat, which could be used, which could be recovered using ORC system. Eventually, whatever the heat source or renewable energy technology is, application of ORC system will significantly reduce the carbon emissions and improve the energy efficiency. What are the common technologies that could be adopted to recover these low temperature renewable energies or the waste heat and low grade heat from industries and transportation sectors? We talk a couple of technologies including Solvang cycle, CO2 power cycle, organic Rankine cycle. It could be flash steam Rankine cycle, cleaner cycle, or steam Rankine cycle. But looking at this chart, this table, the steam Rankine cycle, flash, and cleaner cycle, they are preferred for high-end power production from 1 megawatt onwards, and they are relatively bulkier system and are suited when we have heat in the range of 100 megawatt, 500 megawatt or above, 100 megawatt or above. So normally these systems where the energy resources I'm talking about, low temperature geothermals or solar or waste heat from industries, not all the industries have this much of amount of heat. They might have heat in the range of 50 kilowatt to 100 kilowatt or maybe up to 1 megawatt. In that case, CO2, supercritical CO2, organic Rankine cycle and Solvang cycle are considered more favorable. And if you look figure, organic Rankine cycle perfectly suit if the waste heat temperature or the renewable energy temperature from geothermal or solar is in the range of 100 to 250. That perfectly suits for ORC, and it can have a power production from few kilowatts to 1 megawatt. Although we have some system up to 10 megawatt in geothermal, where we have binary geothermal power plant powered by ORC system. Organic Rankine cycle is similar to conventional steam Rankine cycle. The only difference is it uses a low boiling point refrigerant that enable the ORC system to recover the waste heat, and effectively the rest of the components are same as the conventional steam Rankine cycle. The only difference is the working fluid. In ORC, we have low boiling point refrigerant. But again, when we introduce low boiling point refrigerant, it changes the overall component design itself. It leads to very complex design of turbines and expanders. We have to come up with more fundamental knowledge of their heat transfer behavior to design the heat exchangers. The control becomes different than conventional steam Rankine cycle, although the basic principle remains sense, but due to the thermal fluid properties, it should have been redesigned and adopted accordingly. Cleaner cycle is similar to ORC, but it uses ammonia as ammonia mixture as a working fluid. It's a relatively complex if you compare it with ORC, steam Rankine cycle. Supercritical CO2 could be another option that is being adopted in many industries, but again, it is suitable for very high temperatures. And in supercritical CO2 is being used as working fluid, and in supercritical condition that avoids the losses during phase change, during evaporation and condensation. So those losses are avoided, so it has a relatively higher efficiency than the ORC system. Organic Rankine cycle is suitable for low temperature. So there are a range of temperatures it could be used. It could be used as low as 70 degree and as high as 500 degrees centigrade. So there's a wide range of heat source temperature. It could be applied for waste heat, including gases or liquid. It has a design flexibility, optimized efficiency, and it could be designed using modular approach where the components design does not vary much. So if you have designed a system for 10 kilowatt, you can adopt it for 20 kilowatt. The only difference is the design of expansion machine. It is compact and automated. It can be easily controlled using simple logical controllers. No need of complex and advanced control systems. Due to intrinsic properties of refrigerants, they have a positive or dry slope of saturation curve that leads to a condition, a state where during the expansion there is no danger of that the fluid will be in two-phase region after the expansion. So that ensure the safety of the expansion machines, and they have a relatively higher life than conventional steam run cycle. Operational flexibility is they have relatively good after-design performance. So these waste heat sources are normally characterized by large fluctuations in temperatures and mass flow rate, and that might lead the OIC system to operate at off-design condition. But again, the design of OIC system can be obtained in such a fashion that it can easily adopt the new optimized conditions, and it can ensure still a very high power output or higher efficiency compared to cleaner supercritical CO2 or steam run cycle. For those of you who have never worked or heard about ORC or organic run cycle, I will just briefly explain about the basic principle. This slide just represents the schematic and TS diagram, temperature entropy diagram of a conventional organic run cycle. All the components in schematic are similar to conventional steam run cycle. The working fluid is being pumped to higher pressure in liquid phase to an evaporator, where the heat is recovered from the exhaust gas. It could be waste heat, it could be solar thermal, it could be geothermal, whatever the waste heat source is, that is used in evaporator to vaporize the liquid into high pressure vapors. That expands into expander to provide, to generate power to generator, and then finally the vapors are condensed in a condenser and feed back to the pump, so that there's a continuous closed loop system that produces power. The components are same as conventional steam run cycle. The only difference is it uses refrigerant, low boiling point refrigerant. The TSD diagram, if you look, it has a relatively different saturation curve compared to water, and the points are shown, different points between pumping, evaporation, and condensations are also listed from A, B, C, D, and DA to DS. One of the key components in ORC where we mainly talk about is expansion machine. And design of expansion machine is, and its selection is directly related to the waste heat temperature and the power that it can produce, the power production of ORC system, and what type of cycle configuration is being considered for application. So these conditions lead to select the expanders. And expander selection has a direct impact on the overall cost, system performance, and control of the overall ORC system. And they have relatively more role in terms of cost. When we design the ORC system under 50 kilowatt, the cost of expansion machine is significantly high. So we have to make a choice between different expanders, which one is cost effective, which one is easy to control, and which one has higher system performance. So there's always a trade-off between these. And my tutor talk is mainly focused on this, how we can choose between cost, performance, and control, and different performance indicators of these expansion machines. Normally, the expansion machines for organic and kind cycle are characterized by turbo expanders and volumetric expanders. Turbines or turbo expanders could be classified into radial inflow and axial flow turbines. They have relatively complex design due to high molecular complexity of the refrigerants. They have relatively higher cost, and they are not economically feasible below 50 kilowatt. They're economically feasible above 50 kilowatt or 100 kilowatt. One of the reasons below 50 kilowatts is they have relatively higher rotational speed, which requires dedicated efforts to for the bearing mechanisms and also for alignment. It needs high-speed electronics. When we talk about high speed, just assume a 10 kilowatts turbine would rotate at 120,000 RPM. And you can imagine how hard it would be to control and operate at such high speed. And that is one of the reasons that the design and operation of turbines under 50 kilowatt for ORC application is relatively difficult, and the cost is significantly high. There are not enough commercial providers. Still, it is at development phase. A lot of people working on the design of turbine under 50 kilowatt for ORC system. The ones that are available, they are relatively very high. They have very high cost, considering a 10 kilowatt turbine would cost you 30,000 pounds. So how we can avoid this cost? Because that offset all the benefit that comes with ORC system. Then the second option to adopt is volumetric expanders. You can assume volumetric expanders as compressor working in reverse operation. Okay, so instead of compression, you have expansion. And volumetric expanders have specific built-in volume ratio. They have low rotational speed and low cost. And then these three main features lead them to an ideal choice for ORC application for under 50 kilowatt power capacity. So, as I was talking about turbines, so again, just a reiteration of what I said is, for waste heat and low temperature under 50 kilowatt, the size of the turbine significantly reduced. And when the size reduces, the blade size, rotor diameter decreases. That leads to difficulty in manufacturing. High rotational speed leads to difficulty in alignment and bearing. Also difficulty in control and the requirement of higher high-speed electronics. Then it leads to complex design. So that all add up to higher costs. So definitely turbines are not an ideal choice for ORC system under 50 kilowatt. So what are the choices then? We have a number of volumetric expander that can be adopted for ORC applications, including scroll expander, piston, sphere expanders, and van expanders. And the pressure drop in expanders is being achieved through expansion chamber along the flow length of the fluid within the volumetric expanders. They are characterized by low volume flow rate, high pressure ratios, and much low rotational speed. They have rotational speed between 2000 to 3000 RPM. That is relatively much easier to connect with the generator and other electronic system for control purposes and power generation. Due to fixed built-in volume ratio, they have one of the backdraw that leads them to have over and under expansion losses, which leads to lower asymptotic efficiency than turbine. So always these volumetric expanders have relatively lower asymptotic efficiency than turbine. In terms of specific temperatures and pressure range, they have been studied comprehensively from last 15 to 20 years. Some of them have been tested in 90s for steam Rankine cycle as well, but for organic Rankine cycle, the application of these is still at lab scale. There are some commercial square for scroll and screw expanders, but only a couple of maybe 2 or 3, and still at very limited size and application. But anyway, the scroll expanders, they can operate in the pressure range of around 1.6 megapascal. They can be operated up to a temperature of 190 degrees centigrade. The optimum efficiency, asymptotic efficiency is 65%, although some of them report efficiency of around 70 or 75%. They are suitable for power production between 1 to 10 kilowatt. One of the major drawbacks for scroll expander is that when they are operated at higher temperature, they tend to develop thermal stresses that increases the leakage between the expansion chambers, and that leads to lower asymptotic efficiency. And they do have limitations on pressure application as well. The screw expanders are relatively robust, and they have relatively higher operational pressures and temperatures. But again, in terms of temperatures, the higher temperature always leads to more leakage loss between the expansion chamber. Their efficiency is relatively higher than scroll expanders in the range of 75%. They can be adopted from 10 to 100 kilowatt ORC system, and they are normally preferred for system higher than 50 kilowatt. But again, some of the our screw expanders are available in the range of 10 to 50 kilowatt. The piston expander is an emerging technology due to their high temperature and high pressure operation flexibility. They are an ideal candidate for high temperature waste heat from industries for ORC applications. They have asymptotic efficiency of 75% and the power range between 2 to 20 kilowatt. But again, in terms of control of piston expanders, they do tend to require a very precise control of exhaust and inlet valve, which leads to very precise and accurate control. And if there is any non-optimum control, which will lead to significant drop in asymptotic efficiency. So there's one of the major drawbacks is they require very precise control of the valves during expansion. The van expanders are also an emerging technologies. They can be adopted from applied between 9 megapascal to 150 degrees centigrade temperatures. Asymptotic efficiency is around 70%, and they have a power rating between 1 to 3 kilowatt. But again, in terms of van expanders, they tend to have vans which results more friction losses and more leakage losses. And the piston expanders and van expanders are particularly suitable for supercritical CO2, but they can be applied for organic impact cycle as well. So we tried, I'm working on these volumetric expanders for quite some time, and we have experimental test rig. When I was working in South Korea, we did some experimentation in Denmark and Netherlands as well. And at the moment, we are working on one of the experimental test rig at Austin University as well. And one of the key challenges was to how we can compare the performance of these volumetric expanders at same operating conditions and see which performs better. So we wanted to develop a generalized guideline that can provide the designers, okay, if you want to have a 5 kilowatt ORC system, this is the perfect solution for you. This would be the cost, this could be the performance in terms of asymptotic efficiency. But again, it is a really relatively complex and challenging task to develop this guideline. We are still working on it, but we have completed some of experimental studies and simulations that I will share in the next couple of slides. So major purpose of these studies was to set a basic guideline that can give us a comparative assessment of different expander technologies. The testing at the moment where we have tested 4 different expanders, and the schematic PID diagram is shown here. We have thermal oil loop, evaporator, condensers, and then a flexible tester which can allow us to change the expander machine, the generator, and the condenser. The first study that we did is to ensure that we have all the operating conditions same. We set the heat source temperature constant, working fluid is R245 FA, and the condensation temperature is fixed, the cooling water temperature is fixed, and then just tested different type of volumetric expanders, including screw, roots expander, scroll, and piston, and Tesla. Tesla is basically a type of turbine. And when it's classification of turbine between radial and axial flow. So in terms of pressure ratio and asymptotic efficiency, it seems that the most of these except piston expander, they are suited for low pressure ratio applications, and they have isentropic efficiency at a specific pressure ratio between 1 and 3. In terms of isentropic efficiency, the root expanders have relatively less efficiency. Root expanders is a sub-classification of van expanders. So van expanders have relatively high low isentropic efficiency. The highest isentropic efficiency was achieved for spool and screw expanders, followed by the Tesla turbine. And it shows that the highest asymptotic efficiency for our system was about between 60 and 70%. We could not achieve higher than 70% asymptotic efficiency, which lead us to think about why we do not have these much variations in these systems. And it seems that when we tested these expanders, we asked different manufacturers to provide the systems within 2 to 4 kilowatt capacity. They were not specifically designed for the specific fluid and heat source conditions, although the considerations has been taken into account to make that they are compatible with R245FA and they can withstand those temperatures. But again, the design from scratch is a complex task, and each expander should have been designed specifically for that test rig, and then we can fix it the power. So we can design each expander for 3 kilowatt, and once we have designed it, considering the temperatures, pressures, and working fluid properties, then we have tested. So that leads us, because we used off-the-shelf solution for these expanders, these results could not be reliable. We cannot come up with the basic guideline from these experimental data. Then the second choice was, what if we develop a very comprehensive simulation models, which takes into account of all the sub-models of the system. It takes into account the geometry and initial design of the expander, and develop an empirical model that is the division of expansion process into small element, a discretization of expansion process, and see if we can achieve better results compared to what we have received in experiments. And also these models can include leakage losses, pressure loss models, friction loss models, and also the heat transfer loss models. These are integrated together to develop an empirical model. And again, when it comes to modeling, there are two common approaches that are adopted: the black model, the black box model, and gray box model. Black box models are those where there's no physical interpretations of the system behavior is taken into account. It just take into a simple set of equations, maybe geometrical parameters, but does not take into account of detailed system behavior. Gray box models are more towards a physical model of the system itself, which involves equation of law of conservation of energy, momentum, and law of conservation of mass, and taken into account and applied into each discretization nodes. But that leads to very high computational efforts. We need to take a couple of days to solve for one volumetric expander. So instead, we choose a model that is in between blocks and black and gray box model. That is a semi-empirical model. We adopted part of empirical correlations that comes from the geometry. We adopted basic fundamental equations of law of conservation of energy and mass and applied them together to see if we can have a trade-off between computational effort and accuracy. And we developed this empirical model, and it was validated with experimental data at different test rigs at 3 different countries. And we have a reasonable agreement between the values that we obtained from the model and the values that the simulation model provided. So it seems that this model could be used to analyze the performance of different volumetric expansion machines. We did considered 3 major features of volumetric expanders and classified them as economics, commercialization, technical features. And in these, we will give them score and divide the score from 100. So, for example, economics, cost of expanders count around 12%, and reliability consider 8%. So there's a detailed model of each of these metrics. I'm not going to detail how we estimated the cost of expanders, but anyway, if any one of you is interested to look into cost, because that is an entirely different submodel that involves development of the expanders in a CAD model where we develop each single component of expander, join together them and see how much materials we have used and how much, what different manufacturing processes has been adopted, and then come up with an empirical correlation that takes into account the manufacturing, the material cost, and the labor cost, and then we have a final relationship of the volume of the cost estimation. And we assume that all those expanders are made from stainless steel, and we are producing 2,000 pieces per year, and then we have this production cost and cost of expander. So similarly, for every these performance indicator, we have a detailed background model that is being used to assess the performance of these expanders technologies. So there's a detailed leakage models, friction loss models, and then we give the weightage. So if let's say a system has lower cost, and as we have 4 expanders, and we said that the highest cost, the highest number we can give is 12 marks for one expander technology that can have the lowest cost. So that is a comparative performance. We are comparing the cost between these 4 expanders, that is screw expander, scroll expander, van expander, and piston expander. The lowest cost would lead to highest score. So in this case, the highest score was for van expander, that 12. And same goes for different performance indicators, and we add them up. And it seems that the highest score was for screw expanders, followed by scroll expander. Van expander is least attractive options, and then we have piston expanders. These performance metrics could be used for basic guidelines for development of ORC testing. And the system power that we have adopted for this simulation was between 5 kilowatt to 50 kilowatt. So we have the system at 5 kilowatt, analyze it, then return it at 10 kilowatt. So with an increment of 5 kilowatt, and then for each system, we have take the average for everything. So for example, for screw expander, we included the cost at 5 kilowatt, 10 kilowatt, 15, till 50 kilowatt, and then take the average cost. And same goes for the rest of the features, and we got these total scores. The concluding remarks are that these volumetric expanders are low cost, two-phase, low cost and relatively simple machines that can be adopted for ORC and 50 kilowatt systems. They can withstand two-phase region, a two-phase state of the working fluid as well. And they have lower RPM. That makes them ideal for small-scale ORC system under 50 kilowatt. A typical expander would cost between a couple of 100 pounds, maybe from 500 pounds to maybe 2,000 pounds. And if you compare to turbines, they cost you around minimum to 15,000 to 30,000 pounds. There's a huge different cost between volumetric expanders and turbines. In terms of technical complexities, they need lubrication, and in terms of technical complexities that we have to look into leakage losses, how we can remove the losses between each expansion chambers, how we can reduce the friction losses and leakage losses. There are only few commercial suppliers for these technologies because these are still being developed within the labs in different industries. They are not yet fully commercialized. And one of the key reasons is they have relatively low isentropic efficiency between 60 to 70. In reality, if you operate in ORC condition, in ORC system, they might have efficiency between 50 to 60%. So they need to have higher efficiency, and different researchers are working on it to improve the isentropic efficiency of these expanders. And that is one of the barriers that is yet not commercialized. When expanders are relatively less attractive and out of the race due to higher friction loss and leakage loss, but still many researchers are working to improve the van expanders in terms of higher isentropic efficiency, how they can reduce this friction and leakage losses. Scroll and screw expanders are more suitable, and it could be seen from this score as well as If you see the market and you will Google that, if there's an screw expander, you will find a couple of suppliers. If you look into scroll expanders, you will find maybe 1 or 2 expanders. So this is one of the reasons that satisfy our calculations, and these results that these are the results that we have obtained have a good reasonable agreement with these markets. The piston expanders require precise control and difficult to maintain and requires high cost of controllability. One of the key areas where we look, we're currently working in volumetric expanders is how we can come up with a modular design in terms of reducing the leakage losses and friction losses of these expander technologies. And we are working at the moment on a kind of screw expander technology, single screw expander technology, where we are working how we can reduce the losses and improve the isentropic efficiency of the expansion machine to about than 70%. So we are working on simulation models as well as experimental studies and studying each expansion chamber. I did not went into details of the working principle of these expansion machines, but again, the expansion machines they make series of expansion chambers. Each machine has it may range between 3 to 8 expansion paths along the length of flow of fluid. So these chambers, the design is really important when it comes to leakage losses and friction losses. But anyway, that was all for my side. And if you're interested to look more into volumetric expanders, I have a book chapter that is purely dedicated on mathematical modeling of positive displacement expanders. I do have a review paper on volumetric expander technologies. I have a couple of papers on volumetric machines, both at experimental and simulation studies. So you're more than welcome if you want to discuss more in details about volumetric expander machines. That was all from my side, and looking forward to discussion and questions if you have any. Thank you.
Thank you very much, Dr. Imran. It was a very thoughtful presentation on the volumetric expanders. Unfortunately, we are running out of time, so we won't have time for the question and answer session.
No problem.
And I would like to thank for your time and the very nice presentation.
Thank you. Thank you very much, Tavish.
A virtual shield for your time.
No problem. It was wonderful to speak to you guys. I would have looked into more into time. I would really interested to have this discussion. But anyway, it's great to speak to you guys. And again, I will have you will have my email address on the website. If you want to contact me, you can reach and search me, and I would be more than happy to discuss further in this area if anyone is interested. Thank you very much.
Yes, thank you very much. We will share the email contact with the participants as well.
Thank you.
If any participant is interested. Thank you.
Thank you. Bye.
Yeah, thank you. Bye-bye. So we have a last presentation of this invited talk session. And our next speaker is Dr. Shahid Rasool. Dr. Rasool research aims to enable the clean, affordable, and large-scale electrochemical conversion of carbon dioxide and storage of renewable energy to fuels. Dr. Rasool's research focuses on studying the fundamental process at the electrochemical interface, which defines the kinetics of the electrochemical process and ultimately determining the efficiency and selectivity of the reactions. Dr. Rasool has discovered several new electrocatalysis catalysts for the carbon dioxide reduction.
Dr. Shahid Rasool, you can start now.
Thank you so much. I'll share my screen with you, and please let me know if you can see the screen.
Yes, we can see your screen. We can hear you as well.
Yeah,
can you please share the presentation?
Yes, sure. So do you see the presentation now?
Yes, sir, we can see the presentation now. You can carry on.
All right. Okay. Thank you so much for this invitation, and I'm really thankful to Professor Vakar and his team that they invited me for this talk. And to be very honest with you, that I am really amazed to look at the way the team has arranged this conference. They have been so much professional in their approach, especially Dr. Muhammad Ali and his team. So very well done, and I congratulate you for holding such an successful event. And being a kind of ex-UETian, it is also a kind of honor for me as well that I'm speaking to some of my teachers or some of the students. So it's really, really kind of emotional for me as well. So thank you very much again for all of the organization and the organizers. So coming towards my topic, so just a minute, please. Yeah. So as you can see that I'm going to talk about storing the renewable energy electrons into high energy density molecules. And we think that that is a way forward for renewable energy sector. And I am working at Northumbria University as a senior lecturer, and I have a research group at Northumbria University, and we are working on computational and experimental side of the things, especially for the design of the materials. So what we are working at the moment is the energy storage, that is lithium-ion and magnesium-ion batteries or supercapacitors. Then we are working on the electrocatalysis side, that is what if we can convert carbon dioxide into some useful fuels, and also generation of hydrogen from water splitting, and some of the work I'm doing at wastewater treatment as well. On the other side of the experimental research, I am working on theoretical modeling and simulations at the atomic levels using DFT calculations and battery modeling, especially for the battery thermal management system. So this is the overall overview of the work we are engaged in at Northumbria University. So for today's talk, this is the main slide which I want to show you. So this is the energy conference, and obviously we need to think from different energy vectors for from sustainability point of view. And we know that carbon dioxide is a kind of nasty gas that makes that is one of the greenhouse gas part of emissions. What if we have carbon dioxide from the industrial sources? What if we have carbon dioxide from, let's say, steel mills or power plants or some other industrial sources? And if we could utilize that carbon in it and make some fuels out of that. So one of the things which is very important at this point when we are talking, so especially in advanced world, we have seen that there is enough renewable energy available in terms of electrons. So we have renewably sourced electrons, and when it is sunny days, let's say in UK or in Europe, we have enough electrons, but when we want to store them, we need batteries. So there is not really a really good mechanism that we can store these renewably sourced electrons into batteries. The reason is the batteries are very expensive, and also the energy density for the batteries is very small compared to when we compare the energy density of batteries with, let's say, gasoline, petrol, or gas, or other fuels. So what we are, the dilemma of facing is that when we have renewably sourced electrons, we do not have really the systems which can store these electrons. So one of the alternative could be that if you have electrons, for example, renewable electricity available, what if you have water and carbon dioxide and you do the electrolysis? And from water and carbon dioxide, what you can do is that you can generate hydrogen or carbon monoxide. So these are some of the the feedstock materials that we use in chemical industry or for the fuel synthesis. And now there is a terminology called electrofuels that could be used either for the shipping or for aeroplane industry or even for the bigger trucks as well. For passenger cars, the batteries they can work, because obviously for the passenger cars we really don't need very big amount of energy stored in batteries. But when we talk about, for example, planes or ships or bigger long haul trucks, then we need the fuels. The reason is that we have already a very big infrastructure developed. So if we have carbon dioxide and if we have water and if we have renewably sourced electrons, there is a good chance that we can sustain our chemical industry, our fuel synthesis, to sustain our transportation, especially the long haul transportation systems. And if we estimate the value of this industry, that is about $500 billion. So there are lots of opportunities from commercial point of view, from industrial point of view. And also the good thing about this is that you don't need to change the infrastructure. For example, if you use hydrogen only as the energy vector, or if you use, let's say, ammonia is the energy vector, then you would have to change all of the infrastructure, or at least you have to replace the existing energy infrastructure. So if you go through this route, then definitely you are much easier to go towards these industries, because all of the infrastructure is available. And there is another advantage of using carbon dioxide in water is that it really does not harm the food supply chain. So security of supply chain is always there, especially countries like Pakistan. So when we majority of the energy we import in terms of gas or petrol, so what if we have localized sources available in terms of, let's say, solar energy and water, then we are good to go and there are no issues regarding the supply chain. So for example, if you have carbon dioxide, what you can do from carbon dioxide? So let's say if you have electrons and you want to convert carbon dioxide, and if you have carbon dioxide, you have captured it, then without conversion, you can use it for several purposes. For example, enhanced oil recovery or geothermal fluid or beverages. But what if you convert into, let's say, fuels, syngas, methane, formic acid, methanol, or even you can make some carbonates or polymers or aggregates. So I'll show you that how we can do that. So carbon dioxide utilization is not a new thing, or it is not very far or distant technology that we will not be able to see commercially. So this is one of the recent articles which published in Science, and you can see that the technologies which started, let's say, in 2009, and it's about 10 years now. So, for example, H2O electrolysis to generate hydrogen, CO2 electrolysis, let's say, to convert carbon dioxide, and carbon monoxide electrolysis. So as you can see that these are the stack test duration. That means that how much stable these systems are. as you move along, in just 1 decade, as you can see that in just 1 decade, we have improved a lot in terms of the stack stability. So we can have really good stacks available for hydrogen generation, for CO2 reduction, for carbon monoxide electrocatalysis, for thousands and thousands of hours. Initially, so if you look at this one, so this is 2009 and this is 2019, we had many losses during the stack operations. But as you can see that as the time is passing, whether it is hydrogen generation or carbon dioxide conversion reaction, then the stack stability is improving and the losses we are decreasing. So what if on the commercial side of the thing? So for example, in 2015, so this is the hydrogen demonstration plants. So majority of the plants, either they are in Europe or in US. So as you can see that this is the plant production capacity. This is normal meter cube per hour. So this is for the hydrogen generation in Rotterdam. And this is for the carbon monoxide generation from carbon dioxide. So looking at this, and these are the year of commission, looking at this data, we can definitely say that the pilot plants are coming in place either for the hydrogen generation or carbon dioxide reduction reaction. And especially for the carbon monoxide plants, it is in majority of the times in US. But the commissioning is going further and further. So commercialization of this technology is going on, and that is very important. So in UK, a couple of years ago, we were awarded a £2 million kind of investment from Research Council, Engineering and Physical Science Research Council, where we were given a kind of challenge that what if you have a municipal wastewater, and what if you can generate the renewable energy from this wastewater in using the bioanodes? What we can get is the clean water as a result on the anode side. And on the cathode side, what if we have carbon dioxide, let's say from Tata Steel Mill? Then can we convert that carbon dioxide using this renewable energy into formate? And we can feed that formate into SimCell, we call simple cell. Those are the bacteria to generate liquid fuels, let's say gasoline or biodiesels or so. So this was one of the investments we got from United Kingdom. Right. So how the carbon dioxide reduction reaction happens? So it's very simple. It's a very simple electrochemical system. You have anode, you have a cathode, and then you have a membrane in it. So what you do is that you apply a voltage across the anode and cathode. At anode, you get the oxygen, and at the cathode, when you convert carbon dioxide in water with electrons to carbon monoxide, and you generate some of the hydroxyl ions. So this is very simple process. But what happens is that when you want to convert carbon dioxide electrochemically using this process, what you see is that the thermodynamic potentials for carbon dioxide conversion is very, very close. For example, so since there is water, what we want to do is that we want to convert carbon dioxide into CO. But these electrons somehow reduce water and they generate lots of hydrogen. We really don't want to get hydrogen from this process. We want to get carbon monoxide. So sometimes the selectivity of the reaction is very important. So for example, at these potentials, so these are the cathodic potentials, the applied potentials on the cathode, you can see that you will get methane, hydrogen, formate, ethylene, carbon monoxide. So instead of getting one product from carbon dioxide, you get many products. And that becomes a challenge because obviously you want to have one product instead of many products. But why do we get that? So this is the electrified interface. what happens is that carbon dioxide molecule comes to this electrified interface, and some of the electrons, they are transferred to carbon dioxide molecule to generate a carbon dioxide radical. And if this carbon dioxide radical is stable or it is bound with the surface, then it needs further electrons and protons to be transferred to get carbon monoxide. And still, if this carbon monoxide is still bound to the surface, it will get further 4 protons and 4 electrons to get methane, methanol, ethylene, and so on. So this is the electrified interface where all of the intermediates of the reaction should be stabilized on the surface so that you can get C2, C3 products. So for example, for biodiesels or gasoline, you want to have, let's say, C8, C9, or C10. So this is a very, very a challenging reaction. So that is why you don't see many commercial available technologies for the carbon dioxide reduction reaction. Right. So there are several strategies that we can work on carbon dioxide and we can convert into, let's say, carbon monoxide. So one of the strategy recently in last decade, it was published by Matthew Canaan in Stanford, and they have published many of these strategies in Journal of American Chemical Society or Nature. So what they do is that, what if you have a gold, just a metallic gold, and if you do the carbon dioxide reduction reaction to get the carbon monoxide, what happens is that you need to provide lots of energy to get these products. But what if you oxidize gold and then reduce it electrochemically? What you can do is that you can reduce the amount of energy to get carbon monoxide. So what you do is that if you use simple gold electrode, then you need to provide higher energy to get carbon monoxide. But what if you oxidize it, you just put a gold metal, let's say at 300-400 degrees C, and then just reduce it electrochemically, you can improve the efficiency of the whole system. So getting some inspiration from there, so we said let's do the similar strategy on tin-based alloys. So we have taken a tin, lead, and antimony alloy, and we have tried to oxidize it electrochemically and then reduce it in CO2 environment, and what we get is formic acid. So from carbon dioxide, we are getting formic acid. But what is the Faraday efficiency? So when this is a pure alloy electrode, as you can see that, and this is the cathodic potential, at much higher energy, we can get about 60 to 70% Faraday efficiency for the formate. When you oxidize this electrode at 4 volt or 5 volt or 7 or 9 volt, as you can see that the Faraday efficiency for the these electrodes improves, and at 5 volt, when you oxidize it at 5 volt, you can see that it gives you about 90% of Faraday efficiency for the formate production. So these results then suggest that when you oxidize the surface of a metal and then you reduce it electrochemically and you do the electrochemical reduction of CO2 on that, the Faraday efficiency improves. So we have done some analysis or the material characterization on that. So for example, if you do the cyclic voltammetry for the alloy only or under nitrogen and under CO2, you can see that the onset potentials have moved towards more anodic. That means that under CO2, the reduction reaction improves and the energy required is much lesser. And also the current density improves. That means that the activity of the catalyst improves. So this is the XRD analysis, which shows that on the surface, there is some reconstruction when you do the electrochemical CO2 reduction reaction on this alloy electrode. But overall, the composition of the electrode does not really change. And these are some of the scanning electron microscopy images. So as you can see that when you do the CO2 reduction reaction, the surface becomes kind of porous. And then this is the EDX mapping. So if this is the surface, then you can see that this is tin, lead, and antimony. And as you can see that where there is tin, there is antimony, and somehow they quite in harmony with each other. And lead has another phase. So there are two types of phases on the surface. One is tin rich area, and the other one is the lead rich area. So this is the surface. But another thing we wanted to see that why the Faradic efficiency of oxidized surface improves. So this is the electrochemical impedance spectroscopy analysis. As you can see that this is the alloy before carbon dioxide reduction reaction. This is the oxidized alloy before CO2 reduction reaction, and this is after. And when you enlarge this area, because majority of the interesting phenomenon happens over here. So when you enlarge it, you can see that. So when you have this alloy after CO2 reduction reaction, the charge transfer resistance is much lesser. So more electrons find it easy to get transferred to the CO2 molecule, and that is one of the reasons that Faradic efficiency improves. When you compare it with this alloy electrode, which was oxidized at 5 volt, to just tin. So we for the sake of comparison, we did it that if we take only tin and oxidize it, and we compare it after CO2 reduction, still tin will show lots of charge transfer resistance compared to this alloy. And this is the enlarged part. So if you can improve the charge transfer resistance for the alloy or any other metallic species, then you can improve the CO2 reduction reaction. So we did some XPS analysis, X-ray photoelectron spectroscopy, and this is the tin. So we wanted to see that what is happening on the surface of the electrode. So this is tin edge. This is before oxidation. As you can see, there is metallic tin and there is some tin oxide. When you oxidize it, all of the tin is converted into tin oxide. And when you do the CO2 reduction reaction, due to the electrochemical reduction of potentials, you can see that the metallic character comes back. And similarly, this is the tin, lead edges. There is some metallic lead and some of the lead oxide. On the other hand, all of the lead is converted into oxide when you do the oxidation. And after reduction reaction, there is some metallic lead, some lead oxide, and some of the lead carbonate formation on the surface. So similarly, we did the analysis for the antimony. So antimony also shows a similar behavior. So what we see from this XPS analysis is that initially there are some native oxides present on the surface of the electrode. When you convert those native metallic structure into oxide, all of the structure is changed into oxide. And after conversion, the metallic structure comes back. So then we did some of the stability analysis on that, and we published this work in 2019 in Journal of CO2 Utilization. And we could show that these electrodes are quite stable and can work for several hours to generate formate from carbon dioxide. So overall, the summary for the formate prediction is that if you have a different metallic structures present in the electrocatalyst, you can improve the conductivity and CO2 stabilization to get the formate prediction. So this is the formate. CO2 converts into formate. There is another study we published in 2015 for the first time that if you have copper indium and copper tin electrocatalyst, then you can produce carbon monoxide selectively. You can get only one product at lower supplied energies from CO2 to get carbon monoxide, and that is quite a stable structure. And this is the transmission electron microscopy for those alloys. You have copper in the base, and you have green, that is an indium, very thin layer of indium on the surface, and you can get very good selectivity from CO2 to carbon monoxide. And we wanted to show that this is a universal reaction. So not only indium, because indium is expensive metal, what if you make copper and tin alloy, then you can get carbon monoxide as well. So this is for the copper tin. So this is copper indium, and this is copper tin. We did some DFT calculations on that how the material will behave. For example, if this is in blue, this is copper surface. What if you put a tin? So where the tin atom would like to go. So we calculated the energies, and similarly we took some of the copper 211 planes, and then we wanted to find out that how the tin or indium would like to go on the surface. So we did this, and ultimately what we get was a very low activity. That means that the conversion of CO2 to carbon monoxide was good, but the activity was not that good. That means that the low current density is the major limitation in this research. Then we moved towards another strategy, that what if we want to keep the same selectivity to carbon monoxide, but we want to have a higher current densities. So we prepared copper tin alloy by galvanic replacement process, and these are some of the SEM images which shows that how the copper oxide is coated by tin using this galvanic replacement process. So remember, the first time when we published this work, it was about 1 milliamp per centimeter square of the activity. So when we did this tin at cuprous oxide for 30-minute deposition, 60-minute deposition, and a 90-minute deposition, as you can see that the scale of the activity improved almost 100 times. So when you produce electrode just from metal, the current density or the activity you get is about 1 milliamp per centimeter square. But if you change the process to develop the electrode by using a galvanic replacement process, then you can get it to 100 milliamps per centimeter. So copper tin alloy with 60-minute deposition gave us the highest electrocatalytic activity. So this was for the copper tin. So you improve the activity. Do you decrease the selectivity? We found out no, you still keep the selectivity. You can still make a lots of carbon monoxide from carbon dioxide, as you can see over here. So majority of the times you get carbon monoxide with small amount of hydrogen. So our work work very well. So then there is another thing. What if we use the same process for the copper indium? So again, we did the same thing with copper indium, and we produce a kind of hybrid structure with indium hydroxide and with copper oxide based surfaces. And these are some of the electrode we produced, and we published that one in 2020 last year. And this is the schematic how our carbon dioxide working towards carbon monoxide. And as you can see that majority of the times we could get carbon monoxide at very high activity from this process. And when you compare our work with the published data, we can see that this is the CO2 yield, CO yield from CO2 compared with the other reported literature. So our work went really well, and we published this work last year as well. Now, so we have got carbon monoxide, we have got formate. So all of these have carbon 1 one carbon in it. More carbon you have from CO2 conversion, better the value it will have. So now we are working towards, for example, if you have a copper-based lattice and you are adding indium in it, what are the structures you can get? So one thing is that I can go to lab and I generate these structures experimentally and then work on for the CO2 reduction reaction. But on the other hand, if I have access to a supercomputer, that is UK's national supercomputer facility, Archer, and if I can run the structures and I can find out that what will be the energies involved for the structure development, then I can save lots of time. So one of my PhD students now, he is working on generating or designing or making tailor-made surfaces for the CO2 reduction to get C1, C2 and C3 products. So for example, this is the copper indium based structure. We want to see that what if you have hydrogen atom, or what if you have a carbon monoxide molecule, when they come to the surface of copper, what will be the energies involved? Will they be stable? How they will perform? So this is the DFT calculations Ian is working now on. The other target, so now we are moving from C1 products to C2 and C3 and C4 products. So what we want is that what if instead of two metals, let's say copper, indium, you introduce an other metal, would it be possible that by alloying or by using the promoters on heterogeneous catalysts, is it possible that we can get C3 products, for example, propanol? Is it possible to get C4 products or C5 products? So we are working towards that. Ultimately, what we want is that if you have water, if you have carbon dioxide, if you have renewably sourced electrons, we can make gasoline in the lab, and then we can scale that up. So this is the trimetallic system we are working towards, C2 and C3 based product. So in conclusion, in lab scale, we have shown that we can get carbon monoxide at very good activity and selectivity. We can get formate from carbon dioxide, and there is a possibility that we can move from lab scale to pilot scale and to the commercial scale. And in the past 5 years, the electrochemical conversion of carbon dioxide has become a commercially viable process, as I showed some of the slides in the start of my presentation. So there is a very good opportunity for the industries, for the R&D organizations to be involved, so that another energy vector could be added to the energy infrastructure. And that is very important from energy security point of view, energy supply chain point of view, and local resources could be really used in such a way. So some of the things to the funding agencies, for example, EPSRC or LifeScore project, some of the national facilities for supercomputing or the XPS, and these are some of my collaborators. And before I stop, there is a workshop we are going to organize, that is development of climate change resilience in Pakistan through textile circular economy, that has been funded by British Council and Northumbria University alums. We are trying to collaborate and to work towards the circular economy, especially in the textile sector in Pakistan. And some of the details will soon be available on our webpage. And thank you so much for listening, and I am open to questions if you have any. Thank you.
Thank you very much, Dr. Shahid Rasool, for a very nice and thoughtful presentation. Surely this is really the science that runs behind all the commercial technologies, and it costs a lot of money and a lot of energy and patience.
Yeah, you're right.
Let's see if we have a question from our audience. No. Actually, I have been working on a very similar subject in Delft University of Technology.
Oh, that's great.
That was co-oxidation of hydrogen and carbon monoxide in solid dioxide fuel cell. So the subject is very close to my heart and my understanding. During this presentation, I had so many thoughts and questions in my mind due to time limitation. I just want to know your expert opinion on just 2 questions.
Sure.
First one, you mentioned a concept like microbial fuel cell application for conversion of carbon dioxide. And what was your conclusion and your future thoughts on that?
Yeah.
The second is as per our experience in co-oxidation of carbon mono and hydrogen. But we figured out if we supply this mixture into the fuel cell, then it's a hydrogen that preferentially are selectively oxidized and followed by a very tiny amount of carbon monoxide. Do you think if there is a similar concept in co-electrolysis of carbon dioxide and steam or water, let's say?
Yeah, I think both of your questions are very much relevant and very important. The first question is, and the first question related to the bacteria or the bioconversion is very much relevant to Pakistan economy, because we are agriculture-based country and we can definitely go towards that. So from our experience, we have seen that if you have the bacteria, let's say, Geobacter or some other bacteria, you just feed the bacteria the municipal water or the domestic water. And there are lots of organics involved in the domestic or municipal water, which bacteria could be fed on, and ultimately they generate the electrons from there. Those electrons could be utilized for different other chemical processes. And ultimately, the organic matter which is in the municipal water will be used by the bacteria, and they will be able to give us the clean water. So we have worked on that. We have published several articles on that, especially from my previous group at Newcastle University. From Dr. Eileen Yu. So that was quite a big success, in fact, and we are just coming to an end of this project. So we worked on the electrocatalysis point of view, we worked on the bioelectrocatalysis point of view, and that is a very, very simple system. It is not very high-end technology. We've shown that in the lab, it's much easier to work on that sort of technology. So that is very much relevant. The other thing, the co-electrolysis, for example, CO2 or hydrogen or some other, feedstock, if we can do the co-electrolysis, that are some of the interesting technologies coming. So, of course, when you have hydrogen in your feedstock, the chemical reactions become much easier compared to when you have carbon dioxide and water only. So co-electrolysis is a very good possibility, but I have not seen many papers or research on that side. Definitely, there is a big opportunity on that side, that if you have several feedstock available and you can feed into the electrocatalyst side, what if that all of those feedstocks, they combine electrochemically to give us one product. So that is another thing, I think, a very good idea. I have never thought about it, but I really like the idea itself.
Yes, thank you very much. And have you any opinion on using mixed ionic electronic conducting materials, let's say CERAD, for this kind of application?
Yes, in solid oxide electrocatalysis, people are using, several materials, for example, CERAD or some other materials. But obviously, as you know, that there are high temperatures involved in that one. So some of the companies I mentioned, they are going for the SOECs. We are working at room temperatures and we have not tested that. But from hydrogen generation point of view, from CO generation point of view, I think the companies are going towards the solid oxide electrocatalysis point of view. So yes, there is a big opportunity in the solid oxide electrocatalysis, and I think majority of the times the companies are going through those technologies instead of room temperature.
Yes, thank you very much.
Thank you.
I hope to continue such discussions.
Sure. Looking forward to work with you.
As well. Thank you.
Thank you.
I would request our team to present the virtual sheet.
Thank you so much. I hope to see you in person sometimes at UET. I'm really missing UET. I spent very good time at UET.
You are warmly welcome to have a visit in UET again.
Okay. Thank you so much. Thank you.
Yes, thank you for your time and a very nice presentation.
Thanks so much. Take care.
So we are at the end of today's session. Yes, thank you.
Thank you.
And then I will request our team to display what kind of activities we are running in Energy Center, UET Lahore. And after that, the session will be closed, and we will continue tomorrow for the second day of the conference. Tomorrow we will start at 10 for the invited talks and 10:30 for the paper presentations. Thank you, everyone. Thank you, participants. Thank you, distinguished speakers, for your time and your concentration for this conference. Have a good time.
Thank you so much, Dr. Tabish, for the ending remarks, and thanks a lot to all the panel speakers for participating. Now we will be showcasing you some of our exhibition projects which are being displayed on our website as well. So enjoy our exhibition. Thank you very much, ladies and gentlemen.
Assalamu alaikum. My name is Imran Ali Shah. I am managing Energy Lab, Al-Khwarizmi Institute of Computer Science, and also providing services in Center for Energy Research and Development, which is a state-of-the-art research and testing facility located in the new campus of University of Indian Technology, Lahore, Kala Shah Kaku. We are providing different kind of services like consultancy services, third-party validation services, energy auditing services, and we have some kind of research projects from technology development program from HEC and also NRPU program, and we are also providing training services in related to energy sector. We are providing consultancy services to the energy department. In this consultancy, we are providing energy auditing services for 40 DHQs located in 36 districts of all over the Punjab. Funded project we have done recently in HEC installed 55 kilowatt solar system and search the behavior of the variety of the irradiance and the angle that can impact on energy generation. Secondly, we have CF projects. We have developed a cleaning robot to be very effective to save the water and at the high efficiency of the. We are also working on a project by the HEC. This project is that is a municipal waste to energy. We can convert the plastic as a medical waste that is very harmful for people, and we can convert this plastic to energy by using some nanoparticle that we are developing in our lab. And this is a project we are developing with the help of JV partner from NCP Islamabad, and providing training services with that is the federal government department, and same is we are also doing with Punjab Skill Development Fund program testing services. We have developed one of the state-of-the-art lab in PV testing lab in Kala Shah Kaku campus, and developed the LED testing facility over there. We have state-of-the-art facility available, which is largest and one of the best facility. Recently, we have done a program in Karachi University, ICCBS, and installed 1 megawatt solar system. The same is the case. We have provided technical to the University of Indian Technology, Lahore PD department, installing 1 megawatt, which is the first ever project in the public sector institution.
Assalamu alaikum. Battery has been a critical component in energy storage, especially with PV systems, and has been misquoted with the suppliers by forging the values of battery systems. Battery tester is a cost-optimized solution which can help estimate the battery capacity with higher precisions and validate the claim of rated values, which lead to the better system design and ultimately help to reduce the risk associated with battery backup systems.
Assalamu alaikum. I'm Karutulan, working in Energy Lab in the Hazmi Institute of Computer Science, UET Lahore. With the increment of PV integration in the energy mix of Pakistan, an urgent problem faced is the cleaning of solar PV modules. Currently, our market is not addressing this problem properly, and the soiling problem reduces the energy generation hugely. Therefore, a localized and efficient solution is required to fill this gap in the market. A self-cleaning robot for PV modules has been developed and designed by our team under EGC TDF fund. Our robotized solution not only reduces the time but also water and labor needed for cleaning tasks, and it increases the energy generation by an approximate 5%. The activity of this device can also be controlled remotely through GSM or Zigbee. The payback of our robotized solution spans over 12 to 18 months with an expected life of minimum 5 years.
The light testing services that we have in CERAD are the electrical and photometric test, chromaticity test, harmonic current emission test, impulse test, LED driver test, salt spray test, IP and IK test. The electrical and photometric test used to determine the luminous intensity, luminous efficacy, light distribution diagram, and the other electrical parameters. For that purpose, we are using the gonio spectroradiometer, that is a D-type gonio for near field detection, and we also have a C-type gonio that's used for the near field and far field detection. IES files also produced using this setup, which is further used for the simulation of lightning models. The integrated sphere is used for the chromaticity test, in which the color rendering index and the correlated color temperature were measured. Harmonic current emission test is also done using the power meter that is integrated with this integrated sphere, and it can determine the harmonics of the current and voltages. We have a temperature and humidity chamber which will use for the damp heat and environmental test. In IK test, an impact of 5 joule is applied on the luminaire body at different points to assess its withstand capacity. We are offering following tests in CERAD. Few of them are the determination of real power at STC condition using the sun simulator that can emit a light of 1000 watt per meter square at a temperature of 25 degrees C, and air mass is set at 1.5. IV and PV curve also determined using the sun simulator. Another test that we have is the EL test, that is named electroluminance test. EL test setup capture the image of the PV module, whose quality is assessed to detect the cracks and defects on the PV module. Bypass diode test is also used for the PV module. Bypass diode thermal test is used to assess the adequacy of the thermal design and long-term reliability of bypass diode. Another test that we have is the ultraviolet preconditioning test. Ultraviolet preconditioning test is used to identify the degradation of the PV module material through ultraviolet radiations. Module breakage test is also applied to the PV module to determine the strength of the PV module, and mechanical load test can determine the ability of the PV module to withstand the mechanical load and stress of the PV module.
Assalamu alaikum. My name is Mohammad Amza Lateef, and I'm working as a research assistant in Alternate Energy Research and Innovation Lab, UET Lahore. In addition to that, I'm also working as an instructor for PSDF and NAFTA courses. The ultimate aim of these courses is to target the renewable energy sector. In renewable energy sector, they target solar, they target wind, they target geothermal, and they target hydel. The main focus of these courses is to create employability in the market and to make the students self-sufficient so that they can create their own startups and create jobs in the market. Last but not the least, one of the ultimate aims of these courses is to enhance the R&D sector and to make them self-sufficient so that they can pursue their careers and they can start their masters and PhD, and they have the prerequisite knowledge to pursue their higher education.
Assalamu alaikum. My name is Muhammad Ali, and I am working as Senior Research Manager at Al-Khwarizmi Institute of Computer Science and also providing support to CERAD labs. We are working on various energy efficiency related projects, especially related to the industrial sector. We started off with the energy efficiency course funded by GIZ Germany, where we have senior level people from industries coming over on weekends to get hands-on training. We also developed a motor testing system based on IEC standard. The motor tests the running efficiency of induction motors, which is very important in decision making for motor replacements or making improvements. We won a project from UNIDO for sustainable energy initiatives for Pakistani industries, focusing on paper and pulp and ceramics sector. We won a TDF project from HEC on solar inverter development. It's very essential for us to get these products developed in Pakistan for customized needs, preserve foreign exchange, development and education for local engineers. We won funding again from HEC for pump testing system development. The system tests the efficiency of centrifugal pumps, giving a lot of benefits to its users. We are working very closely with PICA for establishing EC testing lab at CERAD, Kalashakaku campus. The lab will test energy efficiency ratio and coefficient of performance of air conditioners, in addition to various other parameters mentioned on the nameplate. We are also offering short training courses on energy efficiency, programmable logic controllers, industrial instrumentation, in cooperation with NAVTTC and other funding agencies.
This project tends to determine the efficiency as well as the pump curve of pumping system. In any industrial or commercial facility, we can determine the pump curve from ratio of flow rate and the head of the pump. This solution gives us the real-time efficiency data of pump of industrial or commercial systems. The test bench duly equipped with PLC, programmable logic control, and a VFD, variable frequency drive, from which we can change the speed as well as the technical parameters of pump as per demand. All parameters and real-time data are displayed on a HMI screen. This demo test bench contains 1 HP motor of 3-phase power. This project has been awarded from HEC through TDF Technology Development Fund. Thank you very much.
The project is to develop an economizer to control and automate the pigmentation of leather skin with minimal pigment waste at less cost. This system to automate the leather spraying process is locally developed and presented for the first time in Pakistan leather sector with high precision and calibration. It immediately becomes mature and has been installed on various finishing plants across the country. And how it is working, the leather skins are placed on the conveyor of the leather machine and pigment coating is done by solenoid placed on carousel. Economizer detects the speed of the conveyor and carousel and convert the area of the leather skin into the digital format using IR scanner. After computation of calculation, it directs the guns to perform the efficient spraying. It also provides the user-friendly interface and flexibility in adjusting the parameters required for the process. And what is more, the system at the end of the working day gives you more than the 25% saving, thus entirely repaying itself within a few months.
Pakistan is faced with energy crisis due to shortage of 7 gigawatts of electrical energy. 65% of the electrical energy is produced by thermal resources, among which coal is the cheapest. This makes it inevitable for us to move towards coal power generation. However, the problem is, in Pakistan, the coal quality is very low, so we need to process it to make it suitable. Here, our facility, Mineral Processing Research Center at Mining Engineering Department, University of Engineering and Technology, Lahore, comes in. We collected samples of 32 million tons of Punjab coal and 130 million tons of Khyber Pakhtunkhwa coal. We processed it through crushing, grinding, flotation, and gravity separation, and we have made it suitable for power generation. In addition to this, we are also committed towards renewable energy storage. For this, we are recycling printed circuit boards and mobile batteries to extract the raw material for lithium-ion batteries manufacturing. For printed circuit board recycling, we are using shaking tables, electrostatic separators, magnetic separators, and leaching. While for mobile batteries, we are sticking to crushing, screening, and smelting.
Assalamu alaikum. My name is Dr. Tabish. I'm working as assistant professor in Chemical Engineering Department, UET Lahore. Every year, millions of lives are lost because of drinking contaminated water. Availability of clean drinking water is a basic human right, and the water contains several including and biological contaminants are the most common because it contains microorganisms, and those microorganisms lead to several diseases and casualties. There are several techniques to disinfect the microorganisms, and those techniques include ultraviolet radiations, reverse osmosis, chlorination, and ozonation. Reverse osmosis is a versatile technique, but it's expensive to buy and difficult to operate. And ultraviolet radiations, they have technological limitations because of the transmission limits of the ultraviolet radiations within the turbid water. Ozonation and chlorination, they produce disinfection byproducts, and disinfection byproducts, they are harmful in the treated water. We are working on another technique, that is electrochemical disinfection. Electrochemical disinfection works on the principles of electrochemistry. On the electrodes, electrons are generated, and these electrons directly disinfect the microorganisms. Alternately, several chemical radicals are produced, and these radicals include hydroxyl radicals, and oxygen radicals. And when microorganisms come in contact with these radicals, they become hibernate and disinfect. The overall electrochemical disinfection system, it contains pre-filtration process, electrochemical disinfection process, and the post-filtration process. Pre-filtration is to ensure the removal of particles that are more than the micron size. Electrochemical disinfection removes the microorganisms, and post-filtration is to remove the dead bodies and also to polish the treated water. This electrochemical technique against the competitors, it offers several advantages. For example, the low cost, environment compatibility, easy to operate, and their preservative effect in the treated water. Major target of this project is the undeveloped, the developing countries, especially the low-income communities of Pakistan. In the flooded areas, the flood water contains all these microorganisms, and in the flood time, it becomes very difficult to supply the drinking water. We are working on the development of a flood water treatment system for the drinking purposes, and the electrochemical technique will be applied in the process. The system will be mobile, so it can be carried out to any location, any flooded area.
I'm Hafiz Bakas, working as Assistant Manager in Motion Control Research Lab in CERAD, UET Lahore. Motion Control Research Lab conducts its research in the multidisciplinary and electromechanical projects, keeping in view the energy needs of the Pakistan. MCRL providing its services in the advanced green energy using efficient tools to design and develop the best products to fulfill the energy needs of the Pakistan. In this regard, we are working on the concentrated solar thermal power plants, in which we have designed and developed dual-axis solar tracking heliostats, dual-axis solar tracking parabolic dishes, and single-axis parabolic troughs, in which we will focus the sunlight onto the central focal point and then to rise the temperature of the water. After that, we will run the steam turbine to generate the electricity to eradicate the energy shortage of Pakistan. On the other hand, MCRL is working on the energy efficient electrical vehicles, in which we are working on the BLDC motor and its drive with the regenerative braking system. In the end, I would like you to visit our stall, and I would like to thank all of you to visit ICECE. Thank you. Parabolic trough is a type of solar thermal collector that is straight in one dimension and curved as a parabolic in the other two dimensions. The upper surface of a parabolic sheet is then lined with the polished metal mirror. The sunlight which enters the mirror parallel to its plane of symmetry is focused along the focal line, where the pipe containing the fluid with the high coefficient of thermal resistivity are positioned that are intended to be heated, which leads to produce steam from the water by providing the stored heat. Modeling and simulation were carried out on the SolidWorks and software, and analysis of its structural integrity, weight, wind load, resistance was successfully done on the SolidWorks and ANSYS simulation software. Single-axis solar tracking system has been implemented on the PLC, and data has been integrated for the whole year. This single-axis solar tracking parabolic trough rotate in 120 degree in elevation for the sun tracking with the.
Thank you very much, Dr. Saab. I just warmly welcome you all to the virtual exposition of the projects that are being done at Center for Energy Research and Development. Just to name a few, we have
Alternate Energy Research and Innovation Lab. We have battery capacity testing in accordance with IEEE standards. These are some of the projects that are being done under the flagship of Aerial Lab. We have Solar Testing Lab. We have cleaning robot, which is used to clean the solar panels. We have LED testing lab. We have got training in renewable energy sector, and to name a few. So to begin with, I would humbly request Mr. Imran Ali Shah to please come up and share his thoughts, also his team members, and what is happening exactly in the Aerial Lab. So ladies and gentlemen, let's put your hands together for Imran Ali Shah Sahab.
Assalamu alaikum. My name is Imran Ali Shah. I am managing lab Al-Khwarizmi Institute of Computer Science and also providing services in Center for Energy Research and Development, which is a state-of-the-art research and testing facility located in the new campus of University of Technology Lahore, Kala Shah Kaku. We are providing different kind of services like consultancy services, third-party validation services, energy auditing services, and we have some kind of research projects from technology development program from HEC and also NRPU program, and we are also providing training services in related to energy sector. We are providing consultancy services to the energy department. In this consultancy, we are providing energy auditing services for 40 DHQs located in 36 districts of all over the Punjab. Funded project we have done recently in HEC installed 55 kilowatt solar system and search the behavior of the variety of the irradiance and the angle that can impact on the energy generation. Secondly, we have some TDF projects. We have developed a cleaning robot that would be very effective to save the water and provide the high efficiency of the system. And we are also working on TDF project funded by the HEC. This project is, you can say that it's a municipal energy. We can convert the plastic waste, the medical waste that is very harmful for the people, and we can convert this plastic waste to energy by using some nanoparticles that we are developing in our lab. And this project we are developing with the help of JV partner from NCP Islamabad. And we are providing training services with NAVTEC, that is the federal government department, and same is we are also doing with the Punjab Skill Development Fund program. Testing services, we have developed one of the state-of-the-art lab in PV testing lab in Kala Shah Kaku campus, and we have developed LED testing facility over there. We have state-of-the-art facility available, which is one of the largest and one of the best facility available. Recently, we have done a project in Karachi University, ICCBS, and installed 1 megawatt solar system. The same is the case. We have provided technical services to the University of Indian Technology Lahore, the PD department, for installing 1 megawatt, which is the first ever PPA project in the public sector institution.
Assalamu alaikum. Battery has been a critical component in energy storage, especially with PV systems, and has been often misquoted by the suppliers by forging the actual values of battery systems. Battery tester is a cost-optimized solution which can help estimate the battery capacity with higher precisions and validate the claim of rated values, which leads to the better system design and ultimately helps to reduce the risk associated with battery backup systems.
Assalamu alaikum. I am Karatul An, working in Energy Lab in Al-Khwarizmi Institute of Computer Science, UET Lahore. With the increment of PV integration in the energy mix of Pakistan, an underlying problem faced is the cleaning of solar PV modules. Currently, our market is not addressing this problem properly, and the soiling problem reduces the energy generation hugely. Therefore, a localized and efficient solution is required to fill this gap in the market. A self-cleaning robot for PV modules has been developed and designed by our team under HEC TDF. Our robot solution not only reduces the time, but also water and labor needed for cleaning tasks, and it increases the energy generation by an approximate 5%. The activity of this device can also be controlled remotely through GSM or ZigBee. The payback for our robot solution spans over 12 to 18 months with an expected life of minimum 5 years.
The light testing services that we have in CERAD are the electrical and photometric test, chromaticity test, harmonic current emission test, impulse test, LED driver test, salt supply test, IP and IK test. The electrical and photometric test used to determine the luminous intensity, luminous efficacy, light distribution diagram, and the other electrical parameters. For that purpose, we are using the gonio spectroradiometer, that is a D-type gonio for near field detection, and we also have a C-type gonio that's used for the near field and far field detection. IES files also produced using this setup, which is further used for the simulation of lightning models. The integrated sphere is used for the chromaticity test, in which the color rendering index and the correlated color temperature were measured. Harmonic current emission test is also done using the power meter that is integrated with this integrated sphere, and it can determine the harmonics of the current and voltages. We have a temperature and humidity chamber which will use for the damp heat and environmental test. In IK test, an impact of 5 joule is applied on the luminaire body at different points to assess its withstand capacity. We are offering following tests in CERAD. Few of them are the determination of real power at STC condition using the sun simulator that can emit a light of 1000 watt per meter square at a temperature of 25 degrees C, and air mass is set at 1.5. IV and PV curve also determined using the sun simulator. Another test that we have is the EL test, that is named electroluminance test. EL test setup capture the image of the PV module, whose quality is assessed to detect the cracks and defects on the PV module. Bypass diode test is also used for the PV module. Bypass diode thermal test is used to assess the adequacy of the thermal design and long-term reliability of bypass diode. Another test that we have is the ultraviolet preconditioning test. Ultraviolet preconditioning test is used to identify the degradation of the PV module material through ultraviolet radiations. Module breakage test is also applied to the PV module to determine the strength of the PV module, and mechanical load test can determine the ability of the PV module to withstand the mechanical load and stress.
Assalamu alaikum. My name is Mohammad Latif and I'm working as a research assistant in Alternate Energy Research and Innovation Lab, UET Lahore. In addition to that, I'm also working as an instructor for PSDF and NAFTA courses. The ultimate aim of these courses is to target the renewable energy sector. In renewable energy sector, they target solar, they target wind, they target geothermal, and they target hydel. The main focus of these courses is to create employable market and students efficient so they can create their own startups and create jobs in the market. Last but not the least, one of the ultimate aims of these courses is to enhance the R&D sector and to make them self-sufficient so that they can pursue their careers and they can start their masters and PhD, and they have the prerequisite knowledge to pursue their higher education.
Thank you very much, Mr. Imran Ali Shah and team. So, ladies and gentlemen, this was Mr. Imran Ali Shah, Senior Manager, Alternate Energy Research and Innovation Lab. So, quickly moving forward, we have Mr. Muhammad Ali lined up from Energy Efficiency and Conservation Lab. Let's see what Mr. Muhammad Ali has to share with us.
Assalamu alaikum. My name is Muhammad Ali and I am working as Senior Research Manager at Al-Khwarizmi Institute of Computer Science and also providing support to CERAD labs. We are working on various energy efficiency related projects, especially related to the industrial sector. We started off with the energy efficiency course funded by GIZ Germany, where we have senior level people from industries coming over on weekends to get hands-on training. We also developed a motor testing system based on IEC standard. The motor tests the running efficiency of induction motors, which is very important in decision making for motor replacements or making improvements. We won a project from UNIDO for sustainable energy initiatives for Pakistani industries, focusing on paper and pulp and ceramics sector. We won a TDF project from HEC on solar inverter development. It's very essential for us to get these products developed in Pakistan for customized needs, preserve foreign exchange, skill development, and job creation for local engineers. We won funding again from HEC for pump testing system development. The system tests the efficiency of centrifugal pumps, giving a lot of benefits to its users. We are working very closely with PICA for establishing AC testing lab at CERAD, Kalashakaku campus. The lab will test energy efficiency ratio and coefficient of performance of air conditioners, in addition to various other parameters mentioned on the nameplate. We are also offering short training courses on energy efficiency, programmable logic controllers, industrial instrumentation in cooperation with NAVTTC and other funding agencies.
This project tends to determine the efficiency as well as the pump curve of pumping system. In any industrial or commercial facility, we can determine the pump curve from ratio of flow rate and the head of the pump. This solution gives us the real-time efficiency data of pump of industrial or commercial systems. The test bench duly equipped with PLC, programmable logic control, and a VFD, variable frequency drive, from which we can change the speed as well as the technical parameters of pump as per demand. All parameters and real-time data are displayed on a HMI screen. This demo test bench contains 1 HP motor of 3-phase power. This project has been awarded from HEC through TDF Technology Development Fund. Thank you very much.
The project is to develop an economizer to control and automate the pigmentation of leather skin with minimal pigment waste at less cost. This system to automate the leather spraying process is locally developed and presented for the first time in Pakistan leather sector with high precision and calibration. It immediately becomes mature and has been installed on various finishing plants across the country. And how it is working, the leather skin are placed on the conveyor of the leather machine and pigment coating is done by solenoid spraying guns placed on carousel. Economizer detects the speed of the conveyor and carousel and convert the area of the leather skin into the digital format using IR scanner. After computation of calculation, it directs the guns to perform the efficient spraying. It also provides the user-friendly interface and flexibility in adjusting the parameters required for the process. And what is more, the system at the end of the working day gives you more than the 25% saving, thus entirely repaying itself within a few months.
Thank you very much, Mr. Muhammad Ali and his team. So ladies and gentlemen, this was Mr. Muhammad Ali from Energy Conservation and Efficiency Lab. So we have got to know about so many ideas that how we can conserve energy. As far as coal energy is concerned, we have so many renewable energy sources, and role of energy is very much crucial and is of paramount importance. So let's quickly moving forward, let's see what potential we have in the coal industry we have. As long as I know, we have 70% of the coal that is lignitic, which is not usable for energy creation. So how can we make our coal very effective and usable so that we can get some energy out of it? We have Mr. Badr, ladies and gentlemen, Dr. Badr with his project. So let's just put your hands together for Mr. Ladies and gentlemen.
Pakistan is faced with energy crisis due to shortage of 7 gigawatts of electrical energy. 65% of the electrical energy is produced by thermal resources, among which coal is the cheapest. This makes it inevitable for us to move towards coal power generation. However, the problem is, in Pakistan, the coal quality is very low, so we need to process it to make it suitable. Here, our facility, Mineral Processing Research Center at Mining Engineering Department, University of Engineering and Technology, Lahore comes in. We collected samples of 32 million tons of Punjab coal and 130 million tons of Khyber Pakhtunkhwa coal. We processed it through crushing, grinding, flotation and gravity separation, and we have made it suitable for power generation. In addition to this, we are also committed towards renewable energy storage. For this, we are recycling printed circuit boards and mobile batteries to extract the raw material for lithium-ion batteries manufacturing. For printed circuit board recycling, we are using shaking tables, electrostatic separators, magnetic separators, and leaching. While for mobile batteries, we are sticking to crushing, screening, and smelting.
Thank you very much, Dr. Badr. So ladies and gentlemen, this was Dr. Badr, who was exactly letting us know about the potential we have in the coal side. We have lignitic coal, but how can we make it at least close to bituminous and anthracite coal? So Dr. Badr was giving us an insight about it. So quickly moving forward, we have Dr. Tabish with us, and Dr. Tabish has to say a few words regarding mineral processing role, how mineral processing is used in energy creation. So ladies and gentlemen, let's welcome Dr. Tabish.
Assalamu alaikum. My name is Dr. Tabish. I'm working as assistant professor in Chemical Engineering Department, UET Lahore. Every year, millions of lives are lost because of drinking contaminated water. Availability of clean drinking water is a basic human right, and the water contains several pollutants including physical, chemical, and biological. Biological contaminants are the most concerned one because they contain microorganisms, and those microorganisms will lead to several diseases and at the end casualties. There are several techniques to disinfect the microorganisms, and those techniques include ultraviolet radiations, reverse osmosis, chlorination, and ozonation. Reverse osmosis is a versatile technique, but it's expensive to buy and difficult to operate. And ultraviolet radiations, they have technological limitations because of the transmission limits of the ultraviolet radiations within the turbid water. Ozonation and chlorination, they produce disinfection byproducts, and disinfection byproducts, they are harmful in the treated water. We are working on another technique, that is chemical disinfection. Electrochemical disinfection works on the principles of electrochemistry. On the electrodes, electrons are generated, and these electrons directly disinfect the microorganisms. Alternately, several chemical radicals are produced, and these radicals include hydroxyl radicals, ozone and oxygen radicals. And when microorganisms come in contact with these radicals, they become hibernate and disinfect. The overall electrochemical disinfection system, it contains pre-filtration process, electrochemical disinfection process, and the post-filtration process. Pre-filtration is to ensure the removal of particles that are more than the micron size. Electrochemical disinfection removes the microorganisms, and post-filtration is to remove the dead bodies and also to polish the treated water. This electrochemical technique against the competitors, it offers several advantages. For example, the low cost, environment compatibility, easy to operate, and their preservative effect in the treated water. Major target of this project is the underdeveloped and developing countries, especially the low income communities of Pakistan. In the flooded areas, the flood water contains all these microorganisms, and in the flood time, it becomes very difficult to supply the drinking water. We are working on the development of a flood water treatment system for the drinking purposes, and the electrochemical technique will be applied in the process. System will be mobile, so it can be carried out to any location, any flooded area.
Thank you very much, Dr. Tabish, for being with us. Ladies and gentlemen, quickly moving forward, we have Mr. Jamshed Janjua with us, who is ready with this project. How can you safeguard the national grid? That is need of the hour and a very critical issue. This issue is to be addressed by Mr. Jamshed Janjua with his team and with his expertise. So let's see what he has to say.
My name is Jamshed Iqbal Janjua, and I'm working as a Senior Manager Research at Al-Khwarizmi Institute of Computer Science. I work at the Power Systems Lab, and we focus on the research areas in the energy sector and the power sector related environments. And we work with the NTDC, CUPA, and different DISCOs in Pakistan to solve the problems related to the power sector and energy sector with some indigenous capacity building and software development and IT-based solutions. So we have developed a project named Unmanned Grid Control and Monitoring System. This project was a joint initiative with between NTDC and MAPCO, and it was funded by MAPCO as well. So the focus of this project is to control the monitoring and the grid control monitoring system mechanisms of the concerning DISCO. The system comprises of the two main parts. The first part is the hardware devices, which are responsible for the data acquisition and the control system, whereas the other part is the web portal. And this project is totally developed from the hardware to the PCB design, hardware, the firmware level, and the data acquisition systems, and then the portal in Al-Khwarizmi. The overall mechanism of this project is first of its kind, and it is deployed on the 11 kV feeder panels on the grid stations, 220 kV, 500 kV, and 66 kV grid stations of MAPCO. And the hardware devices detect the faults and sends the information via GSM and GPRS medium to the concerning control room. And then there is an interactive dashboard for the web portal. From here, the concerning grid control operators can actually manage the grid and different kind of alarms and faults based upon
and the transformers deployed in the grid stations are available in real time for the efficient management of the grid station. We have developed a project for the data communicator development for the grid control and monitoring systems. In this project, we have focused on reducing the communication cost that occurs when we collect data from the grid stations and relay it to the backend servers. So in this overall activity, the hardware was focused, and we have developed a data communicator that actually communicates with the local devices on the grid station and acquires the data through the Wi-Fi, and then after a certain interval of time, the data is being relayed in a mechanism to the backend servers. And from those backend servers, we have dashboard available and a portal available, upon which there is a dashboard that can actually help to see the faults occurring on the transformers and on the feeders, incoming and outgoing feeders of the 132 kV, 220 and 500 kV grid stations. And the grid control operators can actually control the different functions of a grid station. They can turn off the grid, they can turn on the certain line, and they can manage the load shedding management on this grid, on the concerning grid station. This project was funded by USAID through the USPK centers, energy centers in Pakistan. The project is being now routed to be deployed at the grid stations of PESCO and the TESCO area, so that we can drive most of the benefit for the remote side configuration and the remote side controlling of the grid system.
Thank you very much, Mr. Jamshed Janjua. Ladies and gentlemen, let's quickly moving forward. You might have heard about heliostats concept that is exactly used to converge solar light and to translate into energy. So how heliostats are used and how it is becoming popular in Pakistan, we have Mr. Hafiz Waqas with us. Let's see what Hafiz Waqas has to say with us.
I'm Hafiz Waqas, working as Assistant Manager in Motion Control Research Lab in CERAD, UET Lahore. Motion Control Research Lab conducts its research in the multidisciplinary and electromechanical projects, keeping in view the energy needs of the Pakistan. MCRL providing its services in the advanced green energy using efficient tools to design and develop the best products to fulfill the energy needs of the Pakistan. In this regard, we are working on the concentrated solar thermal power plants, in which we have designed and developed dual-axis solar tracking heliostats, dual-axis solar tracking parabolic dishes, and single-axis parabolic troughs, in which we will focus the sunlight onto the central focal point and then to rise the temperature of the water. After that, we will run the steam turbine to generate the electricity to eradicate the energy shortage of Pakistan. On the other hand, MCRL is working on the energy efficient electrical vehicles, in which we are working on the BLDC motor and its drive with the regenerative braking system. In the end, I would like you to visit our stall, and I would like to thank all of you to visit ICECE. Thank you. Parabolic trough is a type of solar thermal collector that is in one dimension and curved as a parabolic in the other two dimensions. The upper surface of a parabolic sheet is then lined with the polished metal mirror. The sunlight which enters the mirror parallel to its plane of symmetry is focused along the focal line, where the pipe containing the fluid with the high coefficient of thermal resistivity are positioned that are intended to be heated, which leads to produce steam from the water by providing stored heat. Modeling and simulation were carried out on the SolidWorks and simulation software, and analysis of its structural integrity, weight, wind load, resistance was successfully done on the SolidWorks and ANSYS simulation software. Single-axis solar tracking system has been implemented on the PLC, and data has been integrated for the whole year. This single-axis solar tracking parabolic trough can rotate in 120 degree in elevation for the sun tracking with the accuracy of 0.02 degree. Thank you. Programmable logic control, PLC, or a programmable controller is an industrial digital computer which has been ruggedized and adopted for the control of manufacturing process, such as assembly lines or robotic devices, or any activity that requires high reliability, ease of programming and processes. PLCs can range from small modular devices with tens of outputs and inputs in a housing integral with the processor, to the large rack-mounted modular devices
with the count of thousands of IOs and which are often networked to other PLC and SCADA systems. So we have developed the prototype of PLC trainer for the new graduates to have a good experience before getting into the practical industrial application. PLC trainer prototype has been designed and developed. Application manual of PLC trainer is ready for the trainer classes and educational institute. Radar is a detection system that uses radio waves to determine the range, angle, or velocity of the objects. It can be used to detect aircrafts, ships, spacecraft, guided missiles, motor vehicles, weather information, and trains. A radar system consists of a transmitter producing electromagnetic waves in the radio or microwave domain. A transmitting antenna or a receiver antenna is used for transmitting and receiving, and a receiver and processor to determine the properties of the objects. Radio waves from the transmitter reflects the object and return to the receiver, giving information about the object's location and speed. Modeling and simulation of this structure was carried out on the SolidWorks and ANSYS simulation software. Analysis of its structural integrity, weight, and wind load resistance was successfully done on the SolidWorks and ANSYS simulation software. Fabrication and integration of a main structure and slew drive is completed and deployed at the electrical department of UET Lahore. Dual axis tracking system of this radar is capable of 360-degree rotation on azimuth and 180-degree elevation for the active tracking system with the accuracy of 0.02 degree. Thank you. Dual axis solar tracking heliostats is one of the types of the concentrated solar thermal power plants which harness the solar radiation energy, produces the electricity by heating up the working fluid to drive the engine and the turbine. Because the solar radiation is too low to heat up the working fluid, heliostats comes in to concentrate the solar radiation to rise the temperature even up to the 500 degrees centigrades. The purpose of the dual axis slew drives is to enable the mirrors to accurately track the sun throughout the day with the aid of the computer control system, and it can accurately track with the accuracy of 0.1 degree, and it can rotate in 360 degree in both azimuth and elevation angle. MATLAB and SolidWorks were used to calculate the position and angles of the sun at a specific time each day. That is why this type of tracking system can accurately track the sun in both east-west and north-south axis. Modeling and simulation of this project is done in the SolidWorks, and analysis of its structural integrity, weight, and wind load resistance was successfully done in the ANSYS simulation software. Dual axis solar tracking has been implemented in PLC, and data logging for different days of year is taken and verified.
Ladies and gentlemen, this concludes the exhibition. I hope you enjoyed it. Take good care of yourself and have a good day.